OK, welcome back, everyone, to web programming with Python and JavaScript. And today we turn our attention to the second of the main programming languages that we'll be looking at in this class, in particular, JavaScript. And to get an understanding for why it is that JavaScript is actually helpful, let's go back and revisit this diagram of what communication over the internet will generally look like. Oftentimes, we'll have a user, otherwise known as the client, using their computer on their web browser, whether that's Chrome or Safari or some other web browser, that sends an HTTP request, a web request, to some sort of web server. That server then processes that request and then returns some sort of response that comes back to the client. Thus far, all of the code that we've written, the Python web application code running in a Django web application, for example, has all been code that runs on some sort of server, code that is listening for requests, doing some computation in order to process that request, and then generating some sort of response, usually in the form of an HTML template that we then send back to the client. What JavaScript is going to enable us to do is to begin to write client-side code. JavaScript is going to allow us to write code that actually runs inside of the user's web browser on the client. And this can be useful for a number of reasons. One, if there's computation that we want to do, but we don't need to go out and reach out to a server in order to do so, we can do the computation potentially faster just by running the code exclusively on the client. And in addition to that, we can begin to make our web pages a whole lot more interactive. JavaScript is going to give us the ability to directly manipulate the DOM, where again, the DOM is the document object model, that tree-like hierarchy that represents the web page that the user happens to be looking at. So JavaScript will enable us to write code that directly manipulates the content on the web page, and we'll see how that can be quite powerful very soon. So how do we then use JavaScript inside of a web page in order to add some code, add some programming logic to a web page? Well, so far, we've already seen HTML, the language we use to describe the structure of a web page, where an HTML page just describes the structure of a page in terms of nested tags. We had those head tags at the top of the page, the body tags that describe the structure of the page, and then additional tags that could be nested within those. And in order to add JavaScript to a web page, it's as simple as including some script tags that are often located inside of the HTML page itself. When we use these script tags, we're telling the browser that anything in between these script tags should be interpreted, in this case, as JavaScript code that the web browser is then going to execute. So our very first program, for example, might just look like a line of code inside of those script tags, something like this, where alert, for example, is the name of a function that's going to produce an alert. And then, just as with functions in Python, functions in JavaScript can take arguments. So in between these parentheses, we have an argument, something like the string hello world, the text that we would like to display to the user. So let's go ahead and give this a try and see how we can actually use this code to write JavaScript that is going to run inside of the user's web browser. I'll go ahead and create a new file that we'll call hello.html. And inside of it, I'll include the same basic HTML structure that we've already seen before, where I have a head section that has a title, and then a body that maybe just says hello, for example. And so now what I'd like to do is add a little bit of JavaScript to this web page. So in the head section of my web page, I'm going to go ahead and add a script tag, where in between these script tags now, I can write JavaScript code that is going to be written in JavaScript that will run inside of the web browser when the user actually opens up this page. And for now, I'll just say alert and then hello world. It turns out in JavaScript, you can use either single quotation marks or double quotation marks in order to represent strings. I'll generally use single quotation marks here just by convention. So here I'm running a function called alert that's going to display an alert, something like hello world to the user. And that's going to be inside of the script tags of this HTML page. So now, if I want to actually open the page up, I can open hello.html, or you could just visit it inside of your web browser, whether it's Chrome or something else. And now at the top of the page, what you'll notice is that I get a little bit of an alert, some interaction where it says this page says hello world, and it gives me an option to like press a button, for example, like hello, like the OK button that'll say, all right, dismiss the alert now. And this is our very first example of JavaScript. We have a function called alert built into JavaScript for our web browser. And our web browser knows that when we call the alert function, the browser should display an alert message that looks a little something like that. And if I click the OK button to dismiss the alert, then we go ahead and get back the original page that I had from the beginning. And so now we can begin to imagine that using this ability to programmatically display alerts, that we can add additional features to our applications as well. And one big area where JavaScript can be quite powerful is with event-driven programming. And what event-driven programming is all about is thinking about things that happen on the web in terms of events that happen. What are some examples of events? Events are things like the user clicks on a button, or the user selects something from a drop-down list, or the user scrolls through a list or submits a form. Anything the user does can generally be thought of as an event. And what we can do with JavaScript is add event listeners or event handlers, things that say, when an event happens, go ahead and run this particular block of code, or this function, for example. And using that, we can begin to allow our JavaScript code to respond to how the user is actually interacting with our web page, to say, when the user clicks on a button, I would like to run this particular JavaScript function, for example. So let's go ahead and give that a try. I'll go ahead and now, instead of just saying alert hello world, let me put this alert inside of a function. And to create a function in JavaScript, you just use the keyword function, followed by the name of the function. I'll call the function hello, for example. And then in parentheses, any inputs that function takes. This hello function is not going to take any input, so I'll just use an empty set of parentheses. And then inside of curly braces, I include any of the code that I want to run in this function. And so what I've done here now is create a function called hello. And then inside of the curly braces, I've defined the body of the function, what code should run when I run the hello function. And what the hello function should do is it should display an alert that in this case says hello world. So now what I'd like to do is get this function to run when something happens on the page. For example, when a user clicks on a button. So to do that, the first thing I'll need to do is actually create a button. So I'll add a button that just says, like, click here, for example. So now if I refresh this page, I now see that I have hello, and I also have this button that says click here. But when I click here, like, nothing happens. I'm clicking the click here button, but it's not changing anything, because I haven't yet said what should happen when the user does click on this button. And so one way we could do this is by adding an attribute to this HTML element called onClick. What this is going to do is it's going to add an onClick handler to this button. It's going to say what should happen when the user clicks on this button. And I'm going to set the onClick attribute equal to running the function hello. And in order to run a function in JavaScript, just as you ran a function with Python, you use the name of the function followed by a set of parentheses to say, go ahead and actually run this function. Using those parentheses calls the function, another word for running the function. And the fact that there's nothing in between the parentheses means we're not providing anything as input to the hello function. Though if the hello function did take inputs, we could certainly add that in between the parentheses. So now I've tied the two pieces of this page together. I have a button that says click here. And I've added an onClick handler that says that when you click on the button, you should run the hello function. And then up above, I've defined the hello function to say, what should the hello function do? Well, when the function is called, we're going to display an alert that in this case says hello world. So now we should be able to refresh the page. We still see the same thing, at least initially, where it just says hello and a button that tells me to click here. But now, if I go ahead and click the button that says click here, well, then I get the alert that says this page says hello world. I can press OK. And this event handler is always going to work. I click the button again, and I get the alert a second time. Because every time I click the button, it's going to call the hello function again. And when I click when the hello function runs, it is going to display this particular alert. So this now appears to give us a fair amount of power. And much as in other programming languages, languages like Python or other languages you might have worked with, JavaScript has all of these same types of language features. So far, we've seen data types, things like a string, but we also have other data types that we'll take a look at soon too. We've seen functions, some functions that are built into JavaScript, like the alert function, and other functions that we can write for ourselves, functions like hello. But we also have the ability to include things like variables inside of our program as well. So what might that look like? Well, I'll go ahead and create a new file that we'll call counter.html. And counter is going to have some of the similar code to hello. So I'll just go ahead and copy it for now. But I'll clear out the script section, change the title from hello to counter. And now, inside, I'll get rid of the button. Or actually, I'll keep the button. But instead of saying click here, the button is going to say count. I'd like to create a program that just counts for me from 0 to 1 to 2, 3, 4, so on and so forth. And now, in order to do that, in order to have some way of counting repeatedly 0, 1, 2, 3, 4, 5, I'm going to need to have some sort of variable inside of my program, something that is keeping track of data, like the number that I'm currently have counted to. So in order to do that in JavaScript, I can say something like let counter equal 0. This is the way in JavaScript that I define a new variable. I first say let counter, meaning let there be a new variable called counter. And I'm going to initially set the value of counter equal to the number 0. And now when I click on the button, instead of running the hello function, I'm going to go ahead and run the count function, which doesn't exist yet, but I'll now write it. I'll define a function called count. And what the count function is going to do is it is going to first increment the value of counter. And a number of ways I could do that. One is by saying counter equals counter plus 1, to say go ahead and reset the value of counter to whatever counter is plus 1. And there are a couple of shorthand notations for this. I could equivalently say counter plus equals 1 to say add 1 to the counter. Or in the case of adding 1, JavaScript, much like languages like C, if you've seen them before, support notation like this, counter plus plus, which just means take the value of counter and increment it, add 1 to it. So I'll add 1 to the value of counter. And then I'll just display an alert that has whatever the current value of counter happens to be. And so I've incremented the value of counter and then displayed an alert that shows me what's contained inside of counter. And so now, if I go ahead and not go to hello.html, but to counter.html instead, I now see that I still see a button that says count. And if I click on that button, I get an alert that this time says 1. We've incremented the value of counter from 0 to 1. The alert now says 1, and I can press OK. If I press count again, the count now goes to 2. I press OK, press count again, it goes to 3. And every time I click count, it is going to increment the value of the variable counter inside of my JavaScript web page. And then it's going to display an alert that is going to contain the value of that variable. So using alerts now, we're able to manipulate, we can inside of functions manipulate the values of variables and then display alerts that show the contents of those variables. But ultimately, when users are interacting with the page, it's going to be fairly annoying if the only way that we have to interact with the user is via displaying these alerts, the equivalent of like printing something out, except instead of printing it to a terminal, we're printing it via an alert that appears on the screen. What would be more interesting and more powerful, and much more useful in the context of a web page, is if we could programmatically update the website, change something about the web page the user is actually seeing, changing the content that happens to be on the page. And turns out JavaScript is going to enable us to do that as well, because JavaScript allows us to manipulate the DOM, the document object model that represents all of the elements that happen to be on that page. So to do that, let's go ahead and return to hello.html. This, again, was this web page that just said hello and gave me a button where if I clicked on that button, it would display an alert that said hello world. Now what I'd like to do is instead of having the hello function display an alert, I'd like to have it manipulate something on the page. And what might I want it to manipulate? Well, inside the body of the page, I here have this heading that just says hello, for example, which is inside of an h1 element. And what I might like to do is actually change that element. How can I do that? Well, it turns out that in JavaScript, we have access to a function called document.querySelector. And what document.querySelector is going to do is it is going to give us the ability to look through an HTML page and extract an element out of that page so that we can manipulate that HTML element using JavaScript code. And so if I want to select like an h1 element, I can say document.querySelector. And then as the argument, the input to document.querySelector, I'll go ahead and say h1, meaning go through the page, find me an h1 element. And querySelector is only going to return one element. So if there are multiple, it's going to return the first thing it finds. But here we only have one h1 element, so it's OK. I'm going to say look through this document, try and find an h1 element. And when you do, I'd like to manipulate it. And the way I'd like to manipulate it is by saying .inner HTML equals, let's say, goodbye, for example. So all right, what's going on here? Well, right now, initially, when we first load the page, we have an h1, a big heading at the top that just says hello. And now when this hello function is called, which is called when this button is clicked on, because it has an onClick attribute that is equal to hello, calling the hello function, what the hello function is going to do is it's going to say document.querySelector h1. Find me the h1 element. That will return this element right here, a JavaScript representation of this HTML element that is just an h1, whose HTML inside of it says hello. And if I want to change that HTML, I can do that by modifying the inner HTML property of the JavaScript element. In order to update a property of anything in JavaScript, we'll generally use this dot notation, where dot acts as a property of some particular object. And so I have this element, this h1, and saying dot inner HTML means take that element and access its inner HTML property, some property of that object. And I would like to update its inner HTML to just, in this case, be the word goodbye, followed by an exclamation point, for example. So now what we'll see is that when we run this page, when we open this page up, as by opening up hello.html, I still see an h1 that says hello. I still see a button that says click here. But now, when I actually click on the button, click here, you'll see that hello changes to goodbye. We've run JavaScript code that finds an h1 element on the page and manipulates it, changing it to something else than it was originally. Now, every time I click here, nothing else happens, because every time I click here, it's going to find the same h1, and it's going to update its HTML, changing it from hello to goodbye. So maybe what I'd really like then is the ability to toggle back and forth between hello and goodbye, rather than just change it from one thing to something else. Every time I click the button, I'd like it to alternate back and forth. And there are a number of ways you could imagine doing this. But one way is by taking advantage of conditions. So much in the same way that a language like Python has conditions, ifs and elifs and elses, JavaScript too has if and else that allow us to describe conditions such that we can only run certain blocks of code when a particular Boolean expression is true, for example. So what would that look like? Well, let's go ahead and say, inside of this hello function, I can ask a question. If document.querySelector h1's inner HTML is equal to hello, we'll then go ahead and set it to goodbye. And else, then go ahead and update the inner HTML of this h1 element. Go ahead and set it to hello instead. So what is this hello function doing? It's now a little bit more sophisticated. It now has a condition where I say if, the keyword if, followed by in parentheses, the condition that I want to check for, the thing I want to see, is this true or not? And what I'm checking for is let me run document.querySelector h1, which again looks through the page, finds me the h1 tag, and gets that element for me. If I look at that inner HTML, if it is equal to hello, then I want to do something. And this triple equal sign here is JavaScript's way of checking for strict equality, checking to make sure that two values are equal and also that their types are the same thing, that if this is a string, this must also be a string. It turns out in JavaScript there's also a weaker way to check for equality that just uses two equal signs, and that is going to check that values are the same, but it's going to allow for a bit of differences in type. The two things might have different types, but so long as they're basically the same value, the double equal sign might generally come to be true. Usually, if you can, you'll want to use this triple equal sign, this strict equality, to make sure that not only are the types the same, but the values are the same too. And the triple equal sign will check both of those things. So if I go ahead and find the h1 element, and its inner HTML is the word hello, we'll then go ahead and find the h1 element and update its inner HTML, setting it equal to goodbye, for example. And else, go ahead and find that same h1 element, update its inner HTML, set it equal to hello. And again, just as in functions, where we use these curly braces to enclose the body of the function, all of the lines of code that are inside of the function, JavaScript does the same thing too. That inside of a condition, when we want to express that this is inside the body of an if condition, I can use curly braces to say this line of code and that line of code, that's inside of the if expression, or that's inside of the else expression, for example. So let's go ahead and try this now. I can go ahead and open hello.html. Refresh it. It currently says hello with a button that says click here. And now, when I click here, hello changes to goodbye. And when I click here again, goodbye changes back to hello. And every time I click the button, it's going to alternate between hello and goodbye, because we either get caught in the if expression or we get caught in the else expression. Now, there are a couple of places where you might look at this and notice that maybe this isn't as efficient as this code could potentially be. And recall that every time we run document.querySelector to say, go ahead and try and find a particular HTML element for me, it's going to look through that page trying to find the h1 element. And it turns out that right now, we have 3 separate calls to querySelector, even though only 2 of them will ever run on any given instance of the function. But we call document.querySelector, then we call it again inside of the if expression. We can probably improve the design of this page by factoring that out, by just looking for the h1 element once and then manipulating it and checking it using that element that we have found. And to do that, we can store an element inside of a variable. In the same way that a variable can store a number, like a counter, or a string, like hello world, it can also store other values, like an HTML element that we get back from document.querySelector. So I could say something like, let heading, where heading is just the name of a variable, be equal to document.querySelector h1, for instance. Find the h1 element, save it inside of a variable called heading. And now, rather than document.querySelector h1 all the time, I can just say, if the heading's inner HTML is hello, then set the heading's inner HTML to goodbye. Otherwise, set the heading's inner HTML to hello. So I've improved the efficiency of the program, but also reduced the number of characters of code that I've had to write. My lines are now much shorter, a little bit easier to read. This we would consider to be an improvement in design. And it turns out there's one other improvement we can make here, too, that we can define a variable like let something equal something else. But it turns out that JavaScript gives us a couple of ways to define a variable. And if we're going to be creating a variable whose value is never going to change, we're never going to reassign the variable name to something else, then instead of let, we can enforce that it's never going to change by calling it a const variable. So const heading equals document.querySelector h1 means I am going to create a variable called heading, setting it equal to the result of document.querySelector h1, and never again will I change what heading is equal to. I will never have another line of code that says heading equals something else because it is constant. And JavaScript will then enforce that this variable should not change. And if ever I do try to change it, JavaScript will give me an error. And this can just be helpful to prevent against possible unintended behavior. That if you know you have a variable that is never going to change, it's often good design to label it as a const variable so that you and other people looking at your code know that that is never going to have a value that gets changed later on. So this then will behave the same way, where it says hello, but I can toggle it back and forth, changing it to goodbye, and then changing it back to hello again. And so now using this ability to manipulate the DOM, we can go back to our counter program and actually improve upon it. That right now, the counter program, I count and it displays an alert that says 1. I count and it displays an alert that says 2. I can probably do a little bit better than that by, instead of displaying an alert, actually manipulating the DOM in some way. That I would like to have this h1, this big heading at the top, instead of starting out by saying hello, let's have it start out by saying 0, for example, just some initial value for the counter. And now when I increment the value of counter, rather than display an alert that just tells me the value of the counter in an alert, I'm going to instead say document.querySelector h1 inner HTML equals counter, where I'm saying find the h1 element, update its inner HTML, set it equal to whatever the value of the variable counter happens to be, such that now if I refresh this page, the value of this h1 initially is 0. That's the initial value. But every time I click count, we're going to update the contents of that h1 element, this time setting it to 1, 2, 3, 4, and so forth. Every time I click the count button, it's going to increment the value of the variable as well as manipulate the DOM, actually making changes in order to produce the effect that I want to see on this actual page. And we can begin to add additional logic to this as well. Maybe I do occasionally want an alert, but I don't want an alert every single time. I could add a condition. I could say something like, if I only want to display an alert every time I count to a multiple of 10, like 10 and 20 and 30 and 40 and 50 and so forth, I could add a condition that says that if counter mod 10, and mod just gets me remainder when you divide by 10. So if you take the counter, divide it by 10. If the remainder is 0 when I divide by 10, well, that means counter is a multiple of 10. And so I can now display an alert where I can display an alert that says, like, I want to say something like, the counter is now 10, or the counter is now 20. And in order to do that, what I really want to do is have some way of plugging in a variable into a string inside of JavaScript. And in Python, the way we would have done this is by appending f, or prepending f in front of the string to create a formatted string. And then I would have said something like the count is now, and then I'd use curly braces to say, go ahead and print out the value of counter. So this f for formatted string followed by this string would have been the way in Python that we would have done this. Turns out JavaScript does the same thing, just with slightly different syntax. It doesn't use f. Instead of using the regular quotation marks, whether they're single or double quotation marks, JavaScript uses these backticks, which are usually located above the tab key on a standard US keyboard. And this is going to create what JavaScript calls a template literal, where I can then substitute the value of a variable somewhere inside of this template. And then in order to actually do the substitution, while Python uses double curly braces to say plug in the value of counter right here, JavaScript does something similar. It also uses double curly braces, but there needs to be a $ in front of it. The $ and then the double curly braces mean go ahead and plug in the value of a variable there. So this then is a template literal, where every time we get to a multiple of 10, we're going to display an alert that says the count is now. And then this $ curly brace means actually plug in whatever the value of counter happens to be right there. So now if I go ahead and refresh counter, it starts at 0. I can count 3, 4, 5, 6, 7, 8, 9. But when I get to 10, then I get an alert that says the count is now 10. And then I see the result update on the page. And so that template literal can allow us to combine variables and strings in order to generate new strings that are able to represent data inside of them as well. So now what improvements can we begin to make here? What changes can we make to this to improve upon the design of it? Well, one thing, especially as our programs get a little bit more sophisticated, a little bit more complicated, is that we often don't want to be intermingling our JavaScript code with the contents of our HTML. That down here, we have button onClick equals count, this name of this function. And especially as our page starts to get more complicated, it's going to start to get a little bit annoying if we're constantly having to maintain a little bit of JavaScript code, like making a call to a function, inside of our HTML. We'll see a little bit later. There are other paradigms that actually encourage this type of thing. But right now, it can start to get a little poorly designed, as we'd really like to separate all of our JavaScript-related code from all of the HTML, the general structure of our page. And so there are ways we can begin to do that as well. I can add an event listener inside of JavaScript too, that I can say something like document.querySelector button, and then I can say .onClick equals count. So what's going on here? And I can do this instead of this onClick equals count. What I'm now saying is document.querySelector button. Find me the button on the page. And turns out there's only one button here, so it's fine. Though if there were more, I might have to be a little bit more specific. But once I get that button, then I'm going to access its onClick property. And I'm going to set it equal to count. And what is count? Count is the name of a function. Count is itself a function. And so what I'm here saying is I would like to set the value of the onClick property of the button equal to count. The count is the function that should run when the button is clicked on. And notice that I am not actually calling the function. It's not count and then parentheses, which would mean run the count function and then get its return value and use that as the value for onClick. I'm just setting onClick equal literally to the count function itself without actually calling the function. And what this is going to do is it is going to say when the button is clicked on, then and only then should you actually run this count function. And we're not going to run the count function until that button actually gets clicked on. And so in JavaScript, functions can be treated as values of their own. Just as you can set a variable equal to a string, just as you can set a variable equal to an integer, just as you can set a variable equal to like an HTML element, like the result of document.querySelector, you can also set a variable equal to a function, something like count, and pass that around as a value, just as you could with any other value. And this is a paradigm we generally call functional programming, where we have functions as values of their own, things that we can reassign, things that we can manipulate, just as we could any other value. So now I can try and run this program by going ahead and refreshing the page. I'll refresh it. It's 0. I press count. And all right, nothing seems to be happening. It's still 0. I want it to be counting, but it doesn't seem to be working. So why not? Anytime you run into problems in JavaScript where you're not getting the behavior you want, often it can be helpful to look at the JavaScript console, where the JavaScript console is the equivalent of like the terminal window when you're running your Django application in Python that would display any error messages. The JavaScript console will display any of the JavaScript logging information and error messages as well. In Chrome, I can get to it if I first go ahead and go to Inspect, and then just open up the console tab here. And all right, we seem to have some sort of error here. It's an uncaught type error that says we cannot set property onClick of null in counter.html line 18. So that will generally tell you where the error is coming from. It's coming from counter.html on line 18. And the problem seems to be that I'm trying to access the onClick property of null. And null is JavaScript's way of expressing like nothing, some object that doesn't exist. So somehow I'm trying to set the onClick property of null. Well, let's see what's going on line 18 and see if we can figure out what's happening there. Well, all right, here's line 18, where I say document.querySelectorButton, setting its onClick property equal to count. And now what seems to be the problem here? Well, the error message was that I was trying to modify the onClick property of null. Well, here then is the onClick property. So why would this document.querySelectorButton be returning or giving me an output of null? Well, it turns out the document.querySelector will return null if it's not able to find something. If I try and find a button, but it's not able to find a button. Well, this seems a little bit strange because there's a button down here on line 24 that I'd like for my JavaScript code to be able to find when it runs querySelector and tries to find the button. As it turns out, this is a bit of the quirk of the way the browser is going to work. But if the browser is running our code from top to bottom, just reading it from line 1 on and on, then it's going to get to line 18, where I've said document.querySelectorButton.onClick equals count. And it's going to try and find a button on line 18. But the button doesn't show up in my HTML page until much further down in the page. So at this point, when we get to this line of JavaScript, JavaScript is looking for the button. But the DOM, the body of the page, hasn't finished loading yet. The content of the DOM has not yet loaded. And as a result, we're not able to find this button. So how do we solve this problem? How do we get it so we actually are able to like ask for the button and actually get the button? Well, it turns out there are a couple of strategies we could use. One would be take the script tag and go ahead and just move it to the bottom section of the body, so that after we've already defined the button that says count, then we have the script tag that then says, all right, go ahead and now find the button, and now we'll be able to find it. It turns out another way, and perhaps a more common way, is to instead add yet another event listener. And we're going to add an event listener not to the button, but to the entire document, where document is a variable built into this JavaScript that we have access to on the web page that just refers to this entire web document, where I've used document.querySelector already to look through the whole web document, trying to find a button or trying to find an h1 tag, for example. But I can also add an event listener to the document itself. And in order to do that, I can say document.addEventListener. And when I call addEventListener, and I can do this on any HTML element, not just the document, but I could run this function on a button or on an h1 element or any other HTML element, addEventListener will generally take two arguments, where the first is what event I want to listen for. The event could be something like click, when I click on the document. It could be something like when I scroll through a page, for example. But the event I'm going to listen for is a particularly special event called DOM content loaded. And the DOM content loaded event is an event that is going to be fired or triggered when the DOM, the document object model, the structure of the page, is done loading. When all of the elements on the page are done loading, the DOM content has been loaded. And then, if I attach an event listener to it, it'll run whatever code I want to run. That should only run after the DOM is fully loaded, after all of the content on the page has then been loaded. And the second argument to addEventListener is what function should run once the event actually happens, when the DOM content loaded does happen. So I could pass in the name of a function if I had the name of a function that I wanted to pass in. But alternatively, JavaScript allows me to just directly write a function here in the argument to addEventListener. I can just say function, and then a set of parentheses to mean the function doesn't take any input. And then in curly braces, I can include the body of the function right here as the second argument to addEventListener. And this is a little bit of tricky syntax to wrap your mind around if you've never seen it before. But the big picture way to think of it is addEventListener takes two arguments. One is the event, the second is the function. So here first is the event, DOM content loaded. And the second argument is a function. And I would declare the function same as before, just using function. I haven't given the function a name, because strictly speaking, it doesn't need a name. I'm never going to refer to this function by name. So it is what we might call an anonymous function, a function that has no name, but I'm still passing it into the add_event_listener function as an argument because I want to run the code inside of the function once the DOM is done loading. And so inside of curly braces then is the content of that function, the content of what code should run when the DOM is done loading. And then at the end, I again use just this end parenthesis, where that end parenthesis lines up with this parenthesis here. This is enclosing all of the arguments to add_event_listener, where the first one is DOM content loaded, and the second one is this entire function that might span multiple lines. So you'll see syntax like this quite a bit in JavaScript. But now what I want to do is adding the event listener to the button, I can go ahead and just replace and put it here. And it turns out that if I wanted to, instead of saying .onClick equals count, you could have used the same syntax of add_event_listener. I could say add_event_listener click and then count to mean when the click event happens, go ahead and run the count function. But you can equivalently shorthand this and just say .onClick equals count. And that would work just as well. So now what we're saying here is that wait until the DOM is done loaded. Wait until all the content on the page is loaded, and then go ahead and run this function. And what the function is going to do is it's going to add the event handler to this button. And that'll work because now we'll be able to find the button, because now all of the content of the DOM has loaded. So now, if I go back, refresh counter.html, you'll notice that the JavaScript error goes away. I don't seem to have that error anymore. And now if I press count, we're able to see the count increment just as before as well. And so this then is an improvement upon what I've had before, where now I'm able to separate out my JavaScript code from all of the rest of my code as well. But much as in the case of CSS, where we were able to take CSS that was originally located in the head of our page and move it into a separate file, you can do the same thing with JavaScript too. And this can be helpful if you have multiple people working on different files. You want one person working on the HTML and someone else working on the JavaScript. It can be helpful if you expect that one of these things is going to change more frequently than the other, so you might not need to load the other one as often. So there can be value in separating our HTML code from our JavaScript even more by moving our JavaScript into a separate file. And so in order to do that, I can create a new file that I'll just call counter.js, which will contain all of the JavaScript for my counter.html file. So in order to do that, what I can say is let's go ahead and copy all of this JavaScript code, go ahead and cut it out of this page, and I'll paste it into counter.js, remove some of that indentation. So now I have a file called counter.js that just contains all of the JavaScript I want to run on my counter.html page. And now, rather than include actual JavaScript in between these script tags, what I can say is script src for source, equals counter.js, for example, to say go ahead and reference counter.js and use that JavaScript in the head of the page here. And that then is going to work exactly the same way. I still am able to count as high as I'd like. I still get an alert every time the count reaches a multiple of 10. But my HTML is now a little bit simpler. It's just the body. It's just the h1 and the button. And then all of my JavaScript is now located in a separate file that allows me to keep my HTML code and my JavaScript code separate from each other. And that can be valuable for a couple of reasons. Among them, if I have common JavaScript code that's in use by multiple different HTML pages, multiple HTML pages can all include the same JavaScript source rather than needing to repeat myself, use the same JavaScript across multiple different pages. I can just use the same JavaScript across all of them. And that'll be helpful too as we begin to take a look later at some JavaScript libraries, which are JavaScript written by other people. We can just include other people's JavaScript in our own web pages just by adding a script tag at the top of our page that specifies a particular source. You may have already interacted with Bootstrap that has its own JavaScript code, and you can include Bootstrap's JavaScript just by including a script tag at the top of our HTML page in order to say, go ahead and include all of that JavaScript in our page as well. So what else can we do now that we have the ability to get at elements of the DOM and actually manipulate their contents? Well, one thing we can do is begin to make our pages a little bit more interactive, actually respond to what users are doing on the page, whether the user is typing something in or maybe filling out a form, for example. So let's go ahead and try an example of that, where the user might be filling out a form, and we would like for our code to somehow respond to what it is that they type. I'll go ahead and go back into hello.html. And now inside of the body of the page, I've said hello at the top. I'm here instead of a button. I'm going to have a form. This HTML form will look like the HTML forms we've seen before. I'll have an input field that I'll add the autofocus attribute to mean like automatically focus this input field when I open the page, because I might want the user to start typing right away. I'm going to give this input field an ID of name, for example, and then a placeholder of name, capital N, whose type is text. So what have I done here? I've created an input field where the user can type in some text. The placeholder, the thing the user sees filled into that input field originally, will just be capital N name, telling them they should type their name in here. And I've given this input field an ID, some unique identifier, such that I later on can reference and find this particular input field. And then I have input type equals submit, some way for me to now submit this form as well. And so if I load this page, load hello.html, here's what I see. Hello, a field where I can type in my name. The placeholder name shows up there for me. And then a button where I can submit this form. And now what I'd like to do inside of my JavaScript is, instead of this hello function, what I'm going to do is I'm going to first run some JavaScript when the DOM is done loading. And so I'll use that same line from before. You're going to see it quite a bit, where we're going to say document.add_event_listener, DOM content loaded, and then this function to mean go ahead and run this code when the DOM is done loaded. And the code I'd like to run is to say, when I submit the form, I want something to happen. When I submit the form, maybe I want to display an alert that if I typed in Brian, it'll say hello Brian. Or if I typed in David, it'll say hello David, for example. So how might I do that? Well, how do I get the form? That's the first question. Anytime you want to get at an element, one particular element on an HTML page, usually what we're going to do is document.querySelector to say, get me the element that is a form. And there's only one form on the page, so I don't have to worry about ambiguity. I'm just saying, get me that form. And then I can say, .onSubmit, when you submit the form, what code should run? And if I had a name of a function, like a function f, I could just say, like, run function f when the form is submitted. But alternatively, just as before, instead of providing the name of a function, I can also just provide the function itself. I can say function, and then in between these curly braces, I can specify exactly what code should run when the form is submitted by providing this anonymous function instead, using this anonymous function as the value of the onSubmit property of this form. And so now what I'd like to do is somehow get access to whatever the user typed into the input field, whatever the user's name happens to be. And so I could get the input field via document.querySelector input. And that would work this time. But we'll want to start to be a little bit careful, because on this page, there are multiple different input elements. There's an input element here for typing in the name, and a second input element here for telling me, giving me a button where I can submit this particular HTML form. And so what I probably want to do is be a little bit more specific. And it turns out that inside of QuerySelector, I can use all of the standard ways in CSS that we could select for a particular element. So in CSS, if you'll recall, we had the ability to run CSS and just say style all the h1s. Or we could say style all the things with this particular ID or with this particular class. And document.querySelector works the same way, that I can say document.querySelector and pass in a tag to say, like, get me the h1 element, or get me the button, or get me the form. But if there are multiple h1 elements or multiple buttons or multiple forms, I can be more specific than that if, for example, an element has an ID. In which case I can say document.querySelector, and then in quotation marks, the hash mark, and then the name of the ID, to say, get me the element with that particular ID. Again, using the exact same syntax that CSS uses if I want to apply a particular set of styles to only one element that only has one ID. Likewise, too, I can say document.querySelector, and then use dot followed by the name of a class if there's a particular class of elements, and I want to just get one of those to say, get me an element that has this particular class in order to manipulate it as well. So the same types of syntax that we could use in CSS for trying to reference and get at a particular HTML element, we can do the same thing here with document.querySelector to go ahead and try and get a particular element based on its tag name, based on its ID, or based on its class. And it was for that reason that inside of the HTML page, for my input, I gave the input an ID of name. I wanted some way to be able to uniquely reference it. And I can uniquely reference it not by input, but by pound name, where I can say, get me the element that has an ID of name. And that is the element that I would like to extract inside of my JavaScript code. Once I have that HTML element, what I want is like what the user actually typed into that input field. And it turns out that if you have an input field in HTML, I can get access to what the user typed in by accessing its value property. Value is a property that refers to what it is the user actually typed in. So I can say .value. And I'm going to go ahead and save that inside of a variable. So I could say something like let name equal whatever the user typed in. But if I'm not going to reassign name to something else inside of this function, I'm really going to get the name once, and I'm not going to change it inside of the function. So I can use a const variable instead, and that would be better designed to say I have a constant variable called name, which is equal to document.querySelector, get me the element whose ID is name, and get access to its value. And now I can display an alert. I can alert something like in backticks, hello, comma, and then using the $ curly brace syntax, I can say plug in the name there, followed by an exclamation point. So I've extracted the name from the form. Get me the input field where they typed the name, get access to its value, and then I'm displaying an alert that is going to say hello to that person, for example. And so now, if I refresh the page, I type in my name, I press submit, I get an alert that says hello Brian, I press OK, I can try it again. I can type in something like David, press submit, and now the page says hello David. So here again, we've been able to combine event listeners and functions and query selector to be able to both read information from the page in order to say, get me this particular HTML element, find me an HTML element, and access like what the user typed into it, the .value property that gets me what the user typed into an input field. And we've been able to combine that with event listeners and alerts that are able to actually respond dynamically to when a user submits the form or when the entire content of the page is done loading in order to produce some interesting effects as well. But it turns out we can do more than just change like the HTML that is contained within an element. We can also change CSS as well, change the style properties of a particular element as well. So let's go ahead and see an example of that. I'll go ahead and create a new file that I'll call colors.html. And inside of colors, I'll include the same standard HTML boilerplate code that we often start with, a head section with a title and a body section. And inside of the body of this page, I'm going to display a heading that just says hello, for example. And maybe I'll give it an ID, just so I can reference it by name. Maybe it has an ID of hello. And then I'll have 3 buttons. I'll have a button called red, a button called blue, and then a button called green, for example. Where now if I open up colors.html, here's what I see. I see a big heading that says hello, and then I see 3 buttons, red, blue, and green. But of course, right now, these buttons don't actually do anything. How do I get the buttons to do something? Well, that's where JavaScript's going to come in. I'll add a script tag to the top of my page. And I only want to run this JavaScript when the DOM is done loading. So again, we'll use the same syntax as before. Document.add event listener, DOM content loaded, and then run this function. To say everything in between these curly braces, this is all the code that should run once the page is done loading. And what I'd really like to do is get at these 3 buttons and say when you click on each one of them, do something different, like change the color of a particular HTML element. And in order to do that, I need some way of uniquely referencing these buttons. So to do that, I'm going to give them all IDs. This button will have an ID of red. This button will have an ID of blue. This button will have an ID of green. Just unique names I can give to the buttons in HTML such that in JavaScript, I'm later able to reference them. So what do I include now here inside of my JavaScript code? Well, let me say document.querySelector #red to say get me the element whose ID is red. And when you're clicked on click, go ahead and run this function. What should the function do? Well, I want to take this h1 element and change its color to red. I want to change the font color to red. And I'll leave a comment to myself. In JavaScript, the way you can leave a comment just to document what you're doing is using these two slashes. The two slashes indicate everything after that on the page is going to be a comment. The browser will ignore it, but it can be useful to you, the programmer, and to someone who's reading your code to be able to see what it is that you're describing here on the page. And now what I'd like to do is document.querySelector hello, get me the HTML element whose ID is hello, and go ahead and modify its style property. And now inside of this style object, I can modify any of the CSS style properties. One of them, for example, is something like color. So I can update the color property and set it equal to red. So here now I'm saying when you click on the red button, go ahead and run this function. And what the function should do is find the hello element, update its style. What part of the style? Update its color. What should we update it to? We should update it to red. And I'm going to do the same thing for the other two buttons as well. And it's pretty similar code, so I'm just going to copy, paste here. I'm going to have one for changing the color to blue. When I click the blue button, you should change the color to blue. And then we'll do it one more time. Change the font color to green. When you click on the green button, you should change the color to green. So now, when I refresh the colors.html, right now, hello by default is just in black, standard font color for HTML. I click red, hello changes to red. I click blue, it changes to blue. I click green, it changes to green. So depending on what button I click, that triggers some event listener that's going to then say, when the button is clicked, run this function. And what the function does is it grabs this h1 element, the element whose ID is hello, modifies its style, updates its color property to be something like red or blue or green, thus showing that we can modify style in addition to just modifying the content of the page itself. But it turns out that as you looked at me writing that code, something should have struck you as probably not optimal design. That in general, anytime you find yourself writing the same code again and again and again, especially if you're copy-pasting, that is generally a bad sign. Usually a sign that there is some better way of trying to modify, of trying to implement the behavior that I'm trying to create. And it turns out that there is. And there are a number of ways that you could do this. One way here is that I might like to consolidate these three event listeners into just like a single function that is going to handle changing the color to whatever the button says the color should be changed to. But one problem here is that if I just attach the same event listener to all three of the buttons, it's not going to be clear to me when I click on the button, how does the button know what color we should change the text to? And so to that effect, we can add some additional special attributes to a particular HTML element that are called data attributes. Where a data attribute is my way of saying that I would like to associate some data with this particular HTML element. Where here I can say data-color equals red, data-color equals blue, data-color equals green. Data attributes always start with data followed by a dash. And then I can specify really any name that I want for some information that I would like to store about the HTML element. And here, the information I want to store is I want to store data about what color you should change the text to when the button is clicked on. And so what we're going to have the ability to do now is the ability to say that if I have access to this element, this button, I can access its data color property to know whether we should change the text to red or blue or green by adding these data attributes to these HTML elements. And so now what I want is some way of getting all of these buttons. Now document.querySelector, as you recall, just gets one element. It's just going to get for me a single element, and it's going to get the first one that it finds. If I want to get multiple elements, what I can do instead is something like document.querySelector all. QuerySelector all is going to return the same thing that QuerySelector does, but instead of QuerySelector returning a single element that matches what it looks for, QuerySelector all is going to return to me an array of all of the elements that match my particular query. So if I want to select not just the first button I find, but all of the buttons I find, I can here say QuerySelector all for button. And that will give me back a JavaScript array, the equivalent of a list that represents all of those buttons. And we can actually test what this looks like by looking at things inside of the JavaScript console. That if I go ahead and refresh this page, colors, I can open up the inspector, go into the JavaScript console, and just as you could see error messages here, you can also actually write JavaScript code here as well. So I can say something like document.querySelector button to say, all right, what's going to happen when I try and select for a button on this particular page? And what I get is, all right, I get just this very first button whose data-color is equal to red. That's what I would expect. QuerySelector just finds me one element, and it's going to find me the very first element. And likewise, I can say, all right, instead of QuerySelector, let's do QuerySelector all. And what I get back is a node list, which you can think of as kind of like an array or a list in Python, that's got 3 buttons in it, button 0, 1, and 2. And just as with a list in Python, as you can index into things, arrays in Python, arrays in JavaScript can be indexed into as well. That if I have something like const names equals Harry, Ron, and Hermione, like an array of 3 names, I can say name square bracket 0 to get the first name, name square bracket 1 to get the second one, name square bracket 2 to get the third one, for example. And that gives me each of the individual elements in the array. If I want to get the whole length of the array, I can do names.length to get, all right, the length of the names array happens to be 3. So just some additional features that we have access to if you happen to have an array of things. Turns out QuerySelector all returns to me a node list, which is kind of like an array. And that's going to be useful because when I say document.querySelector all button, I am saying get me all of the buttons on the page. And now what I would like to do is effectively loop over all of those buttons and say for each of the buttons inside of this list that comes back to me, I would like to add an event handler for when that button is clicked on. To say for each of the buttons that comes back, go ahead and say when you're clicked on, change the color of the h1 element. And so there are a number of ways, again, that you could do this. But one way is to use a particular property called forEach. And forEach is a function that accepts as an argument another function, where the idea is going to be I would like to run a function for each of the elements inside of an array or inside of a node list, for example. So here I can say, for each button, go ahead and run this function. This is going to be a function now that takes something as input. It's going to take one of the elements in the list as input, something like a button. And now for each button, what would I like to do for that button? Well, when the button is clicked on, button.onClick, then go ahead and run a function that is going to document.querySelector, get me the element whose ID is hello, change its style. Within the style, change its color. And what do I want to change its color to? Well, I have access to this button. This argument to the function is whichever button I'm currently trying to add an event listener for. And in order to access its data properties, I can access a special property of an HTML element called its dataset property. And then I can say something like button.dataset.color to get at the data-color attribute. So a lot of stuff going on here. Let's go ahead and try and read through this entire thing and just get a feel for what's happening. Because we have functions nested within other functions, nested within other functions. Up at the very top, I've said add an event listener to the document. When the document's DOM content is loaded, meaning all of the content of the page is done loading, go ahead and run this function. This is the body of the function. So what do I want to do? When the page is done loading, I'm going to document.querySelector all, looking for all of the buttons. And if I wanted to, if there could be more buttons, I could have added a class to these buttons and just looked for things with a particular class. QuerySelector all just returns all of the elements that match a particular query. And then I'm saying, for each of those buttons, for each of the buttons that came back, I would like to run a function on each of those buttons. I'm basically saying, if I have 3 buttons that came back, let me run a function on the first button, then the same function on the second button, then the same function on the third button. And what is that function? Well, it's this function here, a function that takes as input the button. It's first going to pass in as input the first button, then the second button, then the third. And what this function does is it adds an onClick handler to the button. It says when the button is clicked on, go ahead and run this other function. And this function now is the function that will run when the button is clicked on. To say, when the button is clicked on, get me the hello element, change its color to button.dataset.color. And button.dataset.color takes a button, takes an HTML element like this one here, and accesses its dataset, all of its data properties, and specifically accesses the color data property, which in this case is equal to red. And that is what we would like to set color equal to. So a little bit more complex than we've seen before, but now we've been able to reduce what was 3 different event handlers into just a single one. And now this is going to work the same way. Change it to red, blue, and green, all by just using those data properties that we have access to. And so when in doubt about how these things are working, about what query selector is returning, the JavaScript console can be a very powerful tool for this. So you can go into the JavaScript console and actually manipulate things. You can run queries. You can run functions. You can even modify the values of variables. Like if I go back, for instance, to counter.html, where I had this counter that's counting 0, 1, 2, 3, 4. If I wanted to, I could say something like counter equals 27, just like change the value of the counter. Nothing appears to have changed on the page. I didn't say update anything on the page. But now next time I run count, it's going to update the value of the count to 28. Because I had updated the value inside of the JavaScript console, it's going to increment that value, display that value inside of the h1 element. So you can modify variables. You can run functions. You can run document.querySelector to figure out what particular elements are going to come back, all through the use of the JavaScript console, which can be a very, very powerful tool, especially as you begin working on trying to debug these programs and trying to figure out what might be wrong with them. It turns out, too, that there are other changes that we can make in order to optimize our code a little bit more, in order to make it a little bit more succinct. And one way is that in more recent versions of JavaScript, they've introduced a particular notation for functions called the arrow notation for functions. And I'll just show it to you because it'll come up. But oftentimes, instead of using the keyword function before introducing a function, you'll just have something like button and then arrow, the curly braces. And strictly speaking, you'd only even need the parentheses around the input, where button, arrow, and then in these curly braces some code just means here is going to be a function that takes as input a variable called button and then runs this particular block of code when that function is run. And likewise, if a function takes no input, like this function up here, you could express it using arrow notation with just parentheses, arrow, block. And so this is often a notation that you'll see in JavaScript. So if you ever see it, know that that's really just shorthand for creating a function. Whatever is to the left of the arrow sign is the input to the function, and whatever is to the right of the arrow is what code should actually run when the function body gets executed, when the function is called upon. So what other changes might we want to make to colors.html? Well, if we look back at colors.html, here's what it looks like now. We've got a heading that says hello, and then buttons to change the color to red or blue or green, for example. We might instead, if we want the user to choose from a number of options, decide upon the user interface choice of using a drop-down instead of a bunch of buttons, for example. And JavaScript supports that as well. And we'll use this as an opportunity to explore some of the other event handlers that exist within JavaScript. So for example, instead of having these all inside of buttons, I can make my life a little bit easier by making this a select dropdown, where the select is going to have an option whose value is, let's say, black is the default option. We'll just say black. And then we'll add another option whose value is red. And then we say red. And the value is what we'll get in JavaScript when we try and extract the value of a particular select dropdown. What's in between the option tags themselves is what the user is going to see on the page when they actually view it. So I'm capitalizing it just for them. Option value equals blue. That'll be blue. And then option value equals green. And that'll be green. So now what the user sees is they see hello, and then a drop-down menu where they can choose from a list of colors rather than click buttons in order to do so. And now, of course, this select drop-down doesn't do anything at the moment, but I can modify it so that it does. So now, instead of selecting for all of the buttons and doing something with all the buttons, we don't have any buttons anymore. What I do have is I have a select dropdown. And now, just as we've seen like on click to say when you click on something, as we've seen DOM content loaded as an event, there's another event called onChange, which applies to things like select dropdowns, where when something changes in the select dropdown, when a user chooses something different, I can run some code, for example. So I can run a function that in this case is going to take document.querySelector hello, meaning get me the hello HTML element, change its style, what part of the style, change its color. and I want to change it to something. I want to change it to the value of this select dropdown. But how do I get access to this particular select dropdown? Well, in JavaScript, we have access to a special value called this. And this has special meaning in JavaScript, and its meaning varies based on context. But in the context of an event handler, a function that is called when a particular event happens, this is going to be a special keyword that always refers to the thing that received the event. So what received the event? It was the select dropdown. That is what received the event of being changed. And so this is going to be a special keyword that always refers to that always refers to the dropdown menu where I made a different selection. So if I want to get the value of that dropdown menu, what it is the user actually selected, I can just say this.value to mean get that dropdown menu and get it the value, the thing that the user selected in that menu. And now, much more succinctly than before, I've been able to implement the same kind of idea. It says hello right now in black, but if I choose from the drop-down menu to change its color to something like red, for example, color changes to red. If I instead choose blue, it changes to blue. Green changes to green. I choose black, it changes back to black. So now I have this ability to detect these other types of events and respond to them as well. And there are many, many different events that exist in JavaScript. There's onClick, which we've seen already. OnMouseOver can detect like when you mouse over something, when you're hovering over a particular element. If you've ever seen websites that somehow respond when your mouse moves over something, that can be how it's implemented. OnKeyDown and OnKeyUp can respond to keyboard events, something like when you press a key on the keyboard. When you press down on the key, that's OnKeyDown. And when you lift your finger off the key, that's OnKeyUp. And there are other events as well, many more events than are just listed here, that you can listen for and respond to so that you can really interact with the user based on what it is that they're doing. So now let's take a look at an example of how we can use some of these events to now begin to create a little bit of a more interesting application. We'll go ahead and build a to-do list application, this time using exclusively JavaScript. We've seen to-do lists before that involve communicating with a server, making requests and responses. We'll now build a to-do list that only uses JavaScript to do so. So I'll create a new file called tasks.html. And we'll create a head section whose title is tasks, and a body section. And inside the body of the page, I'll go ahead and have a heading that says tasks. And underneath that, I want an unordered list of all of my tasks. So I'll have an unordered list. I'll give it an ID of tasks just for good measure so I can reference it later. But initially, nothing's going to be in here. But what I'll have underneath the unordered list is a form where I can submit a new task, for example. So I'll give myself an input field, also give it an ID. The ID will be task singular for the new task that I am typing in. The placeholder will be new task, just so the user knows what to type in. And the type of the input field will be text. So I have an input field where the user can type in some new task. And I'll also add an input field for good measure, whose type is submit, that allows the user to submit a new task once they've created it. So if I open up tasks.html, here's then what I see. Big heading. There is technically an unordered list underneath it here, but there's nothing in that unordered list yet, so it just shows up as empty. Then a text field where I can type in a task, and then a submit button where I can submit my new task. So now I'd like some JavaScript, such that when I submit this form, we actually do something. So I'll add a script tag. I want this JavaScript to run after the DOM content is loaded. So we'll go ahead and add the usual DOM content loaded event listener. And now I want to run code when the form is submitted. So I can say document.querySelector form.onSubmit equals, and then I want to run a function. And I could use the keyword function again, but I can just use an arrow function, which will be a little bit faster to type. Just say, all right, here's the function that I want to run when the form is submitted. And what would I like to do? Well, I'd first like to figure out, all right, what did the user actually type in? And what the user typed in, well, that'll be document.querySelector task.value. Get me the element with ID task. That's the input field. .value gets the value of the input field, which is what the user actually typed in. And I can save that as like const task. That is what it is the user typed in. And if I'm curious as to what the user typed in, I can actually print it out to the JavaScript console. And the way to do that is using a special function called console.log. And that just logs something to the console, the equivalent of printing something out in Python where it just shows up in the Python terminal. Here, this is going to show up in the JavaScript console. And one other thing I'll add is by default, forms will try and submit when you press the submit button, like take you to another page. We've seen this before already in the context of Django, that when you submit a form, it tries and submits another web request. If I want to prevent that behavior, stop the form from submitting, so stop form from submitting, I can return false at the end of my form submission handler to say, don't actually submit the form. We're going to do everything client-side, everything just inside of the browser. So now this won't quite work yet, but it'll be progress. I refresh the page. I'm going to open up the JavaScript console so I can see what's going on. If I add a task, something just like foo, press submit, this now gets logged to the JavaScript console. It's the equivalent of a way of like providing debugging information to myself to know, all right, I now have access to this value foo, and it's also telling me what line of code logged it. It was tasks.html. Line 9 is the line of code that logged foo. And so this can be useful when you're debugging a program. When you want to see what the values of variables are, you can just print them out using console.log to figure out what's going on in your program at any particular point in time. But what I want to do is not console.log it. What I want to do is really create a new element that I'm going to add into my body of the HTML. So how can I do that? Well, to create a new element for my document, I can run a function called document.createElement, followed by what type of element do I want to create? Well, I have an unordered list, a UL, and every item inside of an unordered list is a list item, an LI. So I'll go ahead and create an LI element, a list item. And I'll save that in a variable that I'll call LI. So I've created a new list item. And this list item's inner HTML, the HTML content inside of that list item, well, that's just going to be task, this variable from up here, which is whatever the user typed in. So I've now created a new list item and said what HTML should go inside of the list item. It should be whatever task the user typed in. And now I'm going to say document.querySelector tasks, get me the element whose ID is tasks, and that's going to be this unordered list here, the unordered list whose ID is tasks. And if I have an HTML element, I can add a new element inside of it by saying .append li. And what that now is going to do is it's going to say, get me the unordered list whose ID is tasks. Get me the element whose ID is tasks via query selector here. Once I have that element, append to the end of what's inside of that element this value, li, which happens to be this new element that I've created, a new list item. So I've been able to add a new HTML element, and this line of code is going to say, add it to the DOM, add it to the unordered list that I am here now constructing. So now I rerun this. I see tasks. I type in something like foo. I press submit. And all right, foo now shows up. I type in something like, all right, delete that. Type in bar. Bar now shows up. I type in Baz. Baz now shows up. Now, one minor user interface annoyance is that it seems that every time I submit a new task, this input field retains the value of what it used to be. And that's probably not what I want, because I'd rather it just clear out. I've already submitted the task. No need for it to stay there. But that's easy to manipulate in JavaScript. If I want to clear out this input field, the input field whose ID is task, then all I need to do is say document.querySelector task, get me that input field, change its value equal to the empty string, equal to nothing, just to say clear out the value of what happens to be inside of that input field right now. And now if I refresh the page, type in foo, press submit, input field clears out, and now I can type in something like bar and then something like Baz to continue to add tasks as well. Now, one thing that might be slightly annoying is if I'm not careful, if I press submit, well, it submits the empty string as a task. And so I just get this empty bullet point that shows up here. Right? I press submit, and I just get all of these empty bullet points. It might be nice from a user experience perspective if I were to not allow the user to do that, not allow them to submit a task if they haven't actually typed something in to the new task field. And we can do that just by modifying properties of elements. That it turns out that HTML elements have a property called disabled that can be true or false that allows us to disable something like a button. So if I want to disable the submit button, one thing I might want to do first is give this submit button an ID. I'll give it an ID of submit so that in my JavaScript code, I can reference the submit button. And now inside of this JavaScript code, when the DOM content is loaded, by default, the submit button should be disabled. Like when I first load the page, I don't want the submit button to be enabled because I want the user to type in a task first before I enable the submit button. So how do I do that? Well, I can document.querySelector, get me the element whose ID is submit, get me that submit button, and just set its disabled property equal to true. JavaScript has Boolean values, true and false. I set the disabled value equal to true to disable the submit button. Now if I refresh the page, I can type in a new task, but the submit button is disabled. It doesn't do anything. Now, obviously, I don't want to keep it that way. I'd like it such that as I begin to type things in, then the submit button stops being disabled. Disabled gets set from true to false instead. And so what I really want to do is listen for me like pressing keys on the keyboard. And so the way I can do that is by adding yet another event listener. Document.querySelector. What do I want to add a query selector to? What do I want to add an event handler for? Well, I want to add an event handler for when I type something into this input field. And this input field has an ID of task. So let me go ahead and get the input field, the element whose ID is task, and add an onKeyUp handler. OnKeyUp, again, is the event when I lift my finger off of a key. Go ahead and run this function. And what should the function do? Well, it's going to say document.querySelector submit, set the disabled property equal to false. And so now here's what we're doing. We're saying, by default, when I first load the page, take the submit button and disable it. Set .disabled equal to true. Then, anytime I type a key and my finger comes off the key, that means onKeyUp is the event that gets triggered, run this function. And what the function is going to do is take that same submit button and set its disabled property equal to false. So now instead of being disabled, it will be enabled. So if I go back to the page, go here, I type in, right now by default the submit button is disabled. But as soon as I start typing something, now the submit button is active and I can actually click on it. And all right, this isn't great because I clicked on it, but the submit button is still enabled. So what I might like to do is, all right, after I've submitted the form, after I've added a new task, let's go back and disable the submit button. So after I've submitted the form, after we've added the new task to my list of tasks, after we've cleared out the value from the input field, let me also get the submit button, set its disabled property equal to true. Now, even after I submit the form, the submit button is still going to be disabled, such that I type in foo, now submit is active, I press it, but the submit button goes back to being inactive as well. It turns out that even now, there's still a little bit of a bug. If I go back here and I type in something like bar, but then I backspace back to like nothing here, the submit button is still active. So I can still technically submit a task that has no content inside of it. And so I might like to have some way of preventing against that as well. And that's just some additional logic. We now have access to JavaScript that has conditions, that has loops, that has functions. And so if I want to do something like conditionally check, I can say if document.querySelector task .value.length is greater than 0, meaning like something's actually typed into the task field, well then go ahead and set disabled to false. But otherwise, go ahead and set disabled equal to true. So now here we're checking. If the length of what the user has typed in is greater than 0, they actually typed something in, then yes, give them access to the submit button. But otherwise, don't give them access to that button. So now I refresh the page, disabled by default. I type something in, it's enabled. I delete, 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 and it goes back to being disabled. So JavaScript has allowed us to really make our pages much more interactive and immediately interactive based on how the user is interacting with the page. As they begin to type things, as they begin to delete things, as they press buttons, we're able to have the page respond either by adding content to the DOM, by literally adding parts to the HTML page, changing the styles of things, changing particular properties of elements. And this is really where the power of JavaScript begins to come in, is in allowing ourselves to do things like that. Now, so far, we've only been able to have events happen when the user does something, when the user clicks on a button or when the user presses a key, for example. But it turns out JavaScript has other ways of allowing functions to run, in fact, on their own. We can set what are called intervals, where a particular function runs every some number of milliseconds, for example. And so if we go back to like the counter example from before, Right now, for this counter example, I have to be the one to press the count button that is going to increment the value of count every single time. But I could put that inside of an interval instead. So let me go back to counter.html, whose JavaScript is inside of counter.js. And now what I'd like to say is I would like, when the DOM content is loaded, let me set an interval for count and 1,000. So what is that going to do? SetInterval is a function built into JavaScript here, where I'm saying that I would like to create a new interval where every so often go ahead and run a particular function. And I would like to run the count function, where recall that count function is going to increment the value of count. And I'll get rid of this alert for now, just for simplicity. All I want the count function to do is update the h1 with the new value of the counter, and go ahead and run that count function every 1,000 milliseconds, otherwise known as every 1 second, go ahead and run the count function. So now when I open counter.html, it's 0, but every second now it's going to change. Every second updating one by one by one. I don't have to click the button. Of course, I could, and the event handler would still work. But the interval is saying now, every 1 second, go ahead and run the count function, and that has this particular result. So if you've ever seen a web page that like displays the current time in seconds, and it's like a countdown timer, or is displaying the current time with seconds, it might be doing something like this, just having some sort of interval that every second is going to count and increment in order to say update the number to the one greater, and one greater than that. Of course, if I close the page and go back to it, if I close these pages and then open counter.html again, I've gone back to 0. Like JavaScript is not saving any state about my page. It's just every time we're running the page, it's going to go back to counter.js. It's going to see, all right, we're defining a variable called counter. We're setting that variable equal to 0. So every time I load the page, it's going to be set back to 0. And that might not be great depending on the type of page you're trying to create. That maybe you want a page that is somehow able to store information such that on subsequent visits, we're able to utilize the information that was already stored, some way of remembering information for later use. And later versions of JavaScript and more modern browsers now allow us to do something just like that called local storage. And what local storage is it's a way for us to be able to store information inside of the user's web browser, that a page can ask to store particular values inside the web browser. And later on subsequent visits to that page, we can go back and say, let's extract those values that were previously stored inside of local storage. Local storage is going to give us access to two key functions that we're going to use to manipulate this local storage. The first is local storage.getItem, where we would like to get something out of local storage based on its key, some name that we have given to that value. And we also have access to local storage.setItem, which goes ahead and adds a new value to local storage or replaces an existing value in local storage, setting this key equal to a particular value. So we can use local storage then to allow our web pages using JavaScript to be able to store information and retrieve information from the browser. And let's now try to use that in order to solve this problem of the counter that seems to always reset back to 0. So now in counter.js, instead of setting counter equal to 0, the first thing I want to know is there already a value for the counter in local storage? So I can ask a question like, if local storage.getItem counter, meaning go to local storage, try and get the counter. And anything in this if expression will happen if there is something inside of local storage for counter. But it turns out that if I want to do the inverse of that, say not, I can just use the exclamation point, much like in C. In JavaScript, the exclamation point just means not. So meaning if there is not something in local storage called counter, well, then let's go ahead and just set the value in local storage. Local storage.setItem counter, and we'll set it equal to 0. So what this is doing here is before anything else happens, we are checking local storage to say, is there already a value for counter? And if there is not already a value for counter, we need to make sure there is something there inside of local storage for the counter. So we are going to set the value of counter equal to 0, for example. And so now what needs to change, I'll go ahead and get rid of the interval so that it only happens when I click on it. But what should this count function actually do? Well, first, let me get the value of the counter. Counter is going to be whatever local storage.getItem counter is. I'm going to get the counter out of local storage. I'm going to increment it, counter plus plus. We'll go ahead and set the value of this h1 element's inner HTML equal to that counter. But the last step is I'll also do local storage dot set item counter is equal to the new value of counter. So what I've done here is to say that when I click the button, count function is going to run. We're first going to go into local storage, get the value for the key counter, whatever the value of counter happens to be, save it inside of this variable called counter. We'll go ahead and increment that variable, setting it equal to itself plus 1. Update the h1's inner HTML, same as before, just to update what we actually see on the page. But then go ahead and local storage.set item counter gets set to counter, for example. So now let's go ahead and see what's going to happen. If I go ahead and open counter.html, we see 0. We count 1, 2, 3, 4, 5. Everything so far so good. Now watch what happens if I refresh this page. I refresh the page, and all right, that seems a little bit strange. It's 0. Let me try counting and see what happens. I press count, and all right, the count changed to 6. So it seems like it did remember that I counted up to 5, 0, 1, 2, 3, 4, 5. But when I refresh the page, it still showed me 0, but then let me count up to the number 6, and now I can keep counting 7, 8, 9, 10. What happens if I refresh the page now? I can try it. I refresh the page. I've gone back to 0, but I count, and OK, now I'm at 11. So somehow I am still remembering, but the first time it's still giving me 0 every time. Why might that be? Well, if you look back at counter.html, you'll notice that the reason is just inside the body of the page, the initial value of the h1 is just always 0. So if I want to fix that, then what I need to say is when the DOM content is loaded, go ahead and get document.querySelector h1. Go ahead and update the inner HTML equal to whatever local storage.getItem counter happens to be. So every time I open the page, even before I click the button, even before the event listener is triggered, I'd like to say, go ahead and replace this heading, update its inner HTML to be the result of getting the counter out of local storage, for example. So now, if I refresh the page, it's at 11. I can update, 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 click again some number of times, bring it up to 18, for example, refresh the page, and it stays at the number 18. And no matter what value I get it to, it's going to store that number inside of local storage such that when I refresh the page, that number is going to stay there. And we can actually see the value inside of local storage by, again, going into Chrome's inspector. I go into Chrome. If I go to the Application tab, and I go to local storage here on the left, I can see that I have a value for key counter, whose value in this case happens to be 28. And you could go into local storage. You can manipulate this value. You could delete it if you want. But this just goes to show you that we have now stored this value inside of my browser such that on subsequent visits, if this page gets loaded again, we can access that value from inside of the application as well. And so now we've been able to see how our pages are able to store data in order to just make the user experience a little bit better. If we want the user to be able to have information remembered from the last time they visited a particular page, we can sometimes actually be quite helpful. All right, so now we've seen a lot of features of JavaScript. We've seen a bunch of different ways of representing data. We've stored data in variables, and those variables have had types like integers. Those variables have sometimes been strings. Sometimes they've been HTML elements. Sometimes they've been arrays or lists of items. Sometimes they've even been functions. We can set a variable equal to a function. But perhaps one of the most useful data types inside of JavaScript is the JavaScript object. So I'll go into the JavaScript console just to demonstrate this. What the JavaScript object is it's really the equivalent of like a Python dictionary, some association of keys to values, where you can look up something by a key or by a property and see what its value happens to be. So if I had a variable like person, I could set person equal to a JavaScript object whose like first name is Harry and whose last name is Potter. Again, using syntax very similar to what the dictionary syntax looks like inside of Python as well. And now that I have this variable person, which is first Harry, last Potter, I can access a particular property of the person in a number of ways. I can say something like person.first to say, get me the first name property of this particular object, and I see that it's equal to Harry. I could equivalently use square bracket notation, the way Python does, square bracket first, and that will also give me Harry. But this turns out to be quite powerful, to be able to represent data in this structured way like this, where I have an association of keys, or otherwise known as properties, with particular values. And then I have the ability, given a JavaScript object, to be able to access a particular value. And it turns out that one of the ways this is most useful is in the exchange of data, moving data around from one service to another. And so here we're going to introduce what are known as APIs, otherwise known as application programming interfaces, which in the context of the web, you can think of as some well-defined structured way for services on the internet to communicate with each other. That if you want your application to be able to talk to some other service, maybe you want your application to interact with Google Maps or to be able to interact with Amazon or some other weather service to get the day's weather, then you might be able to access some API, some mechanism whereby you can communicate with another service by sending a request and receiving back data in some sort of very well-structured format. And very often, that well-structured format happens to be a particular type of data known as JSON, which stands for JavaScript Object Notation, which is a way of transferring data in the form of JavaScript objects, these sort of objects that happen to have properties and values associated with them. And so what does JavaScript object notation look like? Well, if we think back to the applications that we've been creating, these applications that are able to represent things like an airline and movements of planes between particular destinations, a JavaScript object representing a flight might look something like this. A JavaScript object that has properties for origin is something, destination is something, duration is something, things we've seen before. But you might imagine that if we wanted our airline to be able to make its data available to other services so that other web applications or other programs could programmatically access information about flights, we could pass data in this format to those other applications so that they could then treat this as a JavaScript object and get access to the information about it. And the nice thing about this particular representation is that it is both human readable and machine readable. That we as people can look at this and get an intuitive understanding for what all of this means. But also a computer knows how to access particular properties that appear before the colon and get access to what those values are, which appear after that colon as well. So JavaScript object notation, otherwise known as JSON, offers a very convenient representation. And this isn't exactly what the JavaScript object syntax is. In JavaScript objects, you don't strictly need the quotation marks around the keys. You could just say origin colon and not origin and quotation marks. So JavaScript object notation uses slightly different syntax, but ultimately very reminiscent of what we've seen in JavaScript objects. And JavaScript knows how to take data in this form and turn it into something like a JavaScript object. And turns out there are ways of doing this in Python as well. And other programming languages have the ability to interpret JSON data in order to use it in some meaningful way. And another advantage of the JSON representation is that it's very conducive to representing structures of things. So these values don't just need to be strings or numbers. They could be lists or arrays that happen to have a sequence of possible values. Or they could even be other JavaScript objects, that if we wanted to represent not just the city name, but represent the city name and the airport code, for example, as we saw that we wanted to do before, I could, instead of having origin be equal to a string like New York, have origin be equal to yet another JavaScript object that contains a city property and a code property where the city is the name of the city and the code is the name of the airport code. And the important thing is, as long as I and the person I'm communicating with agree upon this representation, agree upon what the names of these keys are and what the structure of this JSON payload, this JSON object happens to be, then the person on the receiving end can take this data and write a program that's able to interpret it and use that data in some meaningful way. And so we'll see an example of this now, of using JavaScript to be able to communicate with yet another online service, in particular for accessing information about currency exchange rates. Currency exchange rates are always changing. We want access to the latest currency exchange rate data. And if there is an online service, an API, that provides access to that data in JSON form, in a format like this that is machine readable, then we can use that data to write a currency exchange application that uses real-time data in order to make those conversions. What might that data look like? Well, the data could look something like this, that we make a request for accessing what are the exchange rates for converting from US dollars, otherwise known as USD, and we get back a JSON object that looks like this, that has a base key of USD, and then it has a rates key that has a whole bunch of rates within it. So conversion to euros and Japanese yen, Great Britain pounds, as well as Australian dollars, and all of the various different currency exchange rates for all of these different currencies, for example. And this doesn't have to be the way that this data is structured, but it happens to be a convenient way. And so long as the person providing this data to me and I both know what this structure is, we can begin to write programs that are able to use that data. And so we'll now see our example of an API, which is exchangeratesAPI.io. And if we go to api.exchangeratesAPI.io/latest and provide a get parameter of base equals US dollars, then what we get back is data that looks like this. Now, it's a little bit messy looking, not nearly as clean as we saw before, but it's the same exact thing, just without the white space. We have a JavaScript object that has a rates key that tells me, all right, here is the exchange rate between US dollars and Canadian dollars, and the pound and the euro and other currencies that exist as well. And down below, we have the base of what base currency we're converting from. So all of this data can come back to me if I just make an HTTP request. I make a web request to this particular URL. I then get access to all of this currency exchange rate information that I can then use inside of my application. So how can I do this? How can I now begin to use this information inside of an application? Let's now create a new page. I'm going to call this currency.html. Inside of currency.html, I'll add our usual HTML, a title of currency exchange, and a body. And inside the body, I'm just going to include nothing for now. What I really care about is the JavaScript that is going to make a web request in order to get access to additional data. Now, so far in JavaScript, our JavaScript code has exclusively been running code that exists only on our computer. It's running inside the web browser and all happening inside the web browser. We're not communicating with some external server. What we'll take a look at now is something known as AJAX, which is about asynchronous JavaScript, where the idea is that even after a page has loaded, using JavaScript, we can make additional web requests to ask for additional information, either from our own web servers or from some third-party web servers, if we want additional information on our page. And what we want in this case is for our page to make an asynchronous request, to request for additional data about the current currency exchange rates, for example. So how am I going to do that? Well, I want to do this after the DOM content is loaded. So we'll add that usually there. And what we're going to take advantage of is a function built into more recent versions of JavaScript and supported by most major browsers now. And it's a function called fetch. And what fetch is going to do is it is going to make a web request. It is going to query some website. It could be our own. It could be someone else's. And it's going to get back some HTTP response from that page. And I'm going to fetch. And the page I'm going to fetch is this URL, api.exchangeratesAPI.io/latest base equals USD. And the only reason I happen to know how this API works is because I've read the API's documentation that describes how the URL parameters work and what the structure of the data that I get back is. And so I'm here going to say, go ahead and fetch from this URL. Make a HTTP request asking for additional information from this URL and get back what the results are going to be. And what fetch gives back to us is something in JavaScript known as a promise. And a promise is going to be a way of representing the idea that something is going to come back, but it may not come back immediately. We're not going to go into the details of exactly how those promises work, but it turns out there's a particular syntax for dealing with them, which is that I can say, after I fetch, I can add a line called .then that says, what should I do when the promise comes back, once I get back something like a response. And so when I get back the response, what I want to do is convert the response into JSON, treat it as JSON data, a JavaScript object, as something that I can then manipulate. And so what I can do is just use this as a function to say, go ahead and return response.json. And so what this is saying is, go ahead and get me the latest exchange rates. And then, after that's done, this is an asynchronous process. It might take some time. But once I get back those results, then run this function. Take the response and return the JSON version of the response. Convert that response into just the raw JSON data, such that I can use that data to then access the currency exchange rates. And it turns out that with arrow functions, if you ever have a very simple function that all it's doing is taking something and returning something else, I can simplify this function even further and just say, I can omit the curly braces, I can omit the return. I can just say response arrow response.json. And this is a shorthand way of saying a function that takes as input the response and returns as output response.json. So here I'm saying, go ahead and fetch me the latest exchange rates from this particular API, then convert the response to JSON data, and then once you have the data, here's what I want you to do with that data. And for now, let's just go ahead and console.log that data, just to print it out to the terminal. So we're not doing anything else just yet. All I'm doing is saying, get me the exchange rates, convert the exchange rates data into JSON, and then let's go ahead and print out that data. So I'll open up currency.html. It's a blank page, but if I look in the JavaScript inspector, I see what got logged is a JavaScript object, here indicated by the word object. And if I click the triangle at left, I can open up and see, all right, inside of this object is all of this data about exchange rates for a whole bunch of different exchange rates for converting from the US dollar, where here US dollar 1 means 1 US dollar is 1 US dollar, for example. So now that I've got this data, let's actually try and use this inside of the program. Maybe let's say I want to convert between US dollars and the euro to figure out what the conversion rate is between dollars and euros. Well, if we recall what the data looks like, the data is a JavaScript object where we have a key called rates, and inside of rates is this object. And inside of that object, I can access the EUR property to get the exchange rate of 1 US dollar is equal to some number of euros, for example. So it's inside of the rates key and then inside of the EUR key. And that's how I know what to get access to inside of my data. So what I really want to do is access data.rates.eur. That says, get me all the data that came back, access the rates key, and then access the euro key. And we'll go ahead and save that in a variable called rate. And now I'll just document.querySelectorBody.innerHTML equals rate. Just like take that rate, put it inside of the body. So now if I refresh currency.html, what I see is just this value, 0.908843, which means that right now, 1 US dollar happens to be equal to about 0.91 euros, for instance. So that's useful. I could make this a little more human-friendly by putting this inside of a template string. I could say 1 US dollar is equal to, and then rate euros, for example. And so now if I refresh the page, I see 1 US dollar is equal to this many euros. And even this is a little bit annoying. I probably don't care about it to this many decimal places unless I'm really in the mood to be very precise about these exchange rates. If I only care about it to like 3 decimal places, for example, it turns out JavaScript has functions I can use on numbers like rate.toFixed, passing in 3 as an argument there, to mean I'd like to take this exchange rate and just round it to 3 decimal places, for example. So now I refresh the page, and I see 1 US dollar is equal to 0.909 euros. And the interesting thing about what's happening here is this is happening as a result of an asynchronous request. I am asking for the latest exchange rates, and when I get back the exchange rates data, JavaScript is plugging that information into the body of the page. I'm now communicating with an API, getting back that API's data in JSON form, and then using that data to update the contents of my HTML page. Of course, in practice, if I really want a currency exchange web page, I probably don't just want to display the exchange rate between US dollars and euros. I probably want to let the user pick what currencies they would like to exchange between. And so here's how I might go about doing that. Inside of the body of the page now, rather than just have an empty body, let's go ahead and add a form. That form is going to have an input whose ID is currency, just so I have a way of referencing it later. The placeholder will just be currency, and the type of it is text. And then I'll have an input whose type is submit, and we'll give it a value of convert. That'll be what the button says. It says convert, and then I can convert to a particular currency. And then I need some place to put my results. So I'll go ahead and add a div whose ID is result. And this is where, after I've done all the currency conversion, this is where I'm going to put the results of doing that currency conversion. So now, rather than fetch right away, here's what I need to do. I need to do something only when the form is submitted. So I can get the form by saying document.querySelectorForm. .onSubmit equals this function. And I'm going to go ahead and, just in advance, return false at the end of the function, so we don't actually try and submit the form to another page. I just want to run everything locally on this same page. But now inside of this form, once you submit it, that is when I want to run this code that is going to fetch new data. So I'm going to fetch data from the exchange rates API, convert that data to JSON, same as before, then go ahead and get access to that data. But now what I want to do is I want to figure out what the user actually typed in to the input field. And that is going to be the currency that I care about getting access to. So I'll create a variable called currency, which will be equal to document.querySelector. And to write the input field, if I scroll down, it has an ID of currency. So if I want to get that input field, I'm going to say get the element whose ID is currency and get its value. So this now is the currency that the user wanted me to get access to. And I can then say data.rates currency instead of data.rates.eur. And importantly, I can't do data.rates.currency. That would literally try to access a property of rates that is called currency. If I use square brackets instead, that allows me to use a variable, something like the currency variable, which I defined up here on line 13, as the currency that the user typed in. I would like to access that particular currency inside of the rates. And so now I can ask a question. There are two possibilities here. Either the currency the user typed in is a valid currency, or it's not. And it turns out that if you try and access a property of an object that doesn't exist, what you get back is a particular JavaScript variable called undefined, meaning there is no value there. So for example, if I have something like let person equal first name is Harry and last name is Potter, like we did before, I can access something like person.first and get Harry. I can access person.last and get Potter. But if I access person.middle, that is going to be a special variable in JavaScript, or a special value in JavaScript called undefined, meaning there is no value there. Slightly different from null, which also has a similar meaning. They're used in slightly different contexts. So here what I can say is if the rate is not undefined, well then, let's go ahead and update not the body, but the result to say $1 is equal to this rate, not necessarily euros, but whatever the currency happens to be. And otherwise, let's go ahead and document.querySelector result.innerHTML equals invalid currency, just to let the user know that the currency they tried to provide is not actually a valid currency. And so we're going to need to try a different currency in order to get the result to work. So now here's what we can do. If I open up currency.html again, I now see a form where I can type in a currency. I can type in something like the euro, for example. Press convert, and I see, all right, $1 equal to 0.909 euros. I type in something like the pound, press convert, $1 equal to 0.771 pounds. I type in the Japanese yen, $1 is equal to 109.852 Japanese yen. And all of this is happening where every time I submit the form, it's making yet another request. So if the exchange rates happen to change in between when I submit the form, the next time I submit the form, I will be getting the latest exchange rates according to that exchange rates API, and the results are going to come back here. And of course, if I type in a currency that doesn't exist, I type in something like foo, for example, and press convert, invalid currency. So it's going to report back to me that it wasn't able to find that currency, and so it tells me that I need to type in something valid. And so I can type in something valid. Maybe I tried just US dollars itself. It tells me $1 is equal to $1, exactly what I would expect it to be. Now, there are a couple of optimizations and improvements that we can make here. One is that I can search for euros right now with EUR, press convert. But if I search for euros in lowercase, for example, it turns out it thinks that's an invalid currency. And the reason why is because if you look at the data that comes back to me from the API, this is the data that I get back from the exchange rates API, what you'll notice is that all of the currencies are all in capital letters. They're all capital letters, which means the only keys that I'm allowed to access are in fact those that have capital letters in them, because these are the only keys that this API makes available to me. So if I want to convert between US dollars and euros lowercase, what I might want to do is first take the currency, the thing the user typed in, and first just call to uppercase on it, which is a JavaScript function that takes a string and converts it to uppercase. I'd like to take whatever the user typed in and now just first convert it to uppercase. That way, if I go back here, I can type in euro lowercase press convert, and I'm still able to get the correct conversion rate. The other thing that we won't noticeably notice a difference with here is that right now I'm assuming that all of this is going to go successfully, that we're going to successfully be able to make a web request, we'll successfully convert the response back to JSON. But you never know. An API could go down, the API could change and do something unexpected. And so anytime you're dealing with these types of promises where you fetch something and say, then do this, then do that, it can often be a good idea to add one last case, which is a catch case that basically says, what should you do if something goes wrong? So I can say catch the error, and what I can just do is say like console.log error, and then log the error there. And all that's really saying is that if anything above goes wrong with the fetching and trying to process the response, it's going to catch the error, and then we'll just like print out to the console that something went wrong, some error message happened. And so that can be a helpful nice to have just to make sure that when things crash, they crash in a predictable way, that you're able to see exactly what the error is just by looking inside the JavaScript console. And so now we have a fully working web page that is able to communicate with an external API, that is able to ask for information from another service on the internet, use those results, and put them back into the page. Really just going to show the power now that we get by taking advantage of the JavaScript language. We have the ability now to not only use JavaScript to be able to run code on the client, where we weren't able to before, where right before we only had Python code that was running on a web server, but using JavaScript, the really powerful thing is now the ability to manipulate the DOM, the ability to use JavaScript to take the page and change the contents of the page by updating things, by reading what happens to be on the page, whether it's inside of a particular element or what a user happened to type in, and using that in conjunction with event handlers, ways that we can listen for when the user clicks on something, or when the user scrolls through something, or when the user types a key to be able to respond and therefore make our web pages all the more interactive. Next time, we'll continue our discussion of JavaScript, looking at how we can leverage the features of JavaScript to continue to build even more interesting and engaging user interfaces. So we'll see you next time. Welcome back, everyone, to web programming with Python and JavaScript. And last time, we took a look at JavaScript, that language that ran inside of a user's web browser, client-side, and allowed us to do a number of things to make our web pages more interactive. JavaScript enabled us to display alerts, to be able to manipulate the DOM, the structure of the web page, in order to add content or see what content was already there. And it also let us respond to user events. When a user clicked on a button, or submitted a form, or typed something into an input field, we could have JavaScript functions run that responded to those events in order to make our web pages more interactive. Today, we're going to continue that conversation, in particular, taking a look at user interface design, looking at some common paradigms in terms of user interfaces, and how we can leverage JavaScript to be able to achieve those goals, to create interactive user interfaces that will be valuable when users are interacting with our applications. So one of the more common paradigms, especially nowadays in web programming, is the idea of single-page applications. Thus far, if we wanted to create a web application that has multiple different pages, we've generally done that via multiple different routes in our Django web application, for example, where you go to /something to get one page and /something else in order to get another page. But commonly using JavaScript, we have the ability to create single-page applications, where the entire web page is really just a single page. And then we use JavaScript to manipulate the DOM, to replace portions of the page with things we want to replace. And this has a number of advantages, one of them being that we only need to make modifications to the part of the page that is actually changing. If, for example, you have 5 different pages, but the general layout and structure of the page is pretty similar, when you switch between pages, rather than load an entirely new page, you can just load the part of the page that is changing. And this is especially helpful for applications that are changing quite frequently. So let's take a look now at how we could implement, for example, a very simple single-page application. So let's imagine, for example, that we want a single-page application that just displays 3 different pages, but all included in the same page. I'll go ahead and create a new file that I'll call singlepage.html, inside of which we'll include our usual HTML tags. And inside the body of this page now, I'm going to include 3 different sections of the page to represent the 3 different pages I might want to display to the user. So I'll have a div whose ID is page 1 that maybe just has a heading that says this is page 1. And you could imagine there's more content on these pages as well. A div whose ID is page 2. We'll say this is page 2. And then one final div whose ID is page 3 that has a heading that says this is page 3, for example. Now, right now, if I were to open up singlepage.html, what we'd see is we see all 3 pages at the same time. And now that's probably not what we want. What we really want is, by default, to hide these pages until we want to view the pages one at a time, for example. So one thing I could do is use CSS to be able to toggle whether or not something is visible, adding some style tags to my page to say that by default, all of my divs should have a display property set to none, meaning they're not visible. They're not displayed on the screen. Now, if I refresh the page, I don't actually see any of the 3 headings that I had there before. But what I'd really like is for some buttons now to allow me to toggle between these 3 pages. So I'll give myself 3 buttons. One button that says page 1, one button that says page 2, and one button that says page 3, for example. And I need some mechanism for these buttons to know when you click on this button what page should be displayed. So I'll go ahead and use data attributes, which we saw last time with JavaScript, to add some additional information to these particular HTML elements, where I'll give the first button a data-page value of page 1, the second one a data-page value of page 2, and the third one a data-page value of page 3. Here again, just providing information so that later, when I write some JavaScript, I can have the JavaScript code look at the data-page attribute to say that when you click on this button, you should let me see the div whose ID is page 1. That's what this is going to allow us to signal. So now let's go ahead and write that JavaScript. What I want to be able to do is to be able to say, I would like to show page 1 and hide the other 2, or show page 2 and hide the other 2, or show page 3, for example. And so to do that, I'll first write a function that will let me do that. I'll write a function called showPage that takes as its argument like what page I want to show. And so what should this function do? Well, what we're going to do is we're going to say document.querySelector. And I want to get the thing that has a particular ID, the ID of whatever this input happens to be. This page is going to represent the ID of the div that I want to show. So I'll say, get me the thing that has this ID. And then using a template literal, I'll say, all right, get me the ID of page, whatever element has that particular ID. And then I'd like to change its style property. Which part of the style? Well, I want to change its display property. And instead of none, which was the default here, where I said don't show it at all, the other option for a div is block, meaning it shows up as just a block that is on the page that is actually visible. And so now I have this showPage function. And I can test it, in fact. If I go into my browser, refresh the page, I now see 3 buttons. The buttons don't do anything just yet. But what I can do is in the console, if I actually just try running this, I can run the showPage function and say, like, showPage page 1, for example, press return. And all right, page 1 now appears on my page. And if I press showPage page 2, then page 2 will become visible. And all right, that did half of what I wanted. Page 2 is now visible, but so is page 1. So I probably want it such that if I ever show a page, I hide the other pages first. Like hide all the pages and then show page 2, or hide all the pages and then show page 3. So how could I go about doing that? Well, first, I might want to just, when I show a page, first hide all of the other pages, hide all the pages. So to get all the pages, I'll do document.querySelector all. Get all of the divs, which is what I'm using to enclose the pages. And now, for each one of those, again, effectively creating a loop where I'm looping over each of the divs, for each div, let's go ahead and set the div.style.display property equal to none. And so what this showPage function is now doing is it is first querying for all of the divs, which are simulating my pages inside of this single page application. And for each one of the divs, we're going to pass it as input into this function, which is the argument to for each, again, using this arrow function notation, which is just a shorthand way of expressing a function, where I'm here saying that for each of the divs, we'll go ahead and modify its style property, setting display equal to none, meaning don't show any of the divs, and then show only the div that was requested. So now this should solve the problem of multiple pages appearing simultaneously. That if I go back to this page and I click or write show page, page 1, then page 1 appears. But if I run show page of page 2, then page 2 appears, but page 1 disappears. And likewise, when I show page 3, that shows page 3, but not the other two. So I can manipulate which page is visible all via the console. But now what I'd like to do is get these buttons to actually work, where if I click on one of the buttons, that has the effect of actually displaying the requested page. So in order to do that, well, I want to attach some event listeners to these buttons, which means I need to wait until those buttons have loaded onto the page. So we'll use document.add event listener, DOM content loaded. Again, waiting until all of the content on the page has been loaded. And then and only then will I say, let's go ahead and query selector all for all of the buttons. And for each one of those buttons, let's go ahead and attach an event listener to each of those buttons. So I'm querying for all of the buttons and saying for each of the buttons, I would like to do this with each button. And what I'd like to do is say button.onClick when the button is clicked on. Go ahead and run this function. I'd like to show page. And which page do I want to show? Well, I want to show whatever page is in the page part of the button's data set. And to get it, the current button, the button that has been clicked on, recall that when we're inside of an event handler, we can take advantage of the JavaScript keyword this, which refers to whatever element has received the event. So whatever button in this case that was clicked on. So I can say this.dataset.page to mean that, all right, for each of the buttons, when the button is clicked on, we're saying button.onClick for each of the buttons. Run this function when the button is clicked. We'd like to show a page. Which page do we want to show? We'll take this button, the button that received the event, access its data properties, access its data page attribute, which are down here, either page 1 or page 2 or page 3, and go ahead and just call the show page function that we wrote a moment ago. So now that we've done that, we've attached these event handlers to the buttons. So now if I refresh the page, I can click on these buttons and toggle between any of the 3 pages. And now the interesting thing here is that we now have the ability to just, in a single page, allow myself to simulate the idea of having multiple pages, all enclosed in a single HTML file, but not needing to consistently make additional requests to a server in order to get access to that information. Now, sometimes, though, it might be reasonable to want to reach out to a server when you need new information for a page, for example. You might imagine that each of these pages contains a lot of text. It's going to be inefficient if immediately we're loading all of that data into HTML and just showing and hiding them when we need to, because maybe we're loading more information than the user is ever going to actually care about if they're never going to look at page 2 or page 3. So one thing we might imagine doing is loading this data dynamically. Last time when we were talking about JavaScript, we saw how we could use fetch to say, go ahead and request some additional information from a web server. Last time it was currency exchange rates. But then we used that data that came back in order to fill in something onto our page. And likewise, we could do a similar thing here, that if we have the general structure of a single page and we want to load new content, rather than load entirely new HTML content and reload the entire page, we can just ask our own web server for what part of the page needs to change, and then just replace that part of the page. And so that's what we'll take a look at now. Now combining Django for our web server and JavaScript for writing the client-side code to be able to generate a single page application. And so for this, we'll go ahead and go into an example I had in advance called single page 1. And inside of single page 1, this is just a Django application with a single app called single page. And what we'll notice is we'll go to the URLs first. There are 2 URLs. One default URL that just loads the index function, and then a URL for loading different sections of a page that I might want to dynamically load, for example. So I have section / some particular number. And if we look at the views for what it is these URLs are actually doing, the index function just returns index.html. And then what the section function does is it first makes sure the number is between 1 and 3, and if so, responds with one of these just strings of text, for example. So how does this actually work? If I go into single page 1 and run the server, if I go to this URL /section/1, for example, what I get is this block of text. And if I go to /section/2, I get that block of text. Section/3, a different block of text altogether. So just different text. And I'd like to incorporate this text into an existing HTML page, for instance. So here I'll go into index.html, this template that gets loaded when I go to the default route. And inside of index.html, what we'll see is I have a show section function that behaves very similar to the show page function we saw from a moment ago. But instead, what show section is going to do is it's going to fetch what text I should display on the page from my own web server. I'm fetching from /sections/ fill in a number here, number like 1 or 2 or 3. When I get the response, in the past, we've seen how we can convert that response into JSON data if it's some structured data. We can also just convert the response into plain text. Then I'll take that text, console.log it, just so we can see it in the log output, but then go ahead and query select for the content of the page, something that has an ID of content, update its inner HTML, and set it equal to that text. So what this entire function is now doing is it is going to reach out to my server, figure out what text content belongs in the new section, and fill in the part of my page accordingly with the text that comes back from that HTTP request. And then down further below, inside of the page, we'll see that I have a hello heading, 3 buttons that toggle between the different sections. Each of them has a data-section attribute this time for which section should be loaded. And then a div that is initially blank just for the content of the page. So putting this all together now, if I go to the default route, I see hello plus 3 buttons to give me a choice between 3 different sections. And if I click section 1, what's going to happen is JavaScript is going to query /section/1, ask for the text. It gets that text back, and it's going to fill it in into the page. Section 1, section 2, and section 3. So very similar to before, but unlike what we had before where all of the text was being loaded into the HTML page all at once, now we're using asynchronous JavaScript to only dynamically load information when we need it. When we click on a section, then it's going to make the request for what content needs to be filled in, and it's going to fill it in. And everything else, these buttons, this heading, and you might imagine in a more complex website, you've got a lot more going on around the edges of this web page. All of that stays the same. We don't need to reload any of that information. We're only reloading the portion of the page that actually changes as we toggle between these various different section headings. Now, this seems to be an advantage in some ways, that maybe we can be more efficient about how we run our single-page applications like this. One thing we seem to lose, though, is the notion of maintaining state inside of the URL. That generally the URL gives you an indication for what page you're on. You're on something like /1 if you're on section 1, or /2 if you're on section 2, /3 for section 3. But of course, we're staying on the same page in all of these examples. Whenever I click a button, section 1 or 2 or 3, the URL is never changing. The URL stays the same. It turns out there's a way in JavaScript to manipulate that URL, taking advantage of what's known as the JavaScript history API, where I can push something to the history, meaning update the URL and actually save that inside the user's browser history. So later on, they could potentially go back to that. And to do that, I'll show you yet another example inside of single page 2, which is very similar, except inside of index.html, I've added a couple additional things. One is that when I click on a button, meaning when I click on section 1 or section 2 or section 3, I've added this line here, history.pushState. What history.pushState is going to do is it is going to basically add a new element to my browsing history, where I first specify any data associated with the state. So in particular, I'm storing a JavaScript object representing what section number is being represented here. Next is a title parameter that most web browsers actually ignore, so that can generally be the empty string. But the third argument here is what should go in the URL. And what I want to go in the URL in this case is something like section followed by the section number. So I can go to /section1 or /section2 or /section3, for instance, and those will appear in the URL bar when I click on a different page. Then what I want to be able to support is the ability to say, when I go back through my history, if I click the back button in my web browser, I'd like to go back from section 3 to section 2 if that was the page I visited previously. And there turns out to be an event handler for that as well. Window.onPopState, meaning when I pop something off of the history, like go back in my history, we have the ability to take some event as an argument. And if you look at event.state.section, which I've run console.log on so we can take a look at it in a moment, we'll see what state was stored associated with that part of the user's history. And I can go ahead and show that section. So all in all, when I run this web application, going into single page 2 this time, when I run the server, I see hello, 3 sections for buttons. when I click on one of those buttons, not only do I see text, but I also see in the URL bar that I'm now on /section1. That has been pushed onto my history, and I've updated the URL to reflect that too. I click section 2, that updates the URL as well. Section 3 updates the URL too. And when I've pushed things onto my history, I've associated some state with them so that I can go back if I ever need to. And in fact, if I open up the JavaScript console now, and I go back, for example, back to section 2, what you'll see is that what gets logged is the number 2. When I print out, like, what is the current section that's associated with this URL, it's saving that state, that I should be loading section number 2. And so it does load section number 2 here. So there's certainly nothing wrong with the original paradigm of just loading different pages dynamically using Django, like make a request and get a response. But oftentimes, as you begin to imagine applications where a lot of things are changing on the same page simultaneously, you might imagine social networking websites where a lot of things stay the same, but new posts might be added, and you might be looking at different parts of the same page. Being able to dynamically load information, request additional information, and then display it on the page can actually be quite powerful, a way to make your web pages a little bit more interactive. So that then is how we might build single-page applications, taking advantage of JavaScript to asynchronously load new data, and then taking advantage of this history API that let us add things to the URL, add things to the user's browsing history, such that we could go back to them later by listening for window.onPopState. And it turns out that window object that we get access to in JavaScript is quite powerful. It represents the physical window on the computer screen that displays all of their web content. And there are certain properties of that window we can look at that allow us to enable some interesting features. So for example, your window is really described by what the user actually sees inside of their window in Google Chrome or Safari or whatever web browser they happen to be using. And there are a couple of properties that might be of use. Something like window.innerWidth will represent how wide is the window, which might be useful to know like the size of the user's screen, for example, to know how many pixels wide the window happens to be. And just as there's a window.innerWidth, there's also a window.innerHeight that represents the height of the window as well. Now, window represents the physical part that they're actually seeing. We've also seen another variable that JavaScript gives us access to, and that is this document object. So what is the difference between the window and the document? Well, the document generally represents the entire web page. But if web pages are long, oftentimes a web page doesn't fit entirely inside of the window, that you generally have to scroll through an entire web page, and the window is only showing you one portion of that page at any given time. So you can represent the document as like this big vertical section that goes beyond the window. There might be part of the document that is above the window, part of the document that is below the window as well. So window.scrollY is another variable you have access to on the window. And window.scrollY represents how many pixels far down have you scrolled. So if you're at the top of the page, window.scrollY is 0. You haven't scrolled at all. But as you begin to scroll, if you want to know how far the user has scrolled on a page, you can look at window.scrollY to figure out the number of pixels the user has scrolled in the y direction, the up and down direction. And the entire height of the page is represented in document.body.offsetHeight. That represents how tall the entire height of the document is. And we talk about all this in addition to things like window.innerHeight and window.innerWidth, because using all of these values together, you can begin to do some interesting calculations. So one thing you might want to detect, for example, is has the user scrolled down to the bottom of the page or not? That might be something you care about knowing. And it turns out there isn't an event listener that does this automatically, but we can calculate it in order to try and figure this out. If inner height is the height of the window, scroll y is how far vertically the user has scrolled, and document body offset height is the entire height of the document, you can ask yourself, what needs to be true if the user has scrolled to the bottom of the page? And well, if the user has scrolled to the bottom of the page, well then scroll y plus the inner height, meaning the amount that they've scrolled, plus the height of the window, that must be at least or equal to document body offset height, meaning the amount that they scrolled plus the window takes you down to the bottom of the page, to the end of the page, to however tall the document happens to be. And using that mathematical comparison, we can actually detect when the user has reached the bottom of the page. And we can actually try and now put that into practice. So I'll go ahead and open up an example that I have here called scroll.html. And all scroll.html has right now is 100 paragraphs. Inside of the body tag, I have a P for paragraph, paragraph 1, paragraph 2, so on and so forth. I have 100 paragraphs inside of the body of this HTML page. And that's all that really is there right now, such that now if I go ahead and open scroll.html, I see that I have 100 paragraphs that I can scroll through. And what I might like to do is detect when I've reached the bottom of the page, and maybe do something when I do so, something like change the color of the page, for instance. So how might I go about doing that? Well, I'm going to need some JavaScript. So I'm going to add some JavaScript. And I'll add an event listener for window.onScroll. OnScroll is an event that listens for when I'm scrolling through the window. And when I scroll through the window, we'll go ahead and run this function. We'll just use an arrow function as a shorthand here. What do I want to calculate? Well, I want to calculate if window.innerHeight, meaning the height of the window itself, plus window.scrollY, meaning the amount that I've scrolled, if that is at least document.body.offsetHeight, well, that means I must have scrolled to the bottom of the page, or maybe even a little bit further if there's a little wiggle room to scroll past the end of the page. So if this is true, well, then I've reached the end of the page. And then we'll go ahead and say document.querySelectorBody. And let's go ahead and change its style, in particular, change its background color, and change the background color to green. Otherwise, if we haven't reached the end of the page, then we'll take the body of the page and change its background color to white. So what we're now doing here is taking advantage of the properties we know of this window object, saying when we scroll the window, let's check to see if we add this up and at least the height of the entire document, we've reached the end of the page. Go ahead and change the style of the background of the body accordingly. Otherwise, change the background to white, or leave it at white if it already is. So now if I take a look at this actual HTML page and reload scroll.html, we'll see that the background is initially white. But as I scroll down, once I reach the bottom, we'll see that the page changes to green. It's white before I reach the bottom, but as soon as I get to the bottom of the page, it turns to green. And the reason why is because the height of the window here, plus however much I've already scrolled from the top of the page up until now, that together is equal to the entire height of the document, which means we're able to detect the fact that I've reached the end of the page. And as a result, we can change the color of the background to green. Now, this in itself is not a particularly practical use of detecting when we've scrolled to the end of something. We probably don't usually care about changing the background color when you reach the end of the page. But there actually are real applications. And you might imagine this in the context of websites that allow for things like infinite scroll. That if you're on a social networking site that has a whole bunch of posts, you scroll to the bottom of the list of posts, and then it generates the new set of posts as well. Or you're looking at news articles, and you're scrolling through news articles. And once you reach the bottom, it'll load a whole new set of news articles without you having to go to another page. How is it doing that? Well, it's a combination of the same types of ideas that we've been talking about. Number one, the ability to detect when you've reached the end of the page using JavaScript to detect that you're at the bottom of the page. And number two, to be able to asynchronously load, using JavaScript, load additional content. Fetch some additional page that has some additional content, some additional news articles, some additional posts and whatnot, and then take that information and manipulate the DOM to add that information to the existing web page. And that ultimately is what's going to give us this power to be able to support something like infinite scroll. So let's now go ahead and try and see what it would look like to implement infinite scroll. I've already started to create a sample application inside of this application called Scroll. And I've got an app called Posts inside of it. And what the Posts app does is it's got a couple of URLs. It's got a default URL that just loads an index route, and then a posts route that loads this posts view. And so let's look at what these do. Index, all it does is going to load a file called index.html, this template. And if I make a request to /posts, I need to provide two arguments. I need to provide a start for what post I want to start with, an end for what post I want to end with. And then it's just going to generate some sample posts that just say like post number 1, post number 2, so on and so forth. In practice, you could actually use social network posts in place of this. But this is good just for demonstration purposes. So what this is going to do, if I go into Scroll and run server, is that if I go to /posts and say start equals 1 and end equals 10, for example, then I get a JavaScript object that looks like this. Recall that a JavaScript object is just a convenient format for passing information back and forth in JSON format. And what we have here is a JSON object with a key called posts that gives me all of the posts, post number 1, post number 2, all the way up to number 10. And it's giving me those posts because I said start at 1, end at 10. But I could have specified other numbers as well. If I had said something like start at 20 and go to 28, then it's going to give me post number 20 through post number 28. I can specify the range of posts that I want. So this now is an API that I have implemented effectively that allows someone to get access to a variety of different posts by hitting this particular URL, this endpoint, so to speak, and passing in parameters, passing in what post they want to start with and what post they want to end with. And then they get all of this data back presented to them in JSON format that can then be used. And what's nice about this is that now when we're loading posts, rather than have to just guess at how many posts we need to load and then require someone to go to another page, we can just do something like load the first 20 posts. And now what we'd like to do is if they reach the end of the page, go ahead and load the next 20 posts by hitting this API endpoint, getting the next 20 posts, and then filling that into the HTML page. So let's see now how that actually works in practice by taking a look at that template in index.html. So we'll go into templates, index.html. And there's a fair bit of JavaScript here. But look at the body first. The body just has a div for all the posts that initially is going to be empty. Now here's what the JavaScript is going to do, and we'll walk through it. We start with the first post. So counter is going to keep track of what post we need to load next. By default, we're just going to start by loading post number 1. We have a variable called quantity that's going to tell us how many posts are we going to load at a time. Let's just say load 20 posts at a time. So start with 1 to 20, then 21 to 40, 41 to 60, so on and so forth. And when DOM content is loaded, go ahead and just call this function that's called load. And what the load function does is it figures out what the start and end should be. It fetches all the new posts. And then for each of the posts that comes back, it figures out what the So we're asynchronously asking for new posts. And what the add post function does is it creates a new div, populates the post inside of it, and adds it to the DOM. So now that we have these parts, the ability to load new posts as by fetching from some URL all of the posts that we care about, and then for each of those posts that comes back, add something new to the DOM as by creating a new HTML element and inserting it into the page, we have the ability to dynamically load all of these posts. So if I go not to /posts, but just to this default route, I'll see that we have something like 20 posts that all show up. But just 20 posts. Because every time I call the load function, that is going to load the next set of posts, for example. And so what I can do is in the console, if I try running the load function just by calling it myself, press return, after a second or so, the next set of posts show up, 21 all the way through 40. I call load again, the next set of posts show up, 41 through 60. 20 posts at a time, all using that asynchronous JavaScript. But now what I'd like to happen is for all of this to happen on its own, without me having to intervene and manually write JavaScript calls. I would just like to say, well, the same type of logic as before. Window.onScroll. Let's go ahead and say, if window.innerHeight plus window.scrollY is at least document.body.offsetHeight, meaning if I have scrolled to the end of the page, well then, just go ahead and call the load function. That's all these lines are doing. Every time I scroll, we check. Did we scroll to the end of the page? And if we did scroll to the end of the page, then go ahead and load the next set of posts. So now I refresh the page. I see post 1 all the way up through post 20. Now watch what happens when I get to post 20. If I scroll to the bottom, after a second, the next set of posts appears. I scroll to the bottom again. I'm at 40. And then after a second, the next set appears. Every time I scroll to the bottom, more posts are going to load after that, allowing me to effectively implement this idea of infinite scrolling by taking advantage of some JavaScript techniques, where I can check for when I've got to the end of the page and then dynamically do something as a result of that, something like load some additional pages onto the screen. And so here, too, a lot of power to be had inside of JavaScript. And a lot of where the power of user interface comes from is from how it is that the user interface interacts with the user, thinking about what the user is going to do and how the page should interact as a result. Something like user scrolls to the end of the page, and they see some new pages show up as well. And one technique we can use for just making HTML elements a little more responsive, a little bit more interesting, is by adding some animation to them as well, the ability for things to move around and change their properties in some way. And it turns out that CSS has support for animation. CSS has already given us support for things like styling elements, saying we want this element to be of this color and this size, for example. But it also gives us the ability to animate those properties as well, to change the size of something or change the position of something over some amount of time. And so let's now take a look at an example of what that might actually look like. I'll go ahead and create a new file, and I'll call it animate.html. And inside of animate.html, I'll go ahead and start by including our usual HTML. Title is animate. And what I'd like to do is just add a little bit of animation using CSS into this particular page. I'm going to start with just a heading that says something like welcome, for example. It's just going to display a welcome message, such that now, if I open animate.html, here's what I see. Just a message that says welcome. But now let's add some CSS to it. Let's go into the style tag. And for h1, for this heading, I'd like to apply a particular animation to it. And I first need to specify what the animation's name is going to be. And I can pick a name for the animation. I'll say something like grow, for example. I'll set the animation's duration to be 2 seconds. And then the animation fill mode is like, what direction should the animation move in? Should it go forwards or should it go backwards? We'll generally want our animations to go forward. So they're making some sort of forward progress according to some rules that we're going to specify. So here I'm saying we're going to animate all of our headings using an animation called grow. And now I need to define what that animation actually does. And to do that, up above in style, I'm going to say at keyframes grow. And what this is going to allow me to do is specify some keyframes for this particular element, meaning where should the element start, what should its style properties be, and then at the end, what should its style properties be. And CSS is going to take care of the process of figuring out what needs to happen in all those intermediary fractions of seconds, for example. So what I can say is something like go ahead and grow from, meaning what should its initial properties be. And maybe initially I want it to have a font size of 20 pixels. And then we'll say to font size of 100 pixels, for example. So all in all, what this is saying is I would like to apply an animation called grow to all of my headings. This animation should last 2 seconds and go forwards. And what is the grow animation going to do? Well, it's going to mean at the start, anything that obeys the grow animation will start with a font size of 20 pixels. And at the end, it will grow to a font size of 100 pixels. And I have now defined what it is that that animation means. So now, if I go ahead and refresh this page, animate.html, you'll see that welcome changes size. Over the course of 2 seconds, it goes from smaller to larger by obeying those keyframes. I told it to obey this particular set of instructions where it goes from a particular font size to another font size. And as a result, we see the effect here on the page. And it turns out you can do more than just manipulate size. You can manipulate just about any CSS property you want. So if I tell the heading that it should have a relative position, meaning its position should be relative to other elements or other things in its parent, I can say you should change your position from being 0% away from the left side of the screen to being 50% of the way from the left side of the screen. And at this point, grow is probably not the best name for this animation. I'll call it move instead. So animation name is move. And so now what this animation is going to do is it's going to say, when you run the animation, go from being right next to the left side of the screen to being about 50 away from the left side of the screen. So I can go ahead and rerun this. And we see that's the animation that takes place. It goes from the left all the way back up to about halfway across the screen. Refresh the page, and it goes ahead and does the exact same thing. And it turns out we don't just need to specify a beginning point and an end point for an animation. We can specify various different keyframes for different points within the animation that we would like to capture. Something like at the beginning of the animation, have this set of CSS properties. Maybe halfway through the animation, have a different set of CSS properties. And then at the very end, have yet another set of CSS properties. So I could say something like, if I want the heading not just to move from left to right, but also to move back again, I can say at the beginning, at the 0% point, when you're 0% of the way through the animation, you should be 0% away from the left-hand side. When you're 50% of the way through the animation, you should be 50% away from the left-hand side. And then when you're done with the animation, 100% of the way through, let's go back to 0% away from the left-hand side. I now have 3 keyframes: beginning of the animation, middle of the animation, back to the beginning of the animation again. And the effect of this is if I refresh the page, we go to the right, and then we go back. We're able to move one direction and then move back. And there are other properties we can use to manipulate these animations as well. I can set the animation iteration count, for example, to 2 to mean rather than just do the animation once and then stop, do the animation twice and then stop. So I refresh, it goes to the right, and then it goes left, and then it repeats that a second time. And it turns out if you really want, you can set this to infinite, to mean never stop performing that animation. It's consistently going to have this heading, move to the right, and then move left, according to those keyframes that I've specified. And so if you ever see things moving around on a page, interactive in some way, there are a number of ways to do it. You can animate things using JavaScript, for example. But there are many cases where CSS alone is pretty good at just creating these types of animations. And while this animation right now is just running forever, we could use JavaScript in order to control that animation as well. So let's see an example of what that would look like. I'll go back here. In the body of the page, in addition to a heading that says welcome, I'll go ahead and add a button that just says click here, for example. And now what I'll do is add a little bit of JavaScript. I'm going to add some JavaScript so that the button can now control the animation, decide when the animation is going to start and stop. And so what we'll do inside of this script is to first say document.addEventListener, DOM content loaded, meaning wait until the DOM is done loading, as we've done before. And let me now get that h1 element, document.querySelector h1. And initially, I'm going to set its style.animationPlayState equal to paused. So animation play state is a property of the style that lets me decide if the animation is playing or paused. And I can control that using JavaScript. Rather than just say run infinitely forever, I can say the animation play state should start out as paused by first getting the h1 element, then modifying the animation play state property of that particular element. But now what I'd like to happen is anytime someone clicks on the button, I want to change the animation play state. So I'm going to say document.querySelector button, meaning get that button. And when someone clicks on the button, let's run this function, where if the current animation play state is paused, we'll then go ahead and set animation play state equal to running. And otherwise, if it's already running, then let's go ahead and set the animation play state equal to paused. So all in all, what this function is going to do is it's going to get me the heading, pause this initially, and every time the button is clicked, run this function, where the function says if we're paused, go ahead and start running the animation. Otherwise, go ahead and pause the animation by modifying that animation play state property of the heading. So now if I refresh this page, right now we have welcome plus a button that says click here. And initially, everything is paused. There's no animation happening. But I click here, and that begins the animation, which would go on indefinitely, until I decide that I want to stop it, at which point I click it again, and the animation pauses. And I can control when to start and when to pause that animation as well. And so this can be helpful and nice when you want to create something a little bit more interactive, something animated on the page. But this is especially helpful because it means that you can gradually change CSS properties over time. Rather than just immediately change something, you have the ability to animate something to make it work a little bit better. So let's take a look at an example of how you might put that idea into practice. Let's go back to our posts example, where we had this infinite scrolling list of posts. But imagine now that we want the ability to hide posts when we're done with them. So I've prepared an example called hide, which is very similar to what we had before. But this time I've just added one extra button, and the button says hide on every single div. Right now, clicking the hide button does nothing. We'll go ahead and implement that in just a moment. But first, to see how this worked, if you go into hide, go into the index.html template, the only change that's been made here is what happens when I add a new post. Recall again that what this application does is it loads posts from a server. And then when it gets those posts, it loops over each of the individual posts, which is just a string of text. And it adds that string of text inside of an element onto the page via this add post function. And what the add post function is going to do here is first create a new element, create a div in which to store that post, give it a class name, because that's how we're going to animate it, and then set its inner HTML equal to the contents of the post, something like post number 1, post number 2, post number 3, and then add a button that just says hide. And then we're going to go ahead and add that to the DOM as well. So that's what add post is now going to do. We're sort of generating some HTML using this JavaScript code and then adding that HTML to the page. And now what we're adding is a div that has not only the contents of the post as text, but is also going to give us access to a button that ultimately we hope is going to let us hide that post as well. So how do we actually get the hiding of the post to work? Well, what we want to do is somehow detect when the user clicks on one of those hide buttons. So there's a number of ways we could do this. But one way is just to listen for any time anyone clicks on the document as a whole. Anytime anyone clicks on the document, I might like to ask something like, what did they actually click on? And it turns out that with most event listeners, the function the event listener takes in can take as an optional argument the event itself, which is a JavaScript object that contains information about the event that happened, like the click event, or the scroll event, or the key down event, or the key up event, for example. And one of the properties you get access to is event.target, which is like, what was the target of the event? In this case, what was the thing that was actually clicked on? And I'll go ahead and save event.target inside of a variable called element, where the idea now is that whatever gets clicked on, that is the event's target. We're going to save that inside of element. And what I want to know is element, is that one of the hide buttons? I want to know, is it a hide button? I could have also attached an event listener to each of the hide buttons. This is just an alternative way of doing it that I'm showing you for sake of demonstration, where we say when we click anywhere in the document, figure out what was clicked on, and save it inside of this variable. And if it's a hide button, then it's going to have a class of hide, right? Because I gave every hide button a class of hide. And so what I can say is, if element.className equals hide, well, that means that what was clicked on is something with a class of hide. We can assume that it is, in fact, a hide button. And then what I want to do is I can do something like element.remove to say, go ahead and get rid of that element. So now what does this do? If I refresh the page, let's try it. Post number 1, if I hide it, I want to hide post number 1. All right, that didn't quite work. It was close. It got rid of the hide button. But I didn't want to get rid of the hide button. I wanted to get rid of the whole post. So what's going on here is it seems to be that if the element's class name is hide, meaning I clicked on a hide button, element.remove just removes that element. It removes the hide button, but it doesn't remove the post that contains it. And if you think about this in terms of the DOM, the post is a div, and its child element is the button, this hide button. And so you remove the button, but it doesn't also remove the post as well. If you want to remove the post as well, you need to remove not the element, but the element's parent. And in JavaScript, it turns out there's a way to do that too. Rather than element.remove, I can say element.parentElement.remove to say take the element, get its parent, and remove that. So now I refresh the page. Now I see post 1. I want to hide it. I hide post 1. And all right, now I see post 2. And post 1 has gone away. If I want to hide post 3, I hide post 3. Now post 3 is gone. Now I go straight from post 2 to post 4. So this works, but it's also not immediately obvious what's going on. Like, because all of the posts are the exact same height, when I get rid of posts 1 and 3, it's not immediately obvious to the eye that they've gone away, because posts 2 and 4, they look almost exactly the same. You really have to be paying attention to know that the hiding worked. And so this can be a time where animation can actually be quite helpful. So what I can do is say something like, let's go ahead and give this post an animation associated with every post. We'll give it an animation name called hide. an animation duration of 2 seconds. We'll say it'll take you 2 seconds in order to hide. And an animation fill mode of forwards. I want to go forwards with the animation. And initially, I'll give the post an animation play state of paused. Meaning, initially, I don't want the animation to be running because I don't want to hide all the posts immediately. Pause this animation. Later, we'll go ahead and run the animation in order to actually hide the post. Then I need to define what does it actually mean to hide the post. And I'll say, well, all right, at the 0% mark, what does it mean? Let's give yourselves an opacity of 1. Opacity is a CSS property that just controls how opaque or how transparent an HTML element happens to be. And at the end, 100% of the way done with the animation, we'll set opacity to 0. So initially, we can fully see the element. At the end, the element is totally transparent. And now what I need to do is actually trigger this to happen somehow. So this is probably going to happen inside of my event listener, where instead of removing the element right away, let me just take the parent element and set its animation play state equal to running, for example. Meaning, when I click the hide button, go ahead and run the animation that will change the opacity from 1 to 0 over the course of a couple of seconds. And then, if I really want to, I can add another event listener to say, take the parent element, add event listener. There's an event called animation end, which happens when the animation is over. And then I can say, all right, when the animation is over, we'll then go ahead and remove the element. So all in all, rather than just immediately remove the element when I click on the button that says hide, what I'd like to do is say, if you click on a button and the button is hide, go ahead and get the parent element, not the hide button, but the post itself, set its animation play state to running, meaning run the hide animation, and then add an event listener to the parent, to that post as a whole, to say when the animation is over, go ahead and remove that entire post from the DOM altogether. So what is the effect of all of this now, of having this animation and running it? Well, now, if I refresh the page, I see all these posts. If I try and hide like post number 2, for example, you'll see that the opacity changes, and then it slowly disappears, and then only after it's totally transparent, the post disappears entirely. So I can say hide post number 4, it disappears, and then post number 5 jumps up to fill its place. And I can do that for any of these posts, triggering the animation when I click on the hide button. And so this is part of the value of what animation can do, is to be able to make our user interfaces a little more pleasant from the perspective of the user by not immediately getting rid of a post, but by having a nice fade out so it disappears nicely. Now, even this is not perfect animation-wise. Like one thing you might notice is that it jumps up as soon as the post is gone. If I hide post number 3, I hide it, it disappears, and post 5 sort of jumps up very abruptly in order to fill its place. What I might like is to be a little bit cleverer, to somehow shrink the size of the post after it's gone so that the post doesn't jump into place, but it slides a little bit more naturally into place. And so there's some additional things I can play with here. Maybe I want to say that, all right, let me make this animation a multiple part animation. So here, instead of just from 0 to 100% setting the opacity from 1 to 0, maybe in the first 75% of the animation, that will take care of reducing the opacity, going down from 1 all the way down to 0. But in the last 25% of the animation, we'll still end with an opacity of 0. But anything that creates vertical space, I want to reduce down to 0. So the height should be 0 pixels. The line height, which is how high the text is, should also be 0 pixels. Any padding I want to go away. It turns out I've added some margin to the bottom of the post. I want to make that go away as well. So I want to set all of those to 0 from whatever their initial values happen to be. That initially the height is like 100% of what the height could be. Likewise for line height, 100% of the parent. Initially I have like 20 pixels of padding and a margin at the bottom of 10 pixels. And I want all of that to still be true 75% of the way through the animation. But it's only in the last 25% of the animation that I want to set all of these vertical height properties down to 0. I want to remove all the height, remove the line height, remove all the padding. And the effect of this is I'll have an animation now where for the first 75% of the animation, the only thing that changes is the opacity. The opacity goes from 1, fully visible, to 0, fully transparent. And then in the last 25% of the animation, the post is already transparent. You can't see it. But it's still taking up physical space on the page. But we're going to now reduce the height of that post so that now you won't be able to see it at all. So now if I refresh this page, Here again are all the posts. But now if I click hide on a particular post, we'll see that it first fades out, and then its height shrinks so that the next post slides very nicely into place. I can do that again. Hide the post, it's transparent, and then it slides into place. And this, again, is just an application of this idea of CSS animations, using properties of animation to make our interfaces a little bit nicer to use, a little bit clearer visually to the user that one post has gone away and the rest of the posts have now scrolled up in order to take their place. So now we've been able to use JavaScript to create a lot of nice user interfaces. We've been able to create single-page applications, to create infinite scrolling, to be able to create some animations as well, and use JavaScript to be able to control them. But one thing you might be realizing at this point is that our applications are starting to get fairly complicated. There's a lot of JavaScript code needed to manipulate a lot of different parts of our application at the same time. And you can imagine that as web pages start to get more complex, and as you want to start making them more interactive and more dynamic, there's going to be a lot of JavaScript code required in order to keep everything in sync, in order to make sure that all of the elements are updated when they should, so on and so forth. And it's for that reason that in recent years, a lot of JavaScript has now turned to some JavaScript libraries or frameworks that allow to more efficiently and more effectively create user interfaces that are more interactive and more reactive. And one of the most popular of these is a framework known as React. React is a JavaScript library that is going to enable us to be able to design user interfaces that are very interactive, where the content of the web page updates automatically based on some underlying state. And what we'll do now is take a look at a brief taste of React to get a sense for how frameworks like it can actually work and can help us in designing some interactive and useful interfaces for users to be able to interact with. React is ultimately based on this idea of declarative programming, a particular style of programming which is different from the types of programming you might be familiar with, more classical programming styles like imperative programming. In imperative programming, you generally give the computer commands, tell the computer what to do. For example, if we had that counter program from before and we wanted to update the counter from one number to another number, in the view, like the HTML that the user sees, we would include something like a heading that just has the number 0 inside of it. And then the logic in imperative programming would take something like this form. It would be like, all right, first document.querySelector h1 to get that h1 tag, get it its inner HTML, parse int, we'll take the string and convert it into an integer, and we can save that inside of a variable called num, for example. And then after that, if I want to increase it, I would take this variable num and just add 1 to it. Num plus equals 1, add 1 to it. And then if I want to update this heading in order to replace the 0 with a 1, for example, well, then I would need to say document.querySelector h1, set the inner HTML equal to that number, for instance, in order to say, all right, num is now 1, go ahead and replace that in the view. But this is a fair amount of code to do something fairly simple, just like increase a number by 1. And the reason why is because we've had to be very explicit about what instructions we're giving to the web browser. We're saying first, grab the h1, figure out what number is inside of it, add 1 to that number, and then replace it inside of this tag. What declarative programming is going to allow us to do is it's going to allow us to just describe what state should be displayed on the page in what form. In declarative programming, in our view, like the HTML-like code that we're going to be writing, we're just going to say something like h1 and then in curly braces num to mean like fill in the number here. And this is what the React syntax is going to look like. And then the logic code, if we want to increment that number by 1, is we just need to say num plus equals 1. Add 1 to the number. And the effect of that is that since we have declared that inside of this heading, it should be whatever the value of the number is, when we increment the value of number, React is effectively just going to update the view so that the number updates as well. And so this will be some of the power that React gives us. React lets us divide our application into a whole bunch of different components, where a component is something like this thing here that is keeping track of some sort of count along with a button that might manipulate it, and then make that component based on some underlying state, some underlying variables that represent the state of the application, something like the current number. And then we can manipulate that state. And when we manipulate the state, that will have an impact on what the user actually sees. And React will handle the process of updating that user interface for us. There are a number of ways to get React working on our web page. But the simplest is probably just to include these 3 JavaScript packages inside of our web page. So we're first going to include React itself, which is going to be the library that's going to allow us to define these components and how they behave. Then is React DOM, a special package that's going to allow us to take React components and insert them into the DOM, the document object model that represents the structure of the entire page. And then finally, Babel is going to be a package that we're going to use in order to translate code from one language to another. It turns out that when we're writing React code, we're not actually going to be writing JavaScript. We're going to be writing in an extension to JavaScript known as JSX. And JSX is going to be an extension to JavaScript that looks a lot like JavaScript, but has some additional features. In particular, it has the ability to effectively allow us to represent HTML inside of our JavaScript code in a way that's much easier to read, and it's going to be convenient for us to deal with. Browsers, on the other hand, don't understand JSX automatically. So what we're going to use is a tool like Babel to convert that JSX code into plain JavaScript that our web browsers are ultimately going to be able to understand. The best way to get a feel for this kind of thing is just to see it in action. So I'll go ahead and create a couple of React applications just to get a sense for how it is that you can use React in your own applications as well. So let's start by taking a look at react.html. And what I have here is the beginning of an HTML page. Inside the head section, what you'll notice is I've already included these 3 script tags. And what these script tags are doing are just including those 3 JavaScript libraries we were talking about a moment ago. I have a title for the page just called React. And now let's start to fill in the body of this web page. I'll begin by adding a div, which I'll give an ID to. I'll call it app, but I could call it anything. And this is where our application is going to go. But right now, I'm just going to leave it as empty. It's going to be React's job to fill in this div with the contents of our user interface. And now, beneath that div, I'll start to write some JavaScript. But remember, I'm not going to be writing JavaScript per se, but rather JSX, that extension to JavaScript. So in this case, I'll need to add an extra attribute. Type equals text/Babel. And all this is doing is telling my browser that it's going to need to translate this JSX code into JavaScript code that the browser is actually going to be able to understand before it tries to run this code. In practice, if you were developing a real application, what you would want to do is you would want to do this translation ahead of time prior to deploying the application. But here, we're just going to translate it on the fly. And so all of our React applications are going to be composed of components, where a component is just some part of my web application's user interface. And to describe a component, I can write a JavaScript function. So I'll create a function called app, which is going to represent this app component. And what's going to go inside of this app component? Well, it's a function, so it's going to return something. And what it's going to return is what should appear inside of that component. And this app component could really just be, for example, a div that says hello, let's say. And this is where the power of JSX really starts to come in. That here I can write HTML-like syntax inside of my JavaScript code, and JSX is going to be able to understand it. So this function right here is a function called app that is representing a React component. And when this component is rendered onto my web page, it's going to say hello. So there's one last line I need inside of my JavaScript now, and that is to actually render this component into the page. To do that, I'll say React DOM.render. And the first argument to this function, React DOM.render, is what component would I like to render. The component is this app component that I just created. And so I'll say app, again, using this HTML-like syntax. And then the second argument is where on the page would I like to render this component. And I want to render this component right here on line 10, where I have a div whose ID is app. So I'll need to add some JavaScript code to find that particular div. And to do that, I can just say document.querySelector, and then hash app to say find the element with an ID of app, and that is where I would like to render this app component. So I first created this empty div. Then I defined this function representing a React component. And then after that, we're going to render that component inside of the HTML page itself. So now if we were to open a browser and see what this page actually looks like, I'll make the text a little bit bigger. You see that we actually do see the word hello. And if I make a change to the component and refresh the page, it will change the page as well. So if the component instead displayed hello world, well, then I refresh the page, and the page now also says hello world. And because this is JavaScript, I can add JavaScript code to the function just as I could with any function in JavaScript. Imagine, for example, that I had some variables. like let's create a variable x, which is equal to 1, and a variable y, which is equal to 2. Inside of this div, rather than just render some text, I can use curly braces to say plug in the value of some JavaScript expression. I could plug in the value of x plus y, for example. And now by including x plus y in these curly braces, JavaScript is going to evaluate what is x plus y and display that inside of the div instead. And so now when I refresh the page, you see that the page just says 3, for example. And so that's the basics of React. We create these components and then render those components all using the power of JavaScript. But where React starts to get more powerful is when we can reuse components. The whole idea of a component is it represents some part of the user interface, and I could reuse that same component across multiple parts of the interface as well. Imagine, for example, that inside of my app component, I was going to render a div that had 3 headings, each of which said hello. So there's one heading, there's another one, and we'll add a third one there as well. So I have a div with 3 headings inside of it. And we can see what that looks like. Each one of them says hello. But there's some repetition here. I'm having to use this h1 tag 3 times, all to create exactly the same UI element on the page. This is a case where I can create a separate component and then just reuse that component rather than have to repeat myself multiple times. So how could I do that? Well, remember that in JavaScript, we can write a function to represent a React component. So I'll add another function here. And I'll call that function hello, because it's going to represent this hello component. And this hello function is also going to return something. And what it's going to return is a heading, an h1, that just says hello. And so now, inside of my app component, rather than render 3 separate h1s, I can simplify this a little bit to just say hello. Here I'm saying go ahead and render a hello component here. We'll render a second one, and a third one after that. Each time I render a hello component, it's going to display as this heading that just says hello. So I refresh the page, and nothing changes. I still see 3 headings, each of which says hello, because inside of my app component, I'm rendering this hello component 3 times. Each time, it's going to display this h1. But where components start to get more powerful is when they're not always displaying the same information every time, but when we can parameterize those components with properties, or as React simplifies them, props, short for properties. So what would that mean? We see that HTML elements can take attributes. Likewise, React components can take properties, where maybe I don't just want to say hello, but I want to say hello to someone, hello to Harry, or to Ron, or Hermione, for example. So I could say hello name equals Harry, using syntax much like an HTML attribute. Then here say hello name equals Ron. And then finally hello name equals Hermione. And so now my hello component is accepting this prop, this property called name, which is different for all 3 of these components. And so inside this hello function now, I would like the hello function to take advantage of these properties, of these props. And so I'm going to add an argument to the hello function. That argument is conventionally just called props. And now, instead of just saying hello, I'm going to say hello, comma, and then remember to plug in a JavaScript value. I use curly braces. And inside of those curly braces, I can say props dot, and then whatever the name of the property is. In this case, the name of the property is just name. So I can say props dot name to say whatever the name prop is, go ahead and plug that in right here inside of the hello component. So the hello component is going to say hello, comma, and then someone's name. So I can save that, refresh the page, and now I see hello Harry, hello Ron, and hello Hermione. 3 different components, each of which is still just this hello component, but we're rendering it with different props. One time with the name of Harry, one time with the name of Ron, and one time with the name Hermione. And so this is where components can start to get a little bit different. By passing in different props into those components, we can decide how that component is ultimately going to render. But let's add to this a little bit and start to add state into our React components as well. And state is going to mean any kind of data that we want to store inside of the component itself. And for this, let's try to recreate the counter application that we created when we first introduced JavaScript, where we were really just creating a button that allowed you to count, and it counted up from 0, 1, 2, 3, 4, etc. So to do this, let's create a new file. I'll create a new file and just call it counter.html. And we can start just by copying the contents of react.html into our counter.html file. We're still going to use those same script tags. We can still have an app component. But what's going to be inside this app component is going to be a little different. I'll change the title of the page to be counter instead of React. So what goes inside of the app component? Well, if we're going to do this counting, we need a div that's going to display the number that we've currently counted to, something like 0 to start with. And we're going to need a button. This button is just going to be count, which will be the label for that button. So a div that just says 0 and a button that says count. And now if I open up counter.html, we'll make it a little bigger, you can see that I have this number 0 here and a button that says count. Of course, right now, clicking on the button doesn't do anything, because I haven't written any JavaScript code to say what should happen when this button is actually clicked on. But before we get there, let's modify this program a little bit. Right now, I've written the number 0 directly into the div itself, but it's not always going to be 0. Eventually, as I start counting by pressing that count button, that number is going to change. So what I'm going to do now is factor this 0 out into what's known as state inside of my React component. And here, one way to create state in my React component is to use a special function inside of React called useState. This is one example of a React hook that allows me to add some additional functionality into my React component. And the argument to react.useState is going to be the initial value of that state. I'm going to start counting, and I want to start counting from the number 0. So I'm going to include the number 0 as the argument to this useState function. So we're going to start counting at 0. And what this useState function returns is really an array of two things. It's going to be a variable that I can give a name to. I'll call it count. And also a function that I'm going to call setCount. And that function is going to allow me to set the value for the state if ever I need to change the state at some point in the future. So this useState function accepts 0, the initial state, as its argument. And then I get two things back. I get the state variable itself, called count, and I get a function for changing that state when I need to. So now, instead of rendering a 0 inside of the div just by writing the number 0, I'm going to instead, in curly braces, go ahead and render whatever the value of count is. Initially, it's going to be 0, but eventually that number might change, and I want my UI to reflect the changes in the underlying state. So right now, if I refresh the page, it still says 0, because the initial state was set to 0, but I could change that. If initially that initial state was some other value, I could refresh the page and see a different value appear for the count instead. Whatever the value of this count variable is in the state, that's going to be what the user is going to see when they're looking at my user interface and when they see my component. So now let's make this button actually do something, because right now the number is never changing. To do that, I can add an onClick handler. And notice one difference between onClicked in React and onClicked as we traditionally used it in JavaScript. I'm using this capital C. And that's just a common React convention when we're defining event handlers. And here I'm going to say onClick, and then in curly braces, the name of a function that I would like to run when this button is clicked. And I can call that function whatever I'd like. I'll call it update count, for example. And now what I need to do is define a function called update count. And I'm going to define that function inside of this React component, inside of my app function. It turns out in JavaScript, you can have functions that are defined inside of other functions. So I'll define this function called update count. And what do I want the update count function to do? Well, what I'd like to do is just increase count by 1. And you might think that I could do that just by saying count equals count plus 1. But it turns out you can't quite do that in React. In React, whenever I'm using this useState, if I want to change the state, I have to use this function that useState provides to me for whenever I want to set the new value of the state. So rather than count equals count plus 1, I have to use this setCount function. And the argument to setCount is going to be count plus 1. So setCount is this function that is going to change the underlying state inside of my component. And the argument is, what should the new state be? And in this case, it's just going to be count plus 1, one more than whatever the count was before. So I can save that. And I'll go ahead and refresh the page. It starts out at 0. But every time I click on this count button, you'll notice the count increases by 1. And again, I have no code that's saying go into the div and change whatever is inside of the div. All I have inside of this div is this reference to this state variable count. And whenever the state changes, JavaScript and in turn React knows that what React needs to do is to recreate this component, re-render the component by displaying the new value of this state variable. And then when the button is clicked on, we're able to run this function to change the value of that underlying state. So by taking advantage of these React components with state, we can start to represent information inside of our components and then define what our component is going to display as just by representing HTML in terms of that underlying state, deciding how we should use that state in order to render an interface that the user is ultimately going to see. So let's now try and put these pieces together and create a web application that uses these abilities of React to define state and to manipulate that state, and in turn, update a user interface based on changes that are happening to that underlying state. And we'll create an application that will just display some simple mathematical questions to the user and quiz the user on some basic addition facts, for example. So let's create that application. I'll create a new file and call it addition.html. And inside of addition.html, I'll start again just by copying the contents of this counter.html file, because the framework, the structure of this page will be similar. But I'll go ahead and clear out what's inside of my app component, at least for now. And so what would I like for my app component to render? Well, let's go ahead and render a div. And if I want to create an application that's going to ask the user some mathematical questions and then prompt the user to type in an answer, there are at least two parts of this user interface that I'm going to need. I'm going to need a place to display the addition fact answer, like what is 1 plus 2, for example. And then I'll need an input field where the user can type in their response to that question and then see if they got the question right or wrong. So inside the div, I'll start by creating a div that displays the question itself, something like 1 plus 2. And then beneath that, I'll just add an input field. Eventually, we'll add more to this user interface. But for now, all we really need is a div that displays the mathematical question and an input for the user to type in their response. So now if I go ahead and go to addition.html, here's what I see. I'll make it a little bit bigger. I see 1 plus 2, and then an input field where the user could start to type in their response. But just as we did before, I don't want to literally write the numbers 1 and 2 into what I'm returning. Instead, I want these 1 and 2 to be based on some underlying state inside of my application. The application is going to maintain state about what two numbers to add together, and then it's going to display a user interface based on that state. So what could I do here? Well, one thing I could do is, again, use react.useState, start this number off as 1, and maybe call this num1, and then a function to set number 1. And then I could do it again. Let's create num2 and set num2 to be react.useState2. And I could have two different pieces of state, num1 and num2, each of which has a different function, set num1 and set num2, that are each representing the two different numbers that I would like to add together. But already this is starting to get messy, and over time, as I add more different pieces of state to the application, as we'll see in just a moment, the state might start to get more and more complex with more and more different functions and variables. So it's often helpful, and a common practice in React, to combine multiple pieces of state just into one JavaScript object that's maintaining all of the different pieces of state for this particular component. And to do that, I'll again use react.useState. But instead of setting the state initially to be a number, like 1 or 2, it's instead going to be a JavaScript object that has keys and values, where I could say let num1 be the number 1, and let num2 be the number 2. Much like a dictionary in Python, for example, where I have multiple different values, num1 and num2, all together inside of the same object. And I can call that state and have a variable and have a function called setState that is going to update the value of that state. And so rather than have to have all of these different variables, I can simplify a little bit to just state and a function to set the state. And the state now has these two different pieces, number 1 and number 2. And so now, instead of rendering literally the number 1, using curly braces, I can say state.num1. And instead of rendering literally the number 2, I can say state.num2, drawing upon that state to decide what it is going to appear inside of the user interface. And so right now, the page appears no different. But if I were to change those initial values of the state, maybe make it 2 and 4, for example, and then refresh the page, well, now it displays as 2 plus 4. And so that's helpful. We now have a user interface where the numbers are based on the state. But now what I'd like to do is add the ability to keep track of what the user typed in so we can tell if the user correctly typed in the answer to this mathematical problem. And how would I do that? Well, the state represents any information that we need to keep track of inside of this component. And so in addition to storing the two numbers inside of the state, I likely also need to keep track of a third piece of information, which is the response. What did the user type in into this text field? And so I'll add a third part of the state called response that initially will just be the empty string, will just be nothing. And then this input field, I'm going to give it a value, and the value is going to be state.response. Whatever the user typed in as the response, that's stored inside of the state, and that is going to be the value of what shows up in the input field. And so that way, whatever is in the input field will have access to it inside of this state.response variable. But there is a problem. And here's the problem. I'll try refreshing the page. I'll go into this text field, and let's say I know the answer. I know 2 plus 4 is equal to 6. I'm now going to press 6 on my keyboard. But as I press 6 on the keyboard, nothing's happening. No 6 is appearing inside of the text field, even though I am pressing the key on the keyboard. So why is that? Why is the text field not updating? Well, the reason is the value of the input field, whatever appears in the input field, is this value, state.response. And state.response is always this empty string. I'm never changing what state.response is equal to. And so I need to change this a little bit. I need to add as an attribute to this input field onChange, meaning when the input field changes, I need to do something. And I'll call a function that I can call updateResponse. But again, I could call that update function whatever I'd like. It's just the name for the function that's going to run whenever something changes in the input field. So let me now define that updateResponse function. I'll define a function called updateResponse. And because it's an event handler, it can accept an argument, which is the event itself, the fact that something has changed inside of the input field. And when I have access to this event, it turns out that if I want to figure out what it is the user has typed into the input field, I can get at that with event.target.value. And I'd only know that by looking at it in the documentation. But what I'd like is for event.target.value to be the new value for this response. And so what I'd like to do is do something like this. Set state. And what should the new value of the state be? Well, I would like for response to no longer be the empty string, but to now be event.target.value. And that is going to be the new value for response. But I'm not quite done yet, because state doesn't just have response as one of the parts of the state. The state also has num1 and num2. And those two pieces aren't really changing. So I could say, all right, num1 is just going to be whatever state.num1 was, that's not changing. And num2 is going to be whatever state.num2 was, that's not changing. The only thing that's changing is the response. But this is starting to get a little bit verbose, and especially if I start adding more and more different pieces to the state, it's going to become difficult to manage if I constantly have to repeat myself for all of the parts of the state that aren't changing. Ideally, what I'd like to do is just specify the parts of the state that will change and ignore everything else. And so one shorthand way to do that in JavaScript is to use what's known as the spread operator. And it looks like this, ... and then state. And what this is saying is just use the existing values of the state for everything else, like num1 and num2. The only thing to override is the new value for the response. And so this syntax here is my way of saying I would like to update the state. Everything should stay the same except for response, which is now going to be event.target.value. In other words, whatever it is the user typed in into that input field. And so I'll go ahead and refresh the page. And now if I type a number like 6, you actually see that number appear in the input field. So that's great. We've now displayed a question where the numbers are stored in the state, and the user can type in a response where that response is also stored in the state. Now what I'd like is when the user presses the Enter key on their keyboard, we check, did they get the answer right, or did they get the answer wrong? And so how would I do that? Well, the first thing I need to do is in this input field, somehow detect when a key is pressed. When a key is pressed, what I'd like to do is check to see if it was the Enter key. And if it was the Enter key, then let's go ahead and check to see what the actual sum of the two numbers is and see if the user got that right or wrong. So let's add an event handler. On key press is going to be equal to something. Again, I can name this function whatever I'd like. I'll call it input key press. But again, I could name that anything. And now let's define that input key press function. So up above, I'm going to define this function called input key press. Again, it takes that event as its argument. And this event is going to happen anytime a key is pressed, regardless of whether it's a letter or a number or the Enter key. And so I want to check to make sure that the key is actually the Enter key. That's the only time that I want to now check to see if they got the question right or wrong. So I'll add here a condition. It's just JavaScript. So I can say if event.key is equal to Enter, well then, let's go ahead and check. And otherwise, we don't have to do anything. I don't need an else case here because nothing should happen unless it's the Enter key that was actually pressed. And so now, how do I check to see if the user got the answer right or wrong? Well, inside of state.num1 is the first number. And inside of state.num2 is the second number. So I could have a condition that checked if state.num1 plus state.num2 is equal to state.response, which is what the user typed in into the input field. But that doesn't quite work, because state.response, that's a string. The user doesn't necessarily have to type in numbers. It's possible the user is going to type in some letters instead, for example, or other characters instead. And so what I'm going to do first is convert the response into an integer if we're able to do so. So I'm going to define a variable called answer using the JavaScript function parseInt that takes a string and tries to convert it into an integer. So we're going to parse the int state.response. And now we can check if number1 plus number2 is equal to the answer. Well, then this means the user got the question right. And else, if the sum is not equal to the answer, that means the user got the question wrong. And so now what I could do is handle those two different scenarios. In one case, the user got the question right, and we should do something. And in another case, the user got the question wrong, and we should do something else. And we're making that decision by looking at the state of the application, by looking at what two numbers we're supposed to be adding, and looking at what the user typed in as their response. So what should we do when the user gets a question right or gets a question wrong? Well, maybe this game is going to keep score by maintaining a number for how many questions the user has gotten right. And every time the user gets a question right, we could increase that score by 1. And any time the user gets a question wrong, we could decrease that score by 1, for example. So how would we do that? Well, the score is some piece of state inside of the application. And so we're going to need to add to the state. Right now in the state, we're storing a number1, a number2, and a response. I'll add to that a score, where the score is going to start out as just 0. And we can render that score on the page. If I scroll down to where we're returning the div to render, let's add another div that says the score is, and then using curly braces, plug in whatever the value of state.score is. Whatever the score is, let's figure that out from the state, and let's display that in the user interface. So now this user interface shows not only a question and an input field, but also a score. And the score starts out as just the number 0. So let's now go back to this function. When a key is pressed, if it's the Enter key, let's check to see if they got the answer right or wrong. We check, did the user actually get the question right? If so, what should we do? Well, we should increase the score. And how do we do that? We do that by calling the setState function. All of the state is going to be the same, so using that ... state spread operator. The only thing that's different is the score is going to be state.score plus 1. So we're updating the state to increase the score by 1. And if the user gets the question wrong, let's set the state to be ... state, and then the score is going to be state.score minus 1. So if the user gets the question right, we increase the score by 1. Otherwise, we decrease the score by 1. And let's test that to see what it actually looks like when we try this in the user interface. I'll refresh the page. 2 plus 4. If I type in the correct answer, 6, press return, the score increases by 1. If I typed in the wrong answer, let's say 8, press return, the score decreases by 1. So this appears to work. Depending on whether I get the question right or wrong, the score is able to update, increasing or decreasing based on the result of that condition. Now, this game is pretty easy to get a high score on right now because I can just keep pressing return over and over and over, and the question's never changing. My response is already there, and so the score keeps going up and up and up. So let's make the game a little bit more interesting. Every time the user gets a question right, let's display a new question for them to answer. And how would we do that? Well, the question that's displayed to the user is based on two underlying pieces of the state of the component. It's based on state.num1, and it's based on state.num2. So if I want to change the question, all I have to do is when the user gets the question right, and I'm updating the state, instead of only updating the score, let's also update num1 and num2. And I could set these to be specific values, maybe like 5 and 10, for example. But let's make it more interesting and display a random number every time. We'll generate a random number, and so the user will be adding two random numbers together every time they get a new question right. How do we generate a random number? Well, math.random is a JavaScript function that generates a random number between 0 and 1. We can multiply it by 10, so now we're getting a number between 0 and 10. But we don't want any decimals to appear in the number, so I'll go ahead and take the ceiling of the number, math.ceil, to say if the number was like 5.8, we'll just go ahead and round that up to 6, for example. And we'll do the same thing for number 2. We'll take the ceiling of math.random times 10. So every time the user gets a question right, we'll update num1 and num2 to be new random numbers generated just like this. And so let's go back and try it again. We see 2 plus 4. I type in the correct answer, 6, and the question changes. 8 plus 5, I type in the correct answer, press return. My score increases, and the question changes again. This time, if I get the answer wrong, I type in 10, for example. Watch my score decrease. It went from 2 down to 1, but the question didn't change. Now I get another opportunity to try to answer this question. And when I answer it correctly, the score increases again from 1 to 2. So this game is starting to come along now. It's keeping track of my score. It's displaying different questions. There is at least one user interface quirk right now, and that is the fact that at the moment, when I get a question right and press return, I type in 6 and press return, the 6 still stays there. Ideally, I get a new question. I'd like to clear out the response so the user can just type in whatever the new answer is, rather than have to delete whatever they typed in before and then type in a new number. So how could we do that? Reset whatever is inside of the input field. Well, what's typed into the input field is stored inside of the state of my component. It's stored inside of state.response. And so if I wanted to change that, all I would have to do is say, let's change the response to be the empty string. When the user gets a question right, we're going to update these two numbers, increase the score, and also clear out the response so that it's just the empty string. And I can do the same thing if the user gets a question wrong. Decrease the score by 1, but also clear out that response back to the empty string so that there's nothing there. And so now we get a question. I type in an answer, press return, and the input field clears out. I get a new question, and the score increases by 1. 4 separate pieces of state, all changing at the same time, and that gets reflected in the user interface that I'm now able to see. So I type in another value, and the score increases, and everything updates again. All right, so that's definitely progress. One other user interface quirk that I noticed here is that the input field, by default, isn't automatically selected, where I would have to go in and click on the input field in order to highlight it so that I can start typing in my response. I can fix that pretty easily. If I scroll down to where the input field is, we'll add an autofocus attribute and just set that to be true. so that the input field automatically focuses when I load the page for the first time. So now I refresh the page, the input field is already highlighted, and immediately I can start to try to play this game. So now that we have the basic functionality of this app working, let's try and improve the CSS so that the game looks a little bit nicer. I'll scroll up to the top of the page and add a style tag to the head section of my HTML page. And I'd like for this entire app to be centered. So I'll say text align is going to be center. And I'm going to set the font family to be sans serif, because I prefer that font for this particular game. So I refresh the page, and now everything is centered, and the font is different than what the default was. And what else would I like to have changed? Well, this problem, 2 plus 4, maybe I'd like for that to be bigger. I'd like the problem to be big, and the score beneath that, that can stay the same size that it is right now. So how would I do that? Well, if I go back to the HTML here, I'll go ahead and give this div where I'm displaying the problem, number 1 plus number 2, I'll give it an ID of problem. And then if I scroll back up, I'll say for the element with an ID of problem, let's go ahead and set the font size to be 72 pixels, for example, just to make it bigger. And so now I see a big math equation, 2 plus 4, for example, the input field, and then the smaller score beneath it. So that's a nice UI enhancement a little bit. And now I can play the game, get a question right, and the score increases. I get a question wrong, and I get to try again. But maybe I'd like to offer more of a visual indication that the user got a question wrong. Maybe any time the user gets a question wrong, I'd like to change the color of this text. Instead of being black, instead it should be red when the user gets a question wrong. And how could I go about doing that? Well, we can change the color of something just by using CSS. If we had like a class called incorrect, for example, if I scroll down here and give this div a class name, which is how you add a class in React, of incorrect, then I could use this class name to style it as red or not red. So I could say anything that has a class of incorrect, let's go ahead and give that a color of red. And so now, because I gave this problem a class of incorrect, and I said turn all incorrect text to be red, we now see this text appear as red. But this, again, is not quite what I want. I don't want it to be red all of the time. I only want it to be red when the user has just gotten a question wrong, when they were just incorrect in answering a mathematical question. And so how could I represent that information inside of my application? Well, I'm going to need some additional state. State, again, is any information that I need to keep track of inside of my component. And now it seems that in addition to the response and the score and the numbers, I also want to keep track of, did the user just answer a question incorrectly or not? So I'll add another piece to the state. I'll call it incorrect. And initially, it will be false. They didn't just get something incorrect. And now here, if I scroll down to this class name, rather than have it be incorrect all the time, let me add, in curly braces, an expression. I'll say if state.incorrect is true, using the ternary operator with a question mark, then the class should be incorrect. But otherwise, it shouldn't have a class of incorrect. It'll just be the empty string. And so this expression here allows me to change the class of an HTML element based on the underlying state. If state.incorrect is true, then this div will have a class of incorrect, and otherwise, it won't. And so now when I load the page for the first time, the text appears as black. And what I need to do is when the user gets a question wrong, I need to change the state to indicate that they just got a question wrong. How do I do that? Well, here is the set state call when the user gets a question wrong. And in that case, I'll go ahead and set incorrect equal to true. And when the user gets a question right, we'll go ahead and set incorrect equal to false. We're modifying this one additional piece of state based on whether the user got the question right or wrong. So now, if I load the page, answer a question correctly, the score increases, and I get a new question. But if I answer a question incorrectly and press return, you'll notice the score decreases, the input field clears out, and the text changes color, because I changed the value of that incorrect part of the underlying state. And based on that, we were able to see the text color change as well. If I now get a question correct, press return, the text color changes back to black, and the score increases. And let's now add one final piece of state, or one final change to the UI for this application. Let's give me a way to win this game. Maybe once I get to a score of 10 by answering 10 questions correctly, then we're going to win the game. And how could I do that? Well, remember that each React component can just be a JavaScript function. And this function is just immediately returning this div. But it's a function, so I can add additional logic to it. I can say if state.score is equal to 10, for example, then rather than render the old div, let's return a new div. This div is just going to display something like U1. And so that I can style it, I'll give it an ID. The ID will be winner. And if the ID is winner, let's go ahead and make the font size 72 pixels. And let's make the color green if I win. So I added some CSS just to style it. But really, the only new logic is further down below, where I'm here saying, check the state. If the score is 10, well, that means we win. So instead of returning the new problem, just return a div that says you won the game. So let's try that now. I get these questions. Every time I answer a question, you're noticing that the score is going to increase by 1. And every time we're generating new random numbers to display as what's going to appear in the user interface. And once I get to question number 10, if I answer it correctly, press return, the entire UI changes. Instead of the problem and an input field and a score, I just see in green large text that I won. And again, I was able to do that by looking here at this condition, where we're looking at the value of the state. And if the state is 10, we're deciding what to render. And this, again, is one of the great powers of React, this ability to use this underlying state, and based on the value of the underlying state, decide what it is the user should see in their user interface. And React is just one of many libraries that do this type of thing. Other popular ones include Angular and Vue, where all of these are just these web frameworks that make it easy to be able to create applications that are able to respond to some underlying state, so that you, the programmer, don't have to worry about constantly having to manipulate various different parts of the page, which especially as you imagine websites like Facebook or Twitter, where there are many things happening on the page at the same time. Every time a new tweet comes in, you might get a notification and see a new post in your main area of your news feed. So these are the types of things that you might want the application to be able to more easily handle for you, where you describe what the state is, you describe what the page should look like based on that underlying state, and let the library, whether it's React or something else, begin to handle the process of doing that for you. And the world of user interfaces is changing pretty quickly. That a lot changes in user interfaces in terms of the technologies and the tools that are quite popular. But they're really based on the same set of underlying ideas. The idea that we can use JavaScript in order to manipulate what it is the user sees on their page, in order to detect what's happening based on particular events, like scrolling to the bottom of the page or typing something into an input field, and then responding to those particular events by providing some sort of function that gets called anytime a particular event happens. By mixing that in with other features like the ability to asynchronously request information from an external server, or the ability to do computations based on the values of the state like we saw within React, we have the ability to create very interesting, engaging, dynamic user interfaces very, very quickly, all just using the power of combining Python and JavaScript. That was web programming with Python and JavaScript for today. We'll see you next time. OK, welcome back, everyone, to web programming with Python and JavaScript. And now, at this point, we've seen a number of different techniques and tools that we can use in order to design web applications. HTML and CSS to describe how it is that our pages look. A programming language like Python, using a framework like Django, in order to listen for requests, process them, and provide some sort of response. And then more recently, we took a look at JavaScript, another programming language that we can use in particular on the client side, running inside of the user's web browser in order to make our web pages even more interactive and user-friendly. Now what we'll transition to today is taking a look at some of software's best practices, some tools and techniques that developers actually use when they're working on web applications, especially as those web applications start to grow larger. In particular, we'll start by discussing testing, this idea of verifying that our code is correct, and then transition to CI/CD, short for continuous integration and continuous delivery, some other best practices that are used in making sure that the work that software developers are working on can be tested and deployed readily and very quickly. So we'll begin the conversation with testing. And testing is really about this idea of verifying and making sure that the code that software developers are writing are in fact correct, to make sure that the functions work the way they're supposed to, that the web pages behave the way that they are supposed to. And ideally, we'd like some way to be able to efficiently and effectively test our code over time, and as our programs grow more complicated, to allow our tests to make sure that our program is behaving the way that we want it to. So we'll go ahead and start simple and consider the basic way that we might take a function, for example, written in Python, and test and verify to make sure that it works the way we would expect it to. And to do so, we can start with a command in Python known as assert. And what assert does in Python is it asserts or just states that something should be true. And if that something is not true, then the assert is going to throw an exception, some sort of error, so that whoever is running the program or running the command knows that something went wrong. And this can be a very basic way that we can leverage Python's abilities to test a function and verify that that function behaves the way we would want it to. So let's go ahead and try a simple example of writing a Python function and then trying to test to make sure that that function works the way we would want it to. So I'll go ahead and create a new file. I'll call it assert.py. And let me define a new Python function, for example, that is going to take an integer and square it. I just want to take a number and return it square. So I'm going to define a function called square that takes as input a number, like x, and I want to return x times x. It's a fairly straightforward function, but I would like to now verify that the function works the way I would expect it to. Now, there are a number of ways that you could do this. One would be just like, let's print out what the square of 10 is, for example, and just see what that's equal to. And then you could run a program, something like python assert.py, and just say, all right, the answer is 100. And I could say to myself, OK, that's what I would expect it to be. But I now have to do the mental math of squaring the number 10, making sure that the answer comes out to be the value that I expect. It would be nice if I could automate this process. Well, one thing I could do is print out, does the square of 10 equal 100? I know that I want square of 10 to equal 100, so I could just print out that value. Print out, does square of 10 equal the number 100? I'll go ahead and run the program again. And this time what I get is true, for example, because those two things are equal to each other. And if, on the other hand, I had tried to check for something that wasn't true, like does square of 10 equal 101, you run the program, and OK, now it's going to be false. So this is nothing new, nothing we haven't seen before. But now what I can do is, instead of this, I can just say, let me assert that square of 10 is equal to 100. Here I'm just asserting that this expression, that the square of 10 is equal to 100, is going to be true. And now I can run the program. And what you'll notice is nothing happens. No output, nothing at all. Because when an assert statement runs, and the expression that it's checking turns out to be true, that the square of 10 does equal 100, it effectively ignores that statement altogether, just continues on to the next thing, no output, no side effect of any sort. And this is helpful because it just means that if I want to assert that something is true, I can assert it and then just continue writing my code. And it's as if I hadn't written that assert statement at all, so long as the thing that I'm asserting is actually true. But if there were a bug in my code, for example, some sort of mistake, where instead of returning x times x, imagine that I accidentally said return x plus x to calculate the square instead, something that would be a bug in this case, well, then when I try to run python assert.py, what I'm going to get is an exception. And the type of exception that I get is something known as an assertion error. And I can see that here. There's an assertion error. And then I see the reason why the assertion error happened. And the assertion error happened on line 4, which is this line here, where I said I would like to assert that the square of 10 is equal to 100. So one way we could imagine testing our code is just by including a number of these different assert statements. If I want to verify that my code is correct, I can write various different assert statements. And for a function that's fairly simple, like this square function, probably not too many tests that I would need to write. But you can imagine for more complex functions that have multiple different conditional branches, being able to assert that no matter which conditional branch the program chooses to follow, that the code will actually be correct can be a valuable thing to be able to say. And this can be helpful too when, in working on a larger project, you want to deal with the problem of like bugs that might appear inside of a project. And this gets at the idea of test-driven development, developing while keeping this notion of testing in mind. And one of the best practices would be if ever you're working on a program of your own and you encounter some bug in the program, you'll first want to fix the bug, but then you'll want to write a test that verifies that the new behavior is working as expected. And once you've written these tests can start to grow over time. And as you continue working on your project, you can always run those existing set of tests to make sure that no new changes that you make to the program down the line, no future features that you add or changes you might make are going to break anything that was there before. And this is especially valuable as programs start to get more complex, and testing everything by hand would start to become a very tedious process. To be able to just automate the process of just run a whole bunch of tests on all of the things that I know that I would like the program to do, and making sure they work as expected, that can be quite helpful. So assert then is one basic way of just saying that I would like for this statement to be true, and if it's not true, go ahead and throw an exception. And using Python, we know we also have the ability to catch those exceptions in order to make sure that we're able to handle those appropriately, so we could display a nice error message, for example, if we wanted to do so. But now let's go ahead and try and write a more complex function, something more complex than just taking a number and squaring it, somewhere where there's more room for various different cases that I might want to test, and more room where I, the programmer, might make a mistake, for example. So let's imagine writing a new file that I'm going to call prime.py, where here I'll go ahead and say that I would like prime.py to implement a function called isPrime. And what the isPrime function should do is check to see if a number is prime or not. A prime number only has factors of 1 and itself, and I would like it to write a function that verifies that fact. And so how might I go about doing that? Well, if n is less than 2, then it is definitely not prime, because we say 0 and 1 are not going to be prime, and we'll only deal with numbers that are 0 or greater, and we'll deal with that for now. But let's start then with other numbers, numbers that are 2 or greater. Well, what do I want to do? I really want to check each of the possible factors. Like if I want to check whether or not 100 is prime or not, then I want to loop over all of the possible numbers that could be factors of 100, like 2, 3, 4, 5, 6. And when I get to a number like 2 or a number like 5 that do go into 100 cleanly, well, then I'll know that the number is not prime. So I could say for I in range from 2 all the way up through n, for example, let me go ahead and say if n mod I equals 0, then return false. So what am I saying here? I'm saying go ahead and start at 2, go up through but not including n. So if I'm checking to see if 10 is prime, for example, I'm going to check for I is 2, 3, 4, 5, 6, 7, 8, 9. And for each of those numbers, check if n, my input to this function, mod I, the factor that I would like to check, is equal to 0. This mod operator, this percent, if you don't recall, gives us the remainder when you divide one number by another. And so if n mod I equals 0, that means the remainder when you divide n by I equals 0, meaning I goes into n cleanly with no remainder. And that means that it's not prime, because it does have a factor. Whatever I is going to be that factor. And if I get to the end of this for loop, then I can go ahead and just say return true. If we weren't able to find a factor for the number other than 1 and the number itself, well, then we can go ahead and say that true, this number is going to be prime. And so this, for example, could be a function that checks to see if a number is prime. But if I'm trying to optimize, I'm trying to make my function more efficient, I might realize that you really don't need to check every number from 2 all the way up to the number n itself. I could really just check up to like the square root of that number, for example. That for a number like 25, I want to check like 2, 3, 4, 5, because 5 squared is going to be 25. But after 5, I don't need to check any more numbers beyond that. That after you get to a number, the square root of that number is multiplied by itself, there's never going to be a case where a number bigger than that could be a factor that I won't have already known about. So just thinking about things a little bit mathematically, we might be able to make some sort of optimizations where instead of going from 2 all the way up through n, I might go up to the square root of n. And I'll go ahead and import math to be able to use math.squareroot. And I'll convert that number to an integer just in case the square root doesn't already happen to be an integer. So I think this works. I've at least talked myself into thinking that this is a function that might be able to check if a number is prime. So what could I do if I wanted to verify this? Well, I could write some assert statements. Another thing I could do is just use the Python interpreter. I could say, all right, let me go ahead and type Python. And now I'm in the Python interpreter. And I can say from prime, go ahead and import isPrime. Prime is the name of that file. IsPrime is the function in that file that I would like to test. And let's just try, all right, like isPrime of 5. That's a prime number. Hopefully it'll say true that it's prime. All right, it does. Let's try isPrime 10, see if that works. All right, isPrime 10 is false, because 10 is not prime. That's good. That seems to be working as well. Let's try like isPrime 99. That's not prime, because like 3 is a multiple of that, for example. All right, false, so that's good. This seems to be working. And I could, in the interpreter, test this function to make sure that it works the way that I would want it to work. But let's now see some other ways that I might go about testing it. Well, one way is that I could write a file like test0.py. And what test0.py is going to do, instead of using assert, I'm just going to do our Boolean checks like we were doing before. I'm going to import the isPrime function. And I've defined a new function called testPrime, which is going to serve the role of testing to make sure that when you square some number, or when you check to see if some number n is prime, that you get some expected value, where that expected value is either true for it is prime or false for it's not prime. What then is this function doing? Well, the function is checking. We're calling the isPrime function on this number n and seeing whether or not it is equal to the expected value that we get, where we expect it to be either true or false. And if we run isPrime on n, and it is not equal to what we expect, well then we print out, OK, there's an error. We expected some value true or false, but it turned out not to be the case. And so now that I have this testPrime function, well, I can say, all right, let me go back into the Python interpreter. From test0, import testPrime. And now I can say, all right, let me testPrime, make sure that 5 is prime. So I'm passing in as my first input the number n, the number I would like to check. I want to check if 5 is prime. And the second input I provide is what I expect it to be, either true or false. And here, nothing happens, which is a good thing. If there were an error, it would have printed something out. And the fact that I see nothing printed out means that everything was OK. If I test prime now and say something like, all right, make sure 10 is not prime, make sure that 10, when you pass it into isPrime, is going to give us false. Again, nothing happens. Seems to be working just fine. Let me now try, I can try more examples. Maybe I try testPrime 25. I want to make sure that 25 is not prime, because 25 is not a prime number. All right, we get some sort of error. There's an error on isPrime 25, where I expected the output to be false, but for some reason, it looks like isPrime returns something other than false. It probably returned true. And so it might indicate some sort of bug in my program, that somehow I don't think that 25 should be a prime number, but my program thinks that 25 is a prime number. And that error can be a clue to me as to how to do this. But ultimately, especially as programs start to grow longer, especially as I start to add more and more functions, testing each of those functions by hand is going to start to get tedious. So one thing I could do is like write a script to be able to run all these tests for me automatically. And so here, what I have is test0.sh being like a shell script, some script that I can just run inside my terminal. And what this is doing is it's running Python 3 for Python version 3 -c, which means I'm just going to give it a command, and it is going to run that command. And so I can just run these, and each of these lines does what? From test0, it imports my testPrime function, that function that is going to test to make sure that the prime function produces the output that I would expect it to. And each time I'm testing a different number, making sure that 1 is not prime, making sure that 2 is prime, 8 is not prime, so on and so forth. And I can just write a whole bunch of these tests. And then rather than have to run each test one at a time, what I can do is I can just run test0.sh. I can just say that I would like to run /test0.sh. And all right, I see that I get 2 errors. I get an error on isPrime 8, where I expected it to not be prime, but for some reason it seems to be prime. And then again here, exception on isPrime 25, where I expected it to not be prime, but for some reason my program thinks that it is prime. So a very helpful way for me to know immediately that there's some sort of error that is going on here. But ultimately, rather than have me have to write all this framework for how to go about testing my code on my own, there exist libraries that can help us with this. And one of the most popular in Python is a library known as unit test. And what unit test is a library designed to do is it is going to allow us to very quickly write tests that are able to check whether something is equal to something else. And then unit test is built in with an automated test runner that will run all of the tests for me and verify the output. And unit test gets built in to a lot of other libraries within Python. We'll see how we'll soon be able to apply this sort of idea to our Django applications as well. But let's now translate these tests that we have written ourselves just by writing a function that like tests whether the prime number is what we expect it to be, and now translate it to using this Python unit test library instead. And so just to get a sense for what this looks like, I'll now go ahead and open up tests1.py, where here, first thing I'm doing is I'm importing unit test, which we get for free with Python. I'm also importing the function that I would like to test. And now I'm defining a class which will contain all of my tests. This is a class that inherits from or derives from unit_test.testCase, which means that this is going to be a class that is going to define a whole bunch of functions, each of which is something that I would like to test. And so, for example, in this very first test, this is a test that checks to make sure that 1 is not prime. And so the way I do that is by calling self, this testing object itself. It happens to have a method or function built into it called assert false. There's an equivalent assert true. But I would like to assert false. And what would I like to assert that is false? Is prime 1. So whatever is prime 1 is, that should be false. And I would like to just assert that it is false. Likewise, for the number 2 now, I want to check that the number 2 is prime. And the way I do that is by calling self.assertTrue. I would like to assert that when I run the isPrime function on the number 2, the output that I get is going to be a true value, self.assertTrue. And I can translate each of the rest of my tests into one of these self.assertTrues or self.assertFalse. And then I say that if you go ahead and run the program, go ahead and call unittest.main, which will run all of these unit tests. So now, when I run Python test1.py, here's what I get. I get some nice output, where up at the top I see dots every time a test succeeded, and a letter F for a test that happened to fail. It says that it ran 6 tests, and down at the bottom I see that there were 2 failures. So it's immediately going to tell me exactly what failed, and it'll give me some rationale, some reason for why it is that those tests failed as well. So we can see, all right, here is one test, here's another test. This test that failed is the test that checked that 25 is not prime. And this sentence here is what I supplied inside of what was known as that Python docstring, inside of those triple quotation marks underneath the declaration of the function. Those triple quotation marks, otherwise known as a docstring, serve a number of purposes. They can serve as just a comment for describing what it is the function does, but they're a special comment insofar as someone who's looking at the function can access that docstring that's usually used for documentation for what it is that the function is doing, and they can use it inside of other places as well. And so what unit test is doing is for every function, it uses that docstring as a description of what the test is testing for. So that if a test fails, then I can see exactly what the name is of the test that failed and what it was testing, where the description describes what was happening. Now, in this case, where it's just one function, I'm testing a whole bunch of different numbers, it doesn't seem all that useful. But again, as you imagine projects that start to get more complex, being able to know immediately when you run your tests which parts of the program or which parts of your web application aren't working the way they are expected to can actually be quite helpful. So test25, that was the function that triggered an assertion failure in this case. And the line that caused it was self.assertFalse is prime 25. And the reason that it failed is because true, which apparently was the output of this function, is not false. And I expected it to be false instead. And so multiple different ways of trying to run our tests. This happens to be one quite popular one. But this now tells me that I should go back and try and fix my isPrime function. I can go back into prime.py and say, all right, I would like to figure out why this went wrong. And if you look at this enough and maybe give it a little bit of testing, you might see that I have a slight off by 1 error, that I probably need to check 1 additional number than I actually am. Because in checking whether or not 25 is prime or not, for example, I might need to go up to and including the number 5 to know that 5 is a factor of 25. But before, I was going up to the number 5, but I wasn't including the number 5. So I also need to just check 1 more number. And now to verify that this is right, I could just manually test the function myself, or I could just run these tests again. Run Python test1.py. And this time, All these dots mean all these tests succeeded. We ran 6 tests, and everything was OK. No failures. And so this can be a helpful way for me to know immediately that things seems to be working OK. So the takeaways from here are that these tests can definitely help as you begin to write new changes to your program, especially as you begin to optimize functions. You might make a function more efficient, but then run your tests to make sure that in making these improvements, you haven't broken anything. You haven't changed any behavior that the way the program was supposed to behave, and now it doesn't behave that way. You are able to verify with much more confidence that that is true. But of course, that only works if your tests have good coverage of all the things that you would want the function to do. And you've covered appropriately all the various different cases for how the function should behave, because only if the tests are comprehensive will they actually be useful to you in indicating that the change that you made isn't going to break anything. And only then can you actually feel confident in those changes themselves. So now let's take this idea of using unit tests to be able to write these tests that verify that a function works and apply it to something like a web application written in Django that we would like to now use in order to be able to test to make sure that various different functions inside of our Django web application work as well. So what I'm going to do is actually take a look at the airline program that we wrote back when we were first talking about Django and first talking about storing data inside of databases. And I'm going to open up models.py, where you see that I've made one addition to our definition of a flight. And recall from before, when we first introduced this idea of defining a model inside of our application for a flight inside of an airline, we gave that model 3 properties. It had an origin and a destination, where both origin and destination referenced an airport object, where an airport object was an object we defined separately. But a flight has an origin airport and a destination airport. And in addition to that, every flight has a duration, some number of minutes long, that that flight is going to last. And I might like to have some way to validate, to verify that a flight is a valid flight, that there isn't some error somewhere in how the data was entered into the database. I would like to just generally make sure that given a flight, I can check to make sure it's a valid flight. And what does it mean for a flight to be valid? Well, in general, given these particular fields, I'll say there are 2 things that need to be true for a flight to be valid. The origin and the destination need to be different. That's condition number 1. It wouldn't make sense to have a flight whose origin and destination are the same airport. And condition number 2, the duration of the flight needs to be greater than 0 minutes. If ever the duration is 0 or the duration is negative, that probably indicates to me that there was some sort of mistake in data entry or some problem that happened with how it is that these flights were configured. So I want to make sure that the duration is greater than 0. And those then are my 2 conditions for what makes a valid flight. And I've in fact written a function here called isValidFlight that just works on this flight class, that simply checks, given a flight, make sure that it is in fact valid. And the way it's doing that is by checking for these 2 conditions that I've just described. It's checking to make sure that the origin is not equal to the destination. It's checking to make sure that the duration of the flight is greater than or equal to 0. And maybe I should change that to greater than to make sure it's entirely positive. But this then is my definition for what it means for something to be a valid flight. And what I'd like to do now is test these various different parts of my application. I have this isValidFlight function inside of flight that I might like to test as well. But we also have all of these other properties that I would like to test, these relationships, that a flight has an origin and a destination. We have passengers that can be associated with flights. So there's lots of relationships between my data that I would like to test and verify to make sure they work the way we would expect it to. So to do that, whenever we create an application in Django, like this flights application here, we were also given this tests.py file. And we haven't yet used the tests.py file for anything. But what it's supposed to be used for is for writing these sorts of tests, testing that verifies that our application behaves the way that we want it to behave. So let's go ahead now and open up tests.py and see what happens to be in here. What we can do is we can define a subclass of test case, which behaves very similar to unit test and is based on that same idea. I'll define a new class called flight test case that will just define all of the tests that I would like to run on my flights application. And so things to know about this is that first, I might need to do some initial setup in order to make sure that there's some data that I can actually work with and test with. And what Django will do when I go ahead and run these unit tests is that it will create an entirely separate database for me just for testing purposes. That we have one database that contains all of the information that actually pertains to the flights that are actually there on my web server. but we might also like to just test things with some dummy flights and some dummy airports just to make sure that things are working. And then once we're confident things are working, then we can deploy our web application to let actual users begin to use whatever new features we've added to the web application, for example. So inside of this database, I might need to do some initial setup. And I can do so by defining a setup function inside of my test case class. This is a special function. And Django knows that when it's running these tests, it should first do any of the setup steps that we need to do. And so how are we doing this? Well, what we're doing is inside of the setup, we're going to just add some sample data into the test database. Again, this won't touch the database that users actually see and actually interact with. This is just our test one for testing purposes. And we'll start by going ahead and creating some airports. So airport.objects.create, and then specifying what the values for these fields should be. We'll just have an airport whose code is AAA for city A, and an airport whose code is BBB for city B. Just dummy airport names. They're not real airports, but just used for testing purposes. And I'll save those airport objects inside of these values A1 and A2. And beneath that, what I'm going to do next is go ahead and create some flights, where I create using flight.objects.create 3 different flights, one that goes from A1 to A2 with the duration of 100 minutes, one from A1 to A1 with the duration of 200 minutes, one from A1 to A2 with the duration of negative 100 minutes. So I have a whole bunch of these flights now that I would like to test, that I would like to make sure work in some predetermined or expected way. And so now if I scroll down, we can see that I have a whole bunch of these various different tests. Here is one test that just tests the departures count. So every airport has access to a field called departures, which ideally should be like how many flights are departing from that airport. And I'd like to make sure that departures count works the way I expect it to. So here, I go ahead and get the airport, whose code is AAA. And now, using unit test-like syntax, I would like to say self.assert equal. So assert true verifies that something is true. Assert false verifies that something is false. Assert equal verifies that 2 numbers are equal to each other. And here I'd like to verify that a.departures.count, if I take airport A and count how many flights are departing from that airport, that should be 3. So just verifying that that works. And then after that, if this test passes, then I can be confident that elsewhere in my program, if I take an airport and call that airport.departures.count, I can feel pretty confident that that is going to work the way I would expect it to. I can do the same thing for arrivals, get the airport, and assert that a.arrivals.count, that is going to be equal to the number 1 if there's only one flight that arrives at airport A1, for example. So that tests these relationships. And I can also now test the isValidFlight function as well. That here, I get my 2 airports, A1 and A2. This is the one whose code is AAA. This is the one whose code is BBB. I'll go ahead and get the flight whose origin is A1, whose destination is A2, whose duration is 100. And let me just assert true that this flight is going to be a valid flight, because this flight is valid. The origin is different from the destination. Its duration is some positive number of minutes. And so I should feel pretty confident that this is going to be a valid flight that I can verify by calling self.assertTrue. I can do the same thing for testing for an invalid flight. Testing for an invalid flight because the destination is bad. I can get the flight, airport A1, and get the flight whose origin and destination are both A1. And now let me self.assertFalse say that this should not be a valid flight, because the origin and the destination are the same. What's the other way a flight can be invalid? Well, a flight can be invalid because of its duration. So I could say something like, go ahead and get airports A1 and A2, and get me the flight whose origin is A1, destination is A2, but the duration is negative 100 minutes. That was one of the flights as well. And well, that should not be a valid flight. So I'll say self.assertFalse is valid flight, because when I call is valid flight on that flight, it shouldn't be valid because the duration makes it an invalid flight. So here now I've defined a whole bunch of tests, and there are more down below that we'll take a look at in a moment as well. But I've defined a whole bunch of these flights now, or a bunch of these tests, and now I'd like to run them. And the way that I can run tests in Django is via a manage.py command. Manage.py has a whole bunch of different commands that we can run. We've seen like make migrations and migrate and run server. But one of them as well is if I go into airline 0, I can say Python manage.py test that's just going to run all of my tests. And all right, it seems that we ran 10 tests, but 2 of them failed. So let's go ahead and see why did those two tests fail. Well, the way to read this is that we get this heading anytime a test failed. And so we failed the test invalid flight destination function, and we failed the test invalid flight duration function. And docstrings could have helped me to know what it is that these tests are exactly doing. But it seems that true is not false. I wanted to assert that this should not be a valid flight, that it should be false. But for some reason, these appear to be valid flight. So something seems wrong with isValidFlight, where it's returning true when it should be returning false. And so this then gives me a place to start looking. I can say, all right, let me go to isValidFlight and make sure that function is correct. So I'll go back into models.py. I'll take another look at isValidFlight. Maybe I'll think through the logic again. All right, I wanted to check that self.origin is not self.destination. I wanted to check that the duration is greater than or equal to 0. I could change this to greater than, but I don't think that's the issue, because my duration was negative, and so that already should have been invalid. But the other thing I might realize looking at this now is that, OK, the logical connective that I have used was not the right one. I want to check that for it to be a valid flight, it needs to satisfy both of the conditions. The origin and the destination need to be different, and the duration of the flight needs to be greater than 0, for example. And here I've used or instead of and, so I can just change it. All right, and hopefully that will fix things. And to verify as much, I can rerun python manage.pytest, go ahead and press return. It's going to check things, ran 10 tests, everything is OK, and all right. It seems that now I have passed all of these tests. And notice here at the top, it created a test database. So it just created a test database for me in order to do all of this testing work. And then it destroyed that test database at the end as well. So none of my tests, if I'm adding data, removing data, it's not going to touch any of the actual data inside of my database for the web application. Django will take care of the process of keeping all of that separate for me by first calling that setup function to make sure that my new test database has everything that it needs to. So all right, we now have the ability, by using unit test, to be able to test various different functions inside of our web application. We first saw that we could test a function like the isPrime function, just a Python function that we wrote. But we can also test things like functions on our models, like checking to make sure that a flight is valid, checking to make sure that we can take a flight and access all of the, or take an airport and access all of its arrivals and all of its departures. But I'd like to do more than that, especially for a web application. I'd like to check that particular web pages work the way that I want them to work. And so to do that, Django lets us simulate trying to make requests and get responses to a web application. And so let's go ahead and look at some of these other tests as well. Here what we have is a function called testIndex. And what testIndex is going to do is it's just going to test my default flights page to make sure that it works correctly. So we start by creating a client, some client that's going to be interacting request and response style. Then I'm going to call client.get/flights. That is the route that gets me the index page for all the flights. And I'm saving that inside of a variable called response. Whatever response I get back from trying to get that page, I would like to save inside of this variable called response. And now I can have multiple assert statements inside of the same test if I would like to. Sometimes you might want to separate them. But here, I want to check that the index page works. And what that means is a couple of things. It means that response.statuscode, well, that should be equal to 200. 200, again, meaning OK. I want to make sure that whatever response I get back, that is going to be a 200. And if there was some sort of error, like a 404 because the page wasn't found, or a 500 because of some internal server error, I would like to know about that. So let me first just assert that the status code should be equal to 200. But then Django also lets me access the context for a response. And what is the context? Well, recall again in Django when we rendered a template, for example. We called return render, then provided the request and what page we were going to render. But we could also provide some context, some Python dictionary describing all of the values that we wanted to pass in to that template. And Django's testing framework gives us access to that context so that we can test to make sure that it contains what we would expect it to contain. And on the index page for all my flights, I would expect that to contain a listing of all of the flights. And we created 3 sample flights inside of this test database. So I should be able to assert that these two things are equal. Response.context flights, that gets me whatever was passed in as flights in the context. .count, well, that better be 3, because I want to make sure that there are exactly 3 results that come back when I look at the context and access whatever happens to be inside of that flight's key. There are other tests I can run as well. So in this case, I've gone ahead and gotten a particular flight, the flight who in this case had an origin of A1 and a destination of A1. Now that was not a valid flight, but we'll go ahead and get it anyway because it exists in the database. And now I can get /flights / that flight's ID, right? Because on my flights page, I would like to be able to go to /flights /1 to get at flight number 1, and go to /flights /2 to get at flight number 2. So if I take some valid ID, some ID of an actual flight F, and go to /flights / that ID, well, that should work. It should have a status code of 200. Meanwhile, though, if I test an invalid flight page, this is a Django command that will get me the maximum value for the ID. This ID __ max gets me the biggest possible ID out of all of the flights that happen to exist inside of my database. If I go ahead and try and get /flights / max ID +1, so a number that is 1 greater than any of the flights that were already inside of my database, well, that shouldn't work. There shouldn't be a page for a flight that doesn't exist. So here then, I can assert equal that the status code of what comes back, that is equal to 404, because I would expect that page to return a 404. And finally, I can also check various different contexts for things about the passenger page. So in this case, I've added some sample passengers to the database. So inside of my tests, I can manipulate the database as well, adding data into the database and checking to make sure that when you count up the number of passengers on a flight page, that is going to be like the number 1, for example. So a number of different tests that we can then write in order to verify various different parts of our web application. I would like to verify not only that our database works the way we would expect the database to work in terms of how functions on our models work, in terms of relationships between those models, like the relationship between a flight and an airport, but we can also simulate a GET request, simulating a request to a page, and verify that the status code that comes back is what we would expect it to be, verify that the contents of the page contain the right contents, verify that the context that was passed into that template is correct as well. And then all of that can then be verified by saying something like python manage.pytest, then go ahead and running that. And we see that in this case, all of the tests happen to pass, which means that everything seems to be OK, at least for now. So this then, again, very helpful as our web programs start to get more complex, as we have multiple different models, multiple different routes, the ability to test to make sure that if we change things in one part of the program, that it doesn't break things in another part, that can be quite helpful too. What we haven't yet been able to test, though, is any interaction that's happening exclusively in the browser. That I've been able to test a lot of things that are happening server side. And recall that Django is all about working on writing this web server, a Python application that acts as a web server that listens for requests that come in from users, processes those using these various different views and models, and then provides some sort of response back. And we can test the contents of that response. Things like, does the status code match what we would expect it to? Does the context match what we would expect it to? But there's some times where we would like to really simulate, like a user, clicking on buttons and trying things on a page and making sure that page behaves how we would like it to as well, even if we're not using Django or even if we're just dealing with the front end. So let's create like a sample JavaScript web page that we might like to test now by using these sorts of ideas, the ability to automate the process of testing various different parts of our application to verify that they do in fact work correctly. What I'm going to do now is we'll get out of the airline directory, and I'm going to create a new file that I'll call counter.html. And recall before we created a counter application using just JavaScript, where what the counter application did is it let me click a button, like an increase or a count button, that just incremented a number. It went from 0 to 1 to 2 to 3 to 4 and so forth. I'm going to do the same thing here. We'll add a little more complexity, though, and give myself both an increase button to add a number and a decrease button to decrease the number by 1 as well. So I'll go ahead and start with our usual doc type HTML and our HTML tag. I'll give this page a title of counter. And now, inside of the body of this page, I will go ahead and start with a big heading that just says 0. And then beneath that, I'll create 2 buttons. I'll have one button, which will be the plus symbol, and one button, which will be the minus symbol. So now, no JavaScript yet. This won't actually work. But I can go ahead and go into open counter.html. And I can see that I now have 0 and I have a plus and a minus button, although those plus and minus buttons don't actually do anything right now. So let's go ahead and make them do something. Let's give this button an ID called increase so that I can reference it later, and give this button an ID called decrease, again, so that I can reference it inside of my JavaScript. And now in the head section of my web page, I'll add a script tag where I want to start running some JavaScript once the page is done loading. And to do that, you'll recall I can say document.add_event_listener, DOM content loaded, to say go ahead and run this function once the DOM is loaded, once all the contents of this page have loaded the way I would expect it to. And what am I going to do? Well, I first need a variable, something like let counter equals 0. And then I can say, all right, document.querySelector increase. Get me the element whose ID is increase. That's that plus button. And when you are clicked, let's go ahead and add an event handler in the form of this callback function, this function that will be called when the increase button is clicked. And what would I like to do? Well, I'd like to increase the counter. Go ahead and say counter plus plus. And then I'm going to update this h1 that currently contains 0. Document.querySelector h1. That gets me the h1 element. I'll go ahead and update its inner HTML and go ahead and set that to whatever the value of counter happens to be. And then I'll do the same thing for the decrease button. Document.querySelector. Get me the element whose ID is decrease. That's the button that will be the minus button. And when you are clicked, go ahead and run this callback function, which will do the same thing, except we'll first do counter minus minus. Decrease the value of the counter by 1, and then get me the h1 element, set its inner HTML equal to the counter. I think this should work, and I could verify that by opening up counter.html. I'll refresh the page, and I can test these buttons. Test the plus button. All right, that seems to work. Increases the value by 1. I can test the minus button. Make sure that that decreases the value by 1. That all seems to work just fine. But of course, this requires me having to interact with this page. I have to open up the page. I have to click on these buttons. And it's not the type of thing where I'm simulating like a GET request or a POST request. There's no server that I'm sending a request to and getting back a response of 1, 2, 3, 4 from. This is all happening in the browser. And so what I might like to have the ability to do is some sort of browser testing. And there are a number of different frameworks for doing this. One of the most popular is Selenium. And what this is going to allow me to do is I can define a test file that, using unit test or a similar library, can effectively simulate a web browser, can simulate a web browser and simulate a user interacting with that web browser using something that we call a web driver. That's going to allow me to, using code, control what it is that the browser is doing and how it is that the user is interacting with this program. So how is this going to work? Well, I'm going to go ahead and, just as a test, let me open up the Python interpreter and let me import from tests import star. And that's going to give me access to a couple of different things. But the first thing you'll notice that it's doing is, because I'm using this web driver, it's going to give me a web browser. And here I'm using Chrome, but you could use another browser. But notice that here Chrome is telling me Chrome is being controlled by automated test software. That Chrome has the ability to allow me, using automated test software, using like Python code, control what it is the web browser is doing. And so what I can do here is, the first thing I need to do is like tell Chrome to open up my web page. And it turns out that in order to do so, I need to get that page's URI, or Uniform Resource Identifier, just some string that will identify that page. And I've defined a function called file URI that gets me the URI of a particular file in this directory. So I'm going to say I want to open up counter.html, and I need to get its URI. But now what I can say is driver.get URI. Meaning, like, tell this web driver, this Python part of the Python program that is controlling the web browser, that I would like to get this web page, as if the user had gone to the web page and like pressed return after typing in the URL. So I say driver.getURI. I go ahead and press that. And what you'll notice on the right-hand side here is that Chrome has loaded this page. I am effectively controlling this web browser window using my Python program. I said driver.getURI, meaning go ahead and open up the counter.html page, and then inside of this test window, Chrome has opened that up. And inside my Python program now, using this WebDriver, I have the ability to see the same things that the user sees when they open the page. So what does the user see when they open the page? Well, they see, for example, the title of the page. So I could say driver.title and see that, all right, the title of this page is counter. That was, in fact, the title of the page, but I could verify that inside my Python program by checking that driver.title, by taking my WebDriver, getting the title of the current page that it's looking at, making sure that that is counter. And likewise, if I looked at driver.pageSource, press return, what I see there in string format, so it's a little bit messy, is the contents, the HTML content of this page. And you'll notice things like, DOM content loaded, here are my on-click handlers, here's my h1 that says 0. It's very messy because it's being represented as a Python string, and these \n's refer to new lines where there's a line break. But this is the content, and this is really all the browser gets. The browser takes this information and just knows how to render it in some nice, more graphical representation that's easier for a user to look at and therefore be able to understand. But this is fundamentally all that my web browser is actually getting back when it tries to load a web page. So what can I do from here? Well, I would like to simulate a user's behavior on this page. That sure, I can get a page and see the title, but I want to simulate clicking on the plus button, for example. So in order to do that, first thing I need to do is actually get the plus button. And to do that, I could say something like driver dot get or find element by ID. There are a number of ways that I could try and find an HTML element, but I would like to find an HTML element by its ID. And I know that the plus button, the increase button, has an ID of increase, for example. And so if I find element by ID, let me find the element whose ID is increase. And all right, it seems here that I've gotten some web element object back from my WebDriver. And I'll go ahead and save that inside of a variable called increase. So what I now have is a variable called increase that represents the increase button that my WebDriver has found on the web page. It's effectively the same thing as you, the human, going through the page looking for the increase button. The WebDriver is doing the same thing, except instead of looking for the button based on what it looks like, it looks for the button based on its ID. And so this, again, another reason why it's helpful to give your HTML elements IDs. In case you ever need to be able to find that element, it's very useful to be able to reference that element by its name. But now that I have a button, I can simulate user interaction with that button. I can say something like increase.click to say I would like to take the increase button and simulate a user clicking on that button in order to see whatever it is that the user would get back when they click on that button. So increase.click, I press return. And what you'll notice happens is that the number increases from 0 to 1. It's as if I, the user, had actually clicked on the plus button, except all I did was say increase.click to say go ahead and press the increase button and let the browser do what it would normally do in response. And what it would do in response is get that JavaScript event handler, that onClick handler, and run that callback function that increases the value of counter and updates the h1. So I can say increase.click to simulate increasing the value of that variable. But this is just a function call, which means I can include it in any other Python constructs that I want, that if I want to repeat something 25 times, for example, and press the button 25 times, I can say for I in range 25, go ahead and click the increase button. And now very quickly, 25 times, it's going to click the increase button, and I'm going to see the result of all of that interaction. So I can simulate user interaction just by using the Python interpreter. Likewise, if instead of increasing, I want it to decrease, well, then I'm going to do the same thing. I'm going to say decrease equals driver.find element by ID. Let me get the decrease element, the element whose ID is decrease, and now say decrease.click. And that will simulate me pressing the decrease button, press it again, and the more I press it, every time it's just going to decrease by 1. And if I want to decrease it all the way back to 0, well, then I'll just do it 20 times. For I in range 20, go ahead and decrease.click. And that's going to go ahead and reduce the count all the way back to 0 by simulating the user pressing a button 20 times. And what you'll notice is that it happened remarkably fast. I can simulate 100 presses of the increase button by saying for I in range 100, increase.click. And very quickly, you'll see that number 100 times go ahead and go up to 100 faster than a human could ever have clicked that plus button over and over again. And so these tests can not only be automated, but they can be much faster than any human could ever be in order to test this behavior. So how then can we incorporate this idea into actual tests that we write, into like a unit testing framework that allows me to define all of these various different functions that test different parts of my web application's behavior? Well, to do that, let's go ahead and take another look at tests.py. Inside of test.py, here again is that file URI function, where that function has the sole purpose of like taking a file and getting its URI, and we need the URI to be able to open it up. Then we go ahead and get the Chrome WebDriver, which is going to be what's going to allow us to run and simulate interaction with Chrome. And in order to get Chrome's WebDriver, you do have to get Chrome Driver separately. It is separate from Google Chrome itself, but Google does make it available. And other web browsers make equivalent WebDrivers available as well if you'd like to test how things would work in other browsers, because different browsers might behave differently. And it might be useful to be able to test to make sure that not only does everything work in Google Chrome, but it's also going to work in other browsers that you might expect users to be working with as well. Here then I've defined a class that again inherits from unit_test.testCase that is going to define all of the tests that I would like to run on this web page. That here I have a function called testTitle that's going to go ahead and first get counter.html. It's going to open up that page. And then just assert equal. Let's make sure the title of the page is actually counter. That's what I would expect it to be, so I can write a test in order to test for that case as well. Here I test the increase button by finding the element whose ID is increase and clicking on that button to simulate a user pressing the plus button in order to increase the value of the counter. And then, what do I want to check? Well, I want to check that when you find element by tag name, h1, and so find element by tag name, similar to find element by ID, except instead of finding something by its ID, it's going to look at what's the tag. And there only is one element that is an h1. And so here I'm saying, go ahead and get me the h1 element and access its text property, meaning whatever it is that is contained inside of those two h1 tags, I would expect that to be the number 1. And so I would assert that this is equal to 1. And likewise, I can do the same thing for the decrease button, finding the element whose ID is decrease, clicking on that button, and then asserting equal, find me the h1 element, and make sure that the contents of it are equal to the number -1, for instance. And this final test just tests things multiple times. That 3 times I'm going to press the increase button and make sure that after I press the increase button 3 times, when I check the h1, check what's inside of its text, that the answer should in fact be 3. So now I should be able to go ahead and test this code by running python tests.py. And what that is going to do is it's going to open up a web browser. And what you're going to see very quickly flashed across my screen were all of those tests. We test the increase by 1, we test decrease by 1, and then we test like increase 3 times after we had checked to make sure the title was correct. And then we can see here is the output. We ran 4 tests in this amount of time, and everything turned out to be OK. None of the tests failed. But if one of the tests had failed, well then we would see a different output. So let's imagine, for example, that I had a bug in my decrease function, for example, where the decrease function wasn't actually working. What would that bug look like? Maybe I forgot to say counter minus minus. Or maybe, perhaps more likely, what might have happened is I already had written the increase function, and I decided to very quickly add the decrease function, and I thought I'd just, copy paste. Like copy the increase event handler. The decrease event handler is basically the same thing, except I need to query for decrease instead. And maybe I just did that and forgot to change plus plus to minus minus, a bug that might happen if you're not too careful about how you copy and paste code from one place to another. Now when I run these tests, python test.py, we'll see the simulation. A whole bunch gets simulated. And when I go back and check the output of my test, see what actually happened, I see that we do seem to have an assertion error here. The assertion fail was on the test decrease function. And it happened when I tried to assert that what was inside of the h1 element was -1, because 1 is not equal to -1. So this is the value of this assertion error as well. And this is helpful. An advantage over just assert. Assert just tells you, there's an assertion error. But here, in unit tests, we actually get to see. If I asserted that 2 things are equal, it tells me what both of those things are. It tells me the actual output of h1's text it was 1, but what I expected it to be was -1. So it tells me exactly what the discrepancy is. I know that for some reason it was 1 instead of -1, and that can be a clue to me, a hint to me, as to how I can go about trying to solve this problem. And I can solve the problem by going into my decrease event handler, seeing that, all right, this was increasing the counter instead of decreasing it, change ++ to -, and now rerun my tests and see all of the tests simulated inside of my Chrome driver. And we ran 4 tests, and this time everything was OK. So all of my tests appear to have passed this time. So those then are some possibilities for being able to test our code, especially taking advantage of unit tests, this library that we can use in Python in order to make various types of assertions about what we would like to be true or false about our code. And unit test contains a number of helpful methods for being able to perform these sorts of assertions. Some of them are here. So we can say things like, I would like to assert that 2 things are equal to each other, which we've seen. There's a counterpart to that, assert not equal, for making sure that 2 things are not equal to one another. Assert true and false we've seen as well. There are others as well, though. Things like assert in or assert not in. If I would like to assert, for example, that some element is in some list, for example, or that some element is not in some list, there are other assert methods as well that we can use in order to verify that a part of our program or a part of our web application does in fact behave the way we would want to behave. And we can integrate this type of idea into a number of different types of testing. We saw integrating it into Django itself, using Django's unit testing in order to verify that our database works the way we expected it to, and that our views worked the way that we expected them to, and provided the right context back to the user after the user makes a request to our web application. And there are also applications of unit testing, whether using the framework or not, to browser-based testing. When I want to test, like inside of the user's web browser, does it actually work when a user clicks on this button that the JavaScript behaves the way that I would expect it to? And I don't need to especially use JavaScript in order to do those tests. I can write those tests using Python, using unit test, to be able to say, click on the button that has this ID, and verify that the result that we get back is what we would expect it to be. So that then was testing. And now we'll go ahead and take a look at CI/CD, continuous integration and continuous delivery, which refer to 2 best practices in the software development world that have to do with how it is that code is written, especially by groups or teams of people, how it all works together, and how that code is eventually delivered and deployed to users who are using those applications. So CI, which refers to continuous integration, involves frequent merges to a main branch of some repository, like a Git repository, and then automatically running unit tests when that code is pushed. So what does that generally mean? Well, in the past, you might imagine that if multiple people are working on some project at the same time, and multiple people are each working on different features or different parts of that project, then after everyone's done working on those features and we're ready to ship some new version of a web application or ship some new version of a software product, well, then everyone's going to have to take all these various different features and combine them all together at the end and figure out how to then try and deliver that program to users. And this has a tendency to cause problems, especially if people have been working on different big changes all simultaneously. They might not all be compatible with one another. There might be conflicts between the various different changes that have been made. So waiting until everyone's done working on a feature to merge them all back together and then deliver it is not necessarily the best practice, which is why increasingly many more teams are beginning to adopt a system of continuous integration. That there's one repository somewhere online that's keeping the official version of the code. Everyone works on their own version of the code, maybe on their own branch, for example. But very frequently, all of these changes are merged back together into the same branch to make sure that these incremental changes can be happening such that it's less likely that there's 2 really divergent paths that the program has gone under. And as a result, it's much more difficult to merge those 2 paths back together. In addition to frequently merging to some main branch, another key idea of continuous integration is this idea of automated unit testing, where unit testing, again, refers to this idea of, on our program, we run a big series of tests that verify each little part of our program to make sure that the web application behaves the way it is supposed to. And unit tests generally refer to testing particular small components of our program, making sure that each component works as expected. There are also bigger scale tests, tests like integration tests, that make sure that the entire pathway from user request to response, that everything along a certain pipeline works as well. But there are various different types of testing testing. And the important thing is making sure that anytime some new change is merged into the main branch, or someone wants to merge their changes into the main branch, that these tests are run to make sure that nobody ever makes a change to one part of a program that breaks some other part of a program. And in a large enough code base, it's going to be impossible for any one person to know exactly what the effect of one particular change is going to be on every other part of the program. There are going to be unforeseen consequences that the one programmer may or may not know about. And so the advantage of unit testing, assuming they're comprehensive and cover all of these various different components of the program, is that any time someone makes a change and attempts to merge that change into the main branch according to the practice of continuous integration, the fact that it doesn't pass a test, we'll know about that immediately. And as a result, that programmer can go back and try to fix it, as opposed to waiting until everything is done, merging everything together, and then running the tests, realizing something doesn't work, and then being unsure of where to begin. We don't know where the bug is, which change happened to cause the bug. If everything is merged more incrementally, it's easier to spot those bugs, assuming there's good coverage of tests to make sure that we're accounting for these various different possibilities. So continuous integration refers to that idea. Frequently and more incrementally updating the main branch and making sure that the tests are in fact passing. And it's closely tied to a related idea of continuous delivery, which is about the process of how it is that the software is actually released to users, how the web application actually gets deployed. And there are a couple of models you might go about thinking with regards to how it is that some program or web application gets deployed. You might imagine that the release cycle might be quite long. The people spend months working on various different features on some software development team, and after they're happy with all the new changes, they release some new version of the web application. But especially with web applications that are undergoing constant change, that have lots of users, that are moving very quickly, one thing that's quite popular is this notion of continuous delivery, which refers to having shorter release schedules. Instead of immediately releasing something at the end of some long cycle, you can, in shorter cycles, make releases every day, every week or so, in order to say that let's just go ahead and incrementally make those changes. Whatever new changes happen to have merged to the main branch, let's go ahead and release those, as opposed to waiting much longer in order to perform those releases. And that, again, lends itself to certain benefits. The benefit of being able to just incrementally make changes, such as something goes wrong, you know more immediately what went wrong, as opposed to making a lot of changes at once, where if something goes wrong, it's not necessarily clear what went wrong. And it also allows new features to get out to users much more quickly. So especially in a competitive market where many different web applications are competing with one another, being able to take a new feature and release it very quickly can be quite helpful. So continuous delivery is all about that idea of short release cycles. Rather than wait a long time for a new version to be released, release versions incrementally as new features begin to come in. It's closely related to the idea of continuous deployment, which CD will sometimes also represent. Continuous deployment is similar in spirit to continuous delivery, but the deployments happen automatically. That rather than a human having to say, all right, we've made a couple of changes, let's go ahead and deploy those changes. In continuous deployment, anytime these changes are made, the pipeline of deploying the application to users will automatically take place as well, just removing one thing for humans to have to think about and allowing for these deployments to happen even more quickly as well. So the question then is, what tools can allow us to make continuous integration and continuous delivery a little bit easier? What techniques can we use in order to do so? And there are a number of different continuous integration tools. But one of them, produced by GitHub more recently, is known as GitHub Actions. And what GitHub Actions allows us to do is to create these workflows where we can say that anytime, for example, someone pushes to a Git repository, I would like for certain steps to take place. Certain steps that might be like checking to make sure that code is styled well. That if a company has some style guide that it expects all of its programmers to adhere to when working on a particular product, you could have a GitHub action such that anytime someone pushes to a repository, you have an action that automatically checks that code against the style guide to make sure that it is well styled, well commented, documented, and so forth. You might also, for instance, have a GitHub action that tests our code to make sure that anytime anyone pushes code to a GitHub repository, we automatically run whatever tests we would like to run on that particular code base. And GitHub Actions can allow us to do that as well by defining some workflow to be able to do so. And so that's what we'll take a look at in just a moment, using GitHub Actions to automate the process of running tests so that the human, though it would be a good thing for the programmer when they're done writing their code to test their code and make sure it works, we can enforce that by making sure that every time anyone pushes to a GitHub repository, we'll automatically run some GitHub action that is going to take care of the process of running tests on that program. And we'll know immediately, as via an email that GitHub might send to you, to say that this particular test failed, and you'll know every time you push to that repository. So how do these workflows get structured? What is the syntax of them? Well, they use a particular type of syntax known as YAML, which is some language, a configuration language that can be used in order to describe, often described for configuration of various different tools and software. GitHub Actions happens to use it. Other technologies use it as well. And YAML is a file format that structures its data sort of like this, in terms of key-value pairs, much in the same way that a JSON object or a Python dictionary might, where we'll have the name of a key followed by a colon, followed by its value. Name of a key followed by a colon followed by a value. And the value doesn't necessarily need to be just a single value. It could be a sequence of values, like a list of values, for example. And those are denoted this way, by like a hyphen indicating a list, item 1, item 2, item 3. And in addition to just having single values and lists of items, these ideas, these lists, these sequences, these values can be nested within one another. That you might have one key that leads to another set of keys that are associated with values, that leads to other sets of keys associated with values as well. Much in the same way that a JSON object, like a representation of keys and values, can also have nested JSON objects within a JSON object. Likewise, too, we can have nested key-value pairs as the value for a particular key, too. So we'll take a look at an example of what that actually looks like in the context of creating some GitHub workflow that will run some GitHub actions. So what will that look like? Let's go back into airline 0, where here I've defined inside of a .github directory, a directory called workflows, inside of which I have a ci.yml file. It can be any name .yaml, .yml, or .yaml are the conventional file extensions for a YAML file. And here, I'll open up ci.yml. And this now is the configuration for how this workflow ought to behave. I give the workflow a name. It's called testing, because what I want the workflow to do is like test my airline application. Then I specify an on key to mean when should this workflow run. And here I've said on push, meaning anytime someone pushes their code to GitHub, we would like to run this workflow. Every workflow consists of some jobs. And so what are the jobs? What tasks should happen anytime that I try and push to this repository? Well, I've defined a job called test project. And this is a name that I chose for myself. You can choose any name for a job that you would like. And now I need to specify two things for what happens on a job. One thing I need to specify is what sort of machine is it going to run on? That GitHub has its own virtual machines, otherwise known as VMs. And I would like to run this job on one of those virtual machines. And they're virtual machines for various different operating systems. Here I'm just saying, go ahead and run on the latest version of Ubuntu, which is a latest version of Linux that I would like for this test to run on. And then for the job, I specify what steps should happen, where I can now specify like what actions should happen when someone tries to test the project, when I try and run this job. And here I'm using a particular GitHub action. And this is a GitHub action written by GitHub called actions/checkout. And what this is going to do is it's going to check out my code in the Git repository and allow me to like run programs that operate on that code. And you can write your own GitHub actions if you would like. But here, all we really need to do is go ahead and check out the code as by looking at what's on the branch that I just pushed to. And then I'm going to run Django unit tests. This is just a description for me to know what's going on in this particular step. And here is what I would like to run. I'm going to first go ahead and install Django, because I'm going to need to install Django to be able to run all of these tests. But and if there are other requirements, I might need to install those requirements as well. But the airline program is fairly simple. All we really need in order to run the tests is just Django. So I'll go ahead and install Django. And then I'll run Python 3 manage.py test. I would like to run all of the tests. And the way I can do that is just by providing this manage.py command to say that I would like to run all of the tests on this particular application. So this configuration file altogether now is going to specify a particular workflow. the workflow that says that every time I push to the GitHub repository, what I would like to happen is I would like to check out my code inside of the Git repository. So on some Ubuntu VM, GitHub is going to check out my code, and it's going to run these commands. It's going to install Django, and then it's going to test my code. And it will then give back to me what the response is after I do that. So let's go ahead and test this. And in particular, let's run it on a program where the tests are going to fail. So I might say, for example, let's go into flights and models.py. And let's go to my isValidFlight function from before and change it back to that version that didn't work. That before it was something and something, I'll change it to something or something. That as long as the origin is not the destination, or the duration is greater than 0, we'll count that as valid. But we know that that's wrong. That should not work. So here's what I'll do. I'll go ahead and first say git status, see, all right, what's changed? And it seems that, all right, I've modified models.py, which makes sense. I'll go ahead and git add. I'll add dot. We'll just add all of the files that I might have modified. I'll commit my changes. So go ahead and use wrong valid flight function. That's what I'm going to do. And now I'm going to push my code to GitHub. I added it, I committed it, I pushed it. That now then pushes my code to GitHub into a repository called airline that I already have. And now if I go ahead and go to GitHub, and I go to my airline repository, what you'll notice is that we've mostly been dealing with this code tab, but GitHub gives us other tabs as well that are quite useful as you begin to think about working on a project in larger teams. So in addition to looking at the code, we have issues. Issues are ways for people to just report that something is not quite right, or there's a feature request that we have for this particular code base. So the issues might maintain a list of all of the pending action items for a particular repository, things that we still need to deal with. And once those issues are dealt with, the issues can be closed. So I have no issues here as well. Pull requests are people that are trying to merge some part of the code from one branch into another branch. So you might imagine on a larger project, you don't want everyone merging things into master all at the same time. You might have people working on their own separate branches, and then when they feel confident and happy with their code, then they can propose a pull request to merge their code into the master branch. And that allows for various other features, like the ability for someone to offer a code review, to be able to review the code, write comments, and propose suggestions for what changes should be made to a particular part of the code before it gets merged into the master branch. And that's another common practice with regards to working on a GitHub repository or any other larger project that you're controlling using source control, is this idea of code reviews, that oftentimes you don't want just one person making the changes without anyone's eyes on that code, but you'll want a second pair of eyes to be able to look things over, make sure the code is correct, make sure it's efficient, make sure it's in line with the practices that the application is using. And so pull requests can be quite helpful for that. And then this fourth tab over here represents GitHub Actions. These are the various different actions or workflows that I might want to run on this particular repository. And what we'll see here is that if I go to the Actions tab now, what I'll see is here's my most recent testing action. So anytime I push, I get a new testing action. This one was from 29 seconds ago. I'll go ahead and click on it and see what's within it. All right, here was the job that I ran, test project. I see that on the left-hand side. You'll notice this big red X on the left-hand side of this workflow means something went wrong. So I'd like to know what it is that went wrong. I'll go ahead and click on test project. And here within it, these are all of the steps, the things that happened when we actually ran this particular job. First, the job sets up. Then the checkout action goes ahead and checks out my code, because we need access to my code to be able to run it. Here was the step I defined, run Django unit tests, which was going to install Django and run those tests. It has an X next to it, indicating something went wrong. And I see down below annotations 1 failure. So all over the place, GitHub's trying to tell me that something went wrong. It failed 2 minutes ago here. I'll go ahead and open this up. And what I'll see is the first thing that happened is we installed Django. And that seems to have worked OK. But down below, what you'll see is the output of running these unit tests that we see failed, failures 2. And now I can see here are the unit tests that failed. We failed the invalid flight destination test. We failed the invalid flight duration test. And as before, I can see in GitHub's user interface what those assertion errors are. I can see true is not false, true is not false. Those were the problems that happened when I tried to run this particular test suite. And now others who are also working on this repository can see as well what the results of these tests are and can offer suggestions, can offer ways that I might be able to fix the code in order to deal with that problem. But now I know that this particular test failed. And if I go back to the main code page for this GitHub repository, I'll see that next to this commit, there's a little X symbol. And that little X symbol next to the commit just tells me that the most recent time I tried to commit, something went wrong. They ran the workflow and there was an error. And so I'll immediately see for this commit, and I can go back and look at the history of commits and see which ones were OK and which ones had a tendency to cause some sort of problem. So this one, it appears, caused a problem. And we know why. It caused a problem because of this condition, something or something else. So I can fix it. I'll change the or to an and. I'll go ahead and git add dot git commit, say I will fix valid flight check. If I do git status, just to check out what's going on right now, I'm ahead of the master branch by one commit. That's exactly what I would expect. And now I'll go ahead and push my code to GitHub by running git push, saying, all right, let's push this update. And now hopefully, we're going to pass the workflow now. Now I go back to the repository. I refresh the page. Here's my latest commit, fix valid flight check. You'll notice here there's an orange dot instead of the red X as before. This dot just means the tests are currently pending. The workflow is in progress because it takes some time for GitHub to be able to start up the VM, to be able to initialize the job, to check out my code, to run all those tests. So it does take some time. But if I go back to the Actions tab, I'll see that, all right, this time for testing, we get a green check mark. Everything seems to be OK. I go to test project just to see it. And now I notice the green check mark next to run Django unit tests means that the unit tests have passed as well. If I open those up, now I see at the bottom the same output that I saw before when I was running those unit tests on my own machine. We ran 10 tests, and everything was OK. And that tells me that these tests have passed. So GitHub Actions have the ability to allow for certain jobs to happen, certain work to happen, anytime you push code, anytime you submit a pull request, or on various different actions that might happen on a GitHub repository. And they're very helpful for being able to implement this idea of continuous integration, because it means you can make sure that when you're merging code from some developer's branch into the main branch that everyone's merging their code into, you can verify that those tests can pass. And you can add rules to say that you don't want to allow anyone to merge code into the branch if the tests don't pass, to guarantee that any code that does get merged is going to pass all of those tests as well. And so that can definitely help the development cycle, make it easier to ensure that changes can be made quickly. But as we make those changes quickly, we're not going to lose accuracy and validity within our code, that we can make sure that our code still passes those tests by automating the process of running those tests altogether. So other than continuous integration, then, we now talk about this idea of continuous delivery, these short application cycles where we would like to very quickly be able to deploy our application onto some sort of web server. And when we're deploying applications to a web server, there are things that we need to think about. We need to think about getting our program that was running fine on our computer working on a web server as well. And this can just be fraught with headaches and all sorts of configuration problems, because you might imagine that the computer that you are using is not necessarily going to be the same as the computer that on the cloud, the computer in the server, where your web application is actually running. It might be running a different operating system. It might have a different version of Python installed. If you have certain packages working on your own computer, those same packages might not be installed on the server. So we run into all sorts of various different configuration problems where you can be developing, deploy your code, and realize that it doesn't work on the server because of some sort of difference between what's happening on your computer and what's happening on the server. And this becomes even more problematic if you're working on a larger team. You and multiple other people working on a software project, but you each have different versions of various different packages or libraries installed, and those different versions have different features and might not all work and cooperate with one another. And so we need some way, in order to be able to deploy applications efficiently and effectively, to be able to standardize on just one version of the environment, one version of all these packages, to make sure that every developer is working on the project in the same environment. And once we deploy the application, it's going to be working in the same environment as well. And the solution to this comes in a number of possible options. But one option is to take advantage of a tool like Docker, which is some sort of containerization software. And by containerization software, what we're talking about is the idea that when we're running an application, instead of just running it on your computer, we're going to run it inside of a container on your computer. And each container is going to contain its own configuration. It's going to have certain packages installed. It's going to have certain versions of certain pieces of software. It's going to be configured in exactly the same way. And by leveraging a tool like Docker, you can make sure that so long as you provide the right instructions for how to start up and set up these containers, then if you are working on the application and someone you're working with, some colleague is also working on the same project, so long as you're using the same instructions for how to set up a Docker container, you're going to be working in the identical environments. That if a package is installed on your computer in your container, it's going to be installed in your colleague's container as well. And the advantage of this, too, works with this idea of continuous delivery. When you want to deliver and deploy your application to the internet, you can run your application inside of that exact same container, set up using the exact same set of instructions, so that you don't have to worry about the nightmare headaches of trying to make sure that all the right packages and all the right versions are, in fact, installed on the server. Docker might remind you of the idea of a virtual machine, or a VM, if you're familiar with that concept. GitHub uses VMs, for instance, when running its GitHub Actions. They are, in fact, different. A VM is effectively running an entire virtual computer with its own virtual operating system and libraries and application running on top of that, all inside of your own computer. So a virtual machine ends up taking up a lot of memory, taking up a lot of space. Docker containers, meanwhile, are a bit lighter weight. They don't have their own operating system. They're all running still on top of the host operating system. But there's this Docker layer in between that keeps track of all of these various different containers and keeps track of for each container, such that every container can have its own separate set of libraries, separate set of binaries, and an application running on top of that. So the advantage then of containerization is that these containers are lighter weight than having an entire virtual machine, but they can still keep their own environment consistent, such that you can feel confident that if the application is working in a Docker container, you can have that Docker container running on your computer, on someone else's computer, on the server, to guarantee that the application is going to work the way that you would actually expect it to. And so how exactly do we configure these various different Docker containers? Well, in order to do so, we're going to write what's called a Docker file. So to do this, I'll go ahead and go into airline 1, and I'll open up this Docker file. And the Docker file describes the instructions for creating a Docker image, where the Docker image represents all of the libraries and other installed items that we might want to have inside of the container. And then based on that image, we're able to create a whole bunch of different containers that are all based on that same image, where each container has its own files and can run the web application inside of it. So this Docker file, for example, describes how I might create a container that is going to run my Django web application. So first I say from Python:3. This happens to be another Docker image on which I'm going to base these instructions. That this is going to be a Docker image that already contains instructions for installing Python 3, installing other related packages that might be helpful. Oftentimes when you're writing a Docker file, you'll base it on some existing Docker file that already exists. So here I'm saying, go ahead and use Python 3. And now what do I want to do in order to set up this container? Well, I want to copy anything in dot in my current directory into the container. And I have to decide where in the container am I going to store it. Well, I could choose to store it anywhere, but I'll just store it in /user/source/app, just some particular path that will take me to a directory where I am going to store the application. But you could choose something else entirely. So I copy all of the current files in my current directory. So that'll include things like my requirements file, my manage.py file, my applications files, all my settings files. Everything inside of the directory, I would like to copy into the container. Then I'm saying workdir, meaning change my working directory. Effectively the same thing as something like cd on your terminal to move into some directory. I would like to set my working directory equal to that same application directory. The application directory inside of the container that now contains all of the files for my application because I copied all of those files into the container. Now, once I'm inside of this directory, I need to install all of my requirements. So assuming I've put all my requirements, like Django and any other packages that I need, inside of a file called requirements.txt, I can just run the command pip install requirements.txt. And then finally, inside the Docker file, I specify a command. And this is the command that should run when I start up the container. Everything else is going to happen initially when we're just setting up this Docker image. But when I start up the container and actually want to run my web application, here's the command that should run. And I provide it effectively as like a Python list where each word in the command is separated by a comma. Where here I'm saying the command that I would like to run when you start up this container is Python manage.py run server. And here I'm just specifying on what address and what port I would like it to run. And I'm running it on port 8000, for example. But I could choose another port that I would like to run instead. So what's going to happen then is that when I start up this Docker container, it's going to, if it needs to, go through these instructions and make sure that it sets up the container according to these instructions. Make sure that we've installed all of the necessary requirements. Make sure that we're using Python 3. And anyone using the same Docker file can generate a container that has all the same configuration on it. So we don't have to worry about configuration differences between me and someone else who might not have the exact same computer setup that I do. And the nice thing about this is that it can run on Mac and Windows and Linux. So even people running on different operating systems can still have containers that all have the same configuration, that all work in the same way, just to speed up that process. Now, so far when we've been building Django applications, we've been using a SQLite database. SQLite database just being a file that is stored inside of our application. And this file-based database allows us to create tables, insert rows into it, delete rows from it. In most production environments and most real web applications that are working with many, many users, SQLite is not actually the database that is used. It doesn't scale nearly as well when there are many users all trying to access it concurrently. Oftentimes in those sorts of situations, you want your database hosted elsewhere on some separate server to be able to handle its own incoming requests and connections. And we talked about a couple of possible databases we could use instead of SQLite. Things like MySQL, things like Postgres, or various different SQL-based databases. So imagine now I want to deploy my application, but instead of using SQLite, I would like to use Postgres, for example, as the database server that I would like to run. Well, that would seem to be pretty complicated for me to test on my own, because now in addition to running my web application in one server effectively, I also need like another server that's running Postgres, for example, such that I can communicate with that Postgres database instead. And that's going to be even harder for like other people to be able to work on as well. Potentially, it might be difficult to get the server to work in that way too. But the nice thing about Docker is that I can run each of these processes in a different container, effectively. I can have one container that's running my web application using this Docker file right here. And I can have another container that's just going to run Postgres. And as long as other people also have access to that same container for running Postgres, they can be working in an identical environment to the one that I am working in as well. And so there's also a feature of Docker known as Docker Compose. And what Docker Compose lets us do is allow us to compose multiple different services together. That I would like to run my web application in one container, and I would like to run a Postgres database in another container. But I would like for those containers to be able to talk to each other, to be able to work together whenever I start up the application. So if I'd like to do that, in order to run this application on my computer and have both the web application and Postgres installed, I can create a Docker Compose file, which looks like this. Here I'm specifying using version 3 of Docker Compose. Here I specify, again, using a YAML file, much as in my GitHub workflows were formatted in YAML, just as a configuration file. Docker Compose.yml is a YAML file that describes all of the various different services that I want to be part of my application, where each service is going to be its own container that could be based on a different Docker image. Here, I'm saying that I have two services, one called DB for database, one called web for my web application. The database is going to be based on the Postgres Docker image that Postgres wrote that I don't have to worry about. Someone else has written the Docker file for how to start up a Postgres container. Here, though, for the web application, that's going to be built based on the Docker file in my current directory, the Docker file that I have written. And then down below, I've just specified that my current directory should correspond to the app directory. And then I've specified when I'm running this on my own computer, I would like port 8000 on the container to correspond to port 8000 on my own computer, just so that I can access port 8000 in my browser and access port 8000 inside the container. It just lets my computer actually talk to the container, so I can open up the web application in my web browser, for example, and actually see the results of all of this. So here then, I've created two services, a database and web. So now let's actually try starting up these containers. I'm going to first go into my airline 1 directory. And I'm going to say docker compose up to mean go ahead and start up these services. I'll press return. And what you'll see is we're going ahead and starting up two services. I'm starting up the database service, and I'm starting up the web service. And now, as a result of all of this, I've started up the application. And I started it on port 8000. So if I go to 0.0.0.0/8000 or :8000/flights, that's going to take me to the flights page. And now this is running not just on my own computer, but inside of a Docker container. Now, of course, right now there are no flights inside of this page because I haven't actually added anything to the database yet. So I could do that if I wanted to. But how do I do that? Well, I needed to go into /admin to say, let me log in and go ahead and create some sample flights. But I don't have a login yet because I need to create a super user account. And I can't just inside of my airline 1 directory say python manage.py create super user the way that I used to, because this is running in my terminal on my computer. Whereas what I really want to do is go into the Docker container and run this command there inside of the container. So how can I do that? Well, there are various different Docker commands that I can use. Docker ps will show me all of the Docker containers that are currently running. So go ahead and shrink this down a little bit. I see 2 rows, one for each container, one for my Postgres container that's running the database, one for just my web application that's running as well. Each one has a container ID. So I want to go into my web application container in order to run some commands inside of that container. So I'm going to copy its container ID and say docker exec, meaning go ahead and execute a command on the container. -it will make this interactive. Here's the container ID that I would like to execute a command on. And the command I want to execute is bash, pass in the -l flag, but bash to say I want to run a bash prompt. I want to be able to interact with a shell so that I can run commands inside of this container. So I press return. And now what you'll notice is that I am inside of my container in the user source app directory, that directory that contained all of the information about this web application. I type ls, and what I'll see is here are all the files inside of this container now. And now I can say something like python manage.py create superuser. And now it's going to let me create a superuser. So I'll create a user inside of my web application called Brian. I'll give it my email address. I'll type in a password. And now we've created a superuser. And you can run other commands here. If you wanted to migrate all of your migrations, I could say python manage.py migrate. It turns out I've already done that, so I didn't actually have to do it again. But you can run any commands that you could run on your computer, but now you can run them inside of the Docker container instead. And I can press Control-D just to log out, get out of the container, and get back to my computer. But now I've created a super user, so I could go ahead and sign in to Django's admin. And now I can begin to manipulate this database, which is a Postgres database running in a separate container. But the nice thing about it is that I can start them both up together just by running something like docker compose up, for example. So Docker can be quite a powerful tool for allowing us to very quickly ensure that an application is running in the environment that we expect it to be running, to make sure that all of the right libraries are installed, make sure that all the right packages are installed as well, that the configuration between my development environment and the environment that's running on the server are the same as well. So those then were just some of the best practices for how you can go about developing a program now that we have the tools to do so. We have a lot of tools for being able to develop these web applications. But as our programs start to get more complex, it'll be increasingly important to test them. Make sure that each various different component of our web application behaves the way that it is expected to behave. And then taking advantage, especially in bigger teams, of CI/CD, continuous integration, continuous delivery, to make incremental changes and make sure each of those incremental changes, in fact, works on the web application. And then CD, continuous delivery, to say that rather than wait and then deploy everything all at once, let's deploy things incrementally as well. Let users more quickly get access to the latest features, and more quickly find out if something went wrong. We can better identify what it is that went wrong if we've deployed things incrementally, rather than waiting a long time in order to do so as well. So these are some of the best practices in modern software application development, not only for web applications, but for software more generally. Next time, we'll consider other challenges that might arise as we go about trying to make web applications that are used by more and more users. In particular, taking a look at challenges that will arise in terms of scalability as our programs get bigger, and also security, of what security vulnerabilities open themselves up as we begin to design our web applications using Python and JavaScript. So more on that next time, and we'll see you then. All right, welcome back, everyone, to web programming with Python and JavaScript. And for our final topic, we're going to explore scalability and security. So far in the class, we've been building web applications, and we've been building web applications that work on our own computer. But if we want to take those web applications and deploy them to the world so people all across the internet can begin to use them, then we're going to need to host our web application on some sort of web server, some dedicated piece of hardware that is listening for web requests and responding to them with the response that we would like for our web application to deliver. And when we do so, this introduces a whole bunch of interesting issues surrounding scalability and security. So we'll take a look at these issues today, beginning with problems concerning scalability, what those problems are, and how we might go about addressing them. So when we deploy our web applications, we deploy them by putting them onto a web server that I'm here just representing with this rectangle. But all the server is some dedicated computer, some piece of hardware that is listening for incoming requests. So we'll draw this line to represent an incoming web request from a user. The server takes that request and responds to it. But ultimately, our web application isn't just going to be servicing one user. If it becomes popular, it might have many users that are all trying to connect to that server at the same time. And as multiple people start to connect to that server at the same time, here's where we start to deal with issues of scalability. A single computer, a single server, can only service so many users at any given time. And so therefore, we need to think in advance about how we're going to deal with those issues of scale. But the first question, before we even get there, is where these servers actually exist. And nowadays, there are two main options for where these servers can exist. These servers can be on the cloud, or they can be on-premise. And on-premise servers, you might imagine, as if a company is running their own web application, on-premise servers are servers that are inside of the company's walls. The company owns the physical servers, maybe on some server racks inside of a room, and therefore they have very direct control over all of those servers, exactly what kind of servers they are, exactly what software is running on them. They can go and physically look at the servers and debug them if need be in order to make sure that any issues are dealt with. But increasingly, we're starting to move into a world where cloud computing is becoming increasingly popular. Where in cloud computing, rather than have dedicated servers that are on-premise, we have servers that are somewhere in the cloud, where cloud computing companies like Amazon or Google or Microsoft are able to run their own servers, and we simply use those servers that are provided by those third parties, whether it's Amazon or Google or Microsoft or someone else. And there are trade-offs here. With cloud computing, we no longer have as direct control over the machines themselves because they're not on-premise. We can't physically manipulate those computers. But we have the advantage of not having to worry about dealing with physical objects that are inside of the premise of the company whose servers we'd like to run code for. That when it's on the cloud, everything is managed externally by some other company, and we can simply use the servers that we need to. And we'll see that this lends itself to other benefits as well, as we might need more servers as we start to get more sophisticated web applications that need more users. These cloud computing companies can allow us to create web applications that are able to scale across multiple different servers as we start to get more and more users. But we'll discuss those issues of scale as we get to them. The question we need to ask after we have these servers, whether they're servers that are on-premise or servers that are operating somewhere in the cloud, is how many can those users can the server actually service at any given time? And that's going to vary. It's going to vary based on the size of the server, the computing power of the server, and it's going to be dependent upon how long it takes to process any particular user's request. If user requests are quite expensive, it might mean that there are fewer users that can be serviced at any given time. And it's for that reason that a helpful tool is to do some kind of benchmarking, some process of trying to do some analysis on how many users a server can actually be handling at any particular time. And there are numerous different tools that allow us to do this kind of benchmarking. Apache Bench, or otherwise known as AB, is a popular tool for doing this kind of thing. But benchmarking is going to be useful so that we know how many users one particular server can handle. Maybe it can handle 50 users, maybe it can handle 100 users, maybe it can handle more at any given time. But ultimately, it's going to be some finite limit. Every computer just has some finite amount of resources, and servers are no exception. There's going to be some number of users after which the server is not going to be able to handle it. So what do we do in that situation? What do we do if our server can only handle 100 users at any given time, but 101 users are trying to use our web application at the same time? Something needs to change. We need to deal with some sort of scaling to make sure that our web application can scale. And there are a couple of different types of scaling that we can try. One approach is to do what's called vertical scaling, which might be the simplest way you could imagine scaling. If this server is not good enough for handling the number of users that we need it to handle, we'll then just get a bigger server. In vertical scaling, we just take the server and get a bigger server, a more powerful server, a server that can handle more users at any given time. It's going to cost more, but if we need it to handle more users, we can just get a bigger server to be able to deal with that problem. This approach is fairly simple. It just involves swapping out one server for another, one that can handle more users concurrently. But it also has drawbacks, right? There's some limit to how big the server can be, to how many users any physical one server is going to be able to handle, because there's a physical limitation on what is the biggest, fastest, most powerful server we could possibly get. So when vertical scaling ends up not being enough, an alternative, as you might imagine, is what's known as horizontal scaling. And the idea behind horizontal scaling is that when one server isn't enough to be able to service all of the users that might be trying to use a web application at the same time, well, then we can take the approach of saying, well, rather than just using one server, let's go ahead and split it up into two different servers. We now have two servers that are both running the web application. And now, effectively, we've been able to double the number of users that this web application can handle. Rather than just a single server that can service 100 users, if we have two of them, now we can service 200 users at any given time. If you imagine 100 of them using server A over here and 100 of them using server B over there. But this then lends itself to some other questions that we have to answer, which is how do these servers get their users in the first place? Like when a user requests a web page, how does that user get directed either to server A or to server B? It seems that they need some way to make that decision in order to decide whether to go one direction or another. And it's for that reason that we might introduce another piece of hardware into this picture. And that additional piece of hardware is what we might call a load balancer. And a load balancer is just another piece of hardware that is going to sit in front of these servers, so to speak. In other words, when a user makes a request to a web page, rather than immediately getting that request to one of these web servers, the request is first going to go through this load balancer, where the request first comes into the load balancer, and the load balancer then decides whether to send that request to server A or to send that request to server B. And this process is likely less expensive than actually dealing with and processing that request. So the load balancer is effectively just acting as a dispatcher. It waits for those requests to come in, and when the requests do come in, the load balancer directs those requests either to go to one server or to another. And you might imagine a story where we have more than just two servers. Maybe we have many servers, and the load balancer is just going to balance between all of those different servers. And this process of deciding which server to send a request to is known as load balancing, which is what the load balancer is ultimately doing. And there are various different methods that you might use in order to perform this load balancing. So you might imagine thinking about this intuitively. How would the load balancer decide, given some request, should we send the request to this router, to this server, or should we send the request to some other server instead? And there are many different approaches that our load balancer might take, and here are just a couple. Random choice might be the simplest of options. Given a user that shows up and tries to make a request to our web server, the load balancer first takes a look at the user and just randomly assigns them to one of the various different servers that might be processing that request. If there are 10 different servers, it randomly chooses among those 10 servers to decide which of them is going to be servicing that request. This has the advantage of being very simple. It's just a quick calculation. The computers can pretty readily generate random numbers. And based on that random number, the computer can dispatch the user to one server or to another server. But it might not be the best option, because if we happen to get unlucky, we might end up with many more users on one server than another, or we might end up with servers that are entirely unused if it just so happens that we don't end up randomly selecting that server. Now, in practice, with many users that are all using this load balancer, all being dispatched, odds are high that eventually all of them will be used, but it might not be a totally even distribution. And so for that reason, another approach you might take is a round-robin approach, where the approach is instead, for the very first user, go ahead and assign that user to server number 1. For the next user, assign them to server number 2, and maybe if there are 5 servers, you say, the third user goes to server 3, user 4 goes to server 4, user 5 goes to server 5, and then user 6 goes back to server number 1. You basically rotate going 1 through 5, and then once you've assigned someone to each of the servers, you go back to the beginning. This is also a relatively easy thing to implement because you can simply just keep count somewhere in the load balancer saying what was the most recent server that I assigned a user to, and the next time a request comes in, go ahead and assign it to the next server. And the next server after that effectively is doing a round-robin style approach where you go through all the servers once before going through those servers again. Now, this might seem better than random choice in the sense that it's going to more equitably decide whether to assign any particular request to any particular server. But it also suffers from certain problems, that round robin might be great, but if some requests take longer than other requests, we might also get unlucky, and the requests that are taking longer might end up all going to one of the servers as opposed to another server. So there are other approaches that we might want to go to as well. For example, something like fewest connections, where the approach there is to say, go ahead and when a user makes a request, the load balancer should pick which of the servers currently has the fewest connections, the fewest active connections from other users and other requests that are currently connected to those servers instead. And by choosing the server that happens to have the fewest connections, you're probably going to do a better job of trying to balance out between all of the various different requests that might be happening inside of your web application. And while this might do a better job, there are trade-offs here as well, that it might be more expensive, for example, to compute which of the servers happens to have the fewest number of connections, whereas it's much easier just to say, choose a server at random, or to do the round-robin style approach of just 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, again and again and again. But all of these approaches naively have yet another problem, which has to do with sessions. And you recall that sessions we used whenever we wanted to store information about the user's current interaction with the web application. When you log into a website, like you log into your email or you log into Amazon, for example, and then you come back to that website or visit another page on that website, making another request, for example, it's not the case that you have to sign in yet again, that the web browser has totally forgotten who you are. When I go back to my mail account or when I go back to Amazon for a second time, my mail account or Amazon remembers me from the last time that I visited. I have some sort of session where it's keeping track of who is logged in, maybe information about what I've been doing on the page, and allows me to continue interacting with the web application even if I'm making multiple requests. And this, you might imagine, could be a problem for this type of load balancing. That if I have multiple different servers, imagine if I try to log into a website, and the first time I make a request, I'm directed to server number 1. And I'm now logged in on server number 1. But then I make another request. I'm directed back to the load balancer. And maybe the load balancer this time decides to send me to server number 2. But if the session is stored in server number 1 somewhere, if server number 1 remembers who I am and what I'm doing, then server number 2 is not going to know who I am, and therefore it's not going to remember that I've already logged into this web application. And as a result, I might be prompted to log in again. And if I go make another request and I end up on yet another server, I might be logged out again and have to log in for a third time. So the problem comes about when our load balancing happens, but we're not doing so in a session-aware way, that our load balancer isn't caring about when a user visits a page and then visits another page on the same web application again, because we want to remember information from the previous time that the user was here. So how can we solve this problem? How can we make sure that when we do this load balancing across multiple different servers, that we do so in a session-aware way? Well, there are multiple different approaches to session-aware load balancing. One approach is this general idea known as sticky sessions, where the idea is that when I come back to the load balancer will remember what server I was sent to last time and send me there yet again. So for example, if I log into a website once and I'm directed to server number 2, for example, then the next time I visit this web application, even if I should be directed to server 3 or 4 according to random choice or according to fewest connections or any of these other load balancing methods, the load balancer should remember that last time I came to this site, I got directed to server number 2. And so this time, the load balancer is going to direct me to server number 2 yet again. That way, server number 2, which contains information about my session, is going to see me again and remember who it is that I am. And it's not going to make me log in again into the exact same website for a second time, for example. And so sticky sessions are one way of dealing with this problem. But again, with all of these approaches, and this will be a recurring theme as we talk about scalability and security, there are trade-offs here. That a trade-off to the sticky sessions is that it's possible that one of these servers is going to end up getting far more load than another if one server happens to have a lot of users that keep coming back to the website and keep requesting additional pages, but other servers might have had users that decided not to come back, for example. And so there's a difference in utilization, where some of our servers might be more heavily utilized than other servers, and we're not doing a very good job of balancing between them. And so one approach is to store sessions inside of the database, rather than store information about sessions inside of the server themselves, so that if I get directed to another server, that other server doesn't remember who I am, doesn't remember information about my interaction with this website. If we instead choose to store sessions inside of a database, and in particular, inside of a database that all of the servers have the ability to access, well then, it doesn't matter which of the servers I get directed to and which server the load balancer decides to send me to, because regardless of which server I end up getting sent to, the session information is in the database, and each of the servers can connect to the database to find out who I am, to find out whether I've logged into this site already, and therefore is able to recognize me. And so that might be one approach as well. Another approach is to store sessions on the client side. We've talked a little bit about this idea of cookies, which can be stored where the web browser can set a cookie so that your web browser is able to present that cookie the next time it makes a request to the same web application. And inside this cookie, you can store a whole bunch of information, including information about the session. You might, inside of a cookie, store information about what user is currently logged in, for example, or other session-related information. But here, too, there are drawbacks. If you're not careful, someone could manipulate that cookie and maybe pretend to be something else. And so for that reason, you might want to do some encryption or some kind of signing to make sure that you can't fake a cookie and pretend to be someone that you're not. But another concern is that as you start to store more and more information inside of these cookies keep sending back and forth between the server and the client every time a request is made. That can start to get expensive, too. More and more information passing back and forth between the client and between the server. So lots of possible approaches. No one approach that is necessarily the right approach or the best approach to use in any cases, but things to be aware of, things to think about as we begin to deal with these issues of scale, of making sure we have multiple servers that are available for usage in case we do need it, but also making sure that when we do so, we don't break the user experience. We don't result in a situation where a user is logged in, but then suddenly isn't logged in at all. And so horizontal scaling gives us this kind of capacity, the ability to have multiple different servers, all of which can be dealing with user requests and responding to those user requests as well. But a reasonable question to ask is, how many of those servers do we need? Now, we can use benchmarking to try to estimate this. If we have an estimate of how many users are going to be on our website at any given time, we can benchmark and see how many users can be handled by a single server, and extrapolate based on that information to infer how many servers we might need in our web application to be able to service all of these different users. But it might be the case that our web application doesn't always have the same number of users. Maybe sometimes there are going to be far more users than another time. You might imagine, for example, that in a news organization's website, like the web application for a newspaper, when there's breaking news, some big story, there's going to be a lot more people that are all trying to access the website at the same time than at other times. So one approach might be, consider the maximum. What is the most number of users that ever might be trying to use our web application at any given time, and choose a number of servers based on that maximum, so that no matter how high the number of users get, we will have enough servers to be able to service all of those users. But that's probably not a great economical choice if, in the vast majority of cases, there will be far fewer users. In that case, you're going to have a lot of servers that are underutilized, where you don't need that many servers, but you're still paying for the electricity for keeping all of them running, which might not be an ideal choice either. So one solution to this, quite popular, especially in this world of cloud computing, is the idea of auto-scaling, where you can have an auto-scaler to say that, you know what, let's start with, for example, 2 servers. But if there's enough traffic to the website, if enough people are making requests to the website, maybe it's a peak time where people are using the website, go ahead and scale up. Go ahead and add a 3rd server, where now our load balancer can balance between all 3 of those servers. And if even more traffic ends up coming to the website, more users are trying to use this application all at the same time, well then we can go ahead and add a 4th server as well, and we can continue to do that. Most autoscalers will let you configure, for example, a minimum number of servers and a maximum number of servers, and dependent on how many users happen to be using your web application at any given time, the autoscaler can scale up or scale down, adding new servers as more users come to the website, removing servers as fewer users are using the website as well. And so this can be a nice solution to this problem of scale, where you don't have to worry about how many servers there are. It just auto-scales entirely on its own. Now, there are trade-offs here, too, that this auto-scaling process might take time. And if a lot of users all come into your website all at the exact same time, well, it's going to take some time to be able to add all of these additional servers to start them up. And so there might be some trade-offs there, too, where you might not be able to service all of those users immediately. And another problem worth thinking about is as you add more and more of these servers, you introduce opportunities for failure. Now, it's better than having a single server, where if that single server fails, now suddenly the entire web application doesn't work at all. That's what we generally call a single point of failure, a single place where if it fails, the entire system is going to be broken. One advantage of having multiple servers is that we no longer have a single server that acts as a point of failure. If one of the servers goes down, then ideally our load balancer should be able to know, based on that information, to no longer send requests to that particular server, to instead balance the load across the remaining 3 servers instead. Now, there's an interesting question there as well, which is how does the load balancer know that this server is no longer responding, that for some reason it's had some sort of error, that it's not able to process requests appropriately? Well, there are multiple ways you can do this, but one of the most common is what's simply known as a heartbeat, where effectively, every so often, every some number of seconds, the load balancer pings all of the servers, just sends a quick request to all of the servers, and all of the servers are supposed to respond back. And using that information, the load balancer knows a little bit about the latency of each of the servers, how long it took for the server to respond to the request. But also, it can get information about whether or not the server is functioning properly. That if one of the servers doesn't respond to the ping, well, then the load balancer knows that there's probably something wrong with the server, that we probably shouldn't be directing more users to that server at all. And so this can solve for the problem of a single point of failure by allowing ourselves multiple servers where if any one of the servers fails, the load balancer learns about that via a heartbeat, and then based on that information can begin to redirect traffic to the other servers instead. Now, one thing you might notice is that even in this picture, now the load balancer appears to be like a single point of failure, where if the load balancer happens to fail, well, now nothing is going to work, because the load balancer is the one responsible for directing traffic to all of these various different servers. And so even there's no single server that is a point of failure, this load balancer also appears to be a single point of failure. And that's definitely true. And you might imagine instead having multiple load balancers, where if one load balancer goes down, another load balancer can swoop in, acting as a hot spare, where it picks up all of the traffic that was originally going to the first load balancer, and if it ever goes down, a second one is ready to take its place. And it might also be doing this kind of heartbeat process, checking up on the first load balancer, and if all is well, the second load balancer doesn't have to do anything. But if the first load balancer ever were to fail, well, then the second load balancer can step in and begin servicing those requests, directing them to all of these individual servers as well. And so there, too, another opportunity to think about where the single points of failure are and thinking about how we might address those single points of failure in order to make sure that our web applications are scalable. So that then deals with issues about how we might go about scaling up these servers. But ultimately, the servers are not the entirety of the story. That inside of our applications, we've mostly been writing web applications that interact and deal with data in some way. And there are multiple different databases that we've talked about. SQLite has been the default one that Django provides to us, which just stores data inside of a file. But as we begin to grow our applications, as we want to begin to scale them, it's quite popular and quite common to put databases entirely somewhere separate, to have a separate database server running somewhere else, where the servers are all communicating with that database, whether it's running MySQL or Postgres or some other database system instead. And all of the servers then have access to that database. And so there, too, are considerations that we need to take into account, issues of how it is that we go about scaling up these databases. That in this picture, for example, you might imagine a load balancer that is communicating with 2 servers, but both of those servers, for example, need to be communicating with this database. And much like any server can only handle some number of requests, some number of users at any given time, databases too can only handle some number of requests, some concurrent number of connections at any given time. And so we need to begin to think about issues of how it is that we scale these databases as well in order to be able to handle more and more users. Now, one approach, the first thing we might try to do, is something called database partitioning, effectively splitting up what is a big data set into multiple different parts to that data set. And we've already seen some examples of database partitioning. We've seen one example where, for example, when we talked about SQL, we looked at a table of flights, where each flight had an origin city, the origin city's airport code, the destination city's airport code, and some number of minutes, the duration for that particular flight. And we decided that storing all of this data in a single table probably wasn't the best idea, and instead we wanted to split that data up in a type of partitioning, where instead we said, all right, let's just have one table that will have all of the airports. And so each airport gets its own row inside of this airports table. And we also had another table, which was just the flights table, which rather than storing all of those columns, just mapped two airports to each other. That with any given flight, it has an origin ID, meaning which object, which row in the origin airports table is represented by the flight, and then which row in the airports table is going to represent the destination for that flight. So we took one table and effectively split it up into multiple tables, each of which ultimately had fewer columns. And this might be something we call the vertical partitioning of a database, where instead of just having single big long tables, we split them up into multiple tables, each of which have fewer columns that are able to represent data in a more relational way. And that's something we've seen before too. But in addition to vertical partitioning, we can also do horizontal partitioning, where the idea there is that we take a table and just split it up into multiple tables that are all storing effectively the same data, but split up into different data sets. So the same type of data, but just in different tables, where we might have originally had a flights table, and instead we split it up into a domestic flights table and an international flights table. Each of these tables still has the exact same columns. They still have a destination column. They still have an origin column. They still have a duration column, for example. But we've just now taken the data that used to be in one table and split up that data into two or more multiple different tables instead. One for all the domestic flights, one for all the international flights. And the advantage there is that we no longer need to search through the entirety of the data set if we're just looking for one domestic flight, for example. If you know the flight you're looking for is a domestic flight, well, then it can be more efficient to just search the flights domestic table and not bother searching through the flights international table. And so if we're intelligent about how we choose to take a table and split it up into multiple different tables, the effect of that is that we can often improve the efficiency of our searches, the efficiency of our operations, because we're dealing with multiple smaller tables where these operations can come faster. One drawback, though, is that as we begin to split data across multiple different tables, it becomes more expensive if ever we need to join this data back together and connect all the domestic and international flights running separate queries on each. And so in that case, we'll want to think about trying to separate our data in such a way that generally we're only going to need to deal with one table or the other at any given time. And so domestic and international might be a reasonable way to split up our flights table, because maybe most of the time our airport just cares about searching domestic flights if we know we're looking for one kind of flight, or just cares about searching for international flights if there are different people or different computers that are going to handle each of those different types of systems. And so partitioning our database can sometimes help with issues of scale by making it faster to search through large amounts of data and being able to represent data a little bit more cleanly. But it still seems to represent a single point of failure, that we have multiple servers now that are all connected to the same database. And there again is a single point of failure. If the database fails for some reason, well, now suddenly none of our web application is going to work because all of those servers are all connected to that exact same database. And so it's for that reason that we might, just as we tried to add more servers in order to solve the problem of a single point of failure with our servers, we might also try database replication. That rather than just have a single database in our web application, in order to guard against potential failure, we might replicate our database, have multiple different databases, and therefore reduce the likelihood that our application entirely fails. And there are a couple of approaches that we can use for database replication. Two of the most common are what are known as single primary replication and multi-primary replication. And in single primary database replication, we have multiple different databases, but one of those databases is considered to be the primary database. And what we mean by a primary database is a database to which we can both read data, meaning like select rows from the table, but also write data, meaning insert rows or update rows or delete rows to any of those tables. So in single primary replication, we have a single database where we can both read and write. And we have some number of other databases, in this case 2 other databases, from which we can only read data. So we can get data from those databases, but we can't update or insert or delete from those databases. And now we need some mechanism to make sure that all of these databases are kept in sync. And ultimately what that means is that any time the database changes, all of the databases are informed. Now, the only database that can change is our primary one. This is the only one that can be written to, the only one that allows for the data to change. The others are read-only. So anytime this primary database updates or changes in some way, it needs to inform the other databases of that update. And so it informs the other databases of that update. And now all of the databases are kept in sync, where if you try and run a query on any of these databases to select and get some information, you'll get the same results from all of these various different databases. Now, the single primary approach has some drawbacks. It has the drawback of only one of these databases can be written to. So if you have a lot of users that are all trying to write data to the database at the exact same time, well, there might be some issues here where this one database is going to be carrying all of that load for all of the people that might be trying to update and change that database. And it also has a slightly smaller version of the same problem of a single point of failure. There's no longer a single point of failure for reading from that data, that if you want to read from the data and one of the databases goes out, you can read data from any of the other databases and they'll work just fine. But it does have the drawback that if this database fails, if our primary database fails, well, then we're no longer able to write data. That if we want to update data inside of our database, this one database is no longer going to be operational, and none of the other databases are going to allow us to write new changes. So there are a couple of approaches we can use to try to solve this problem. One approach, though, is instead of having a single primary database, a single database to which we can read and write, to use a multi-primary approach. And in the multi-primary approach, we have multiple databases, all of which we can read and write to. We can select rows from all the databases, and we can insert and update and delete rows to all of these databases as well. But now the synchronization process becomes a little bit trickier. And here now is the trade-off, that now we've replicated the number of reads and writes we can do by having many databases to which we can read data and write data. But anytime any of these databases changes, every database needs to inform all of the other databases of those updates. And that's certainly going to take some amount of time. It introduces some complexity into our system as well. And it also introduces the possibility for conflicts. That you might imagine situations where if 2 people are editing similar data at the same time, that you might run into a number of different types of conflicts. So one type of conflict, for example, would be an update conflict. If I try to edit one row in one database and someone else tries to edit the same row in another database, when they sync up with each other via this update process, our database system needs some way to decide how it's going to resolve those various different updates. Another conflict might be a uniqueness conflict. We've seen in the case of databases in SQL that when we're designing our tables, I can specify that this particular field should be a unique field. Common one being the ID field, for example, where every single row is going to have its own unique ID. Well, what happens if 2 people try to insert data at the same time into 2 different databases? They're each given a unique ID, but it's the same ID on both of the databases because neither database knows that the other database has added a new row yet. So when they sync back up, we might run into uniqueness conflict where 2 different databases have assigned the same exact ID to multiple different entries. And so we need some way to be able to resolve those conflicts as well. And there are many other conflicts that you might imagine trying to deal with. One example being, for instance, delete conflicts, where one person tries to delete a row and another person tries to update that row. Well, which should take precedence? Should we update the row? Should we delete the row? We need some way to be able to make those decisions because there is some latency between when a change is made to a database and when that database is able to communicate with another database. So these issues of scale, these issues of synchronization are always going to come up as we start to deal with programs that are interacting with more and more of this kind of data. And as a result, we need to design more and more sophisticated systems that are able to deal with those issues of scale. Now, ultimately, we'd ideally like to reduce the number of different of these database servers that we have, that every additional database server is going to cost time, it's going to cost resources, it costs money in terms of keeping all of these servers running. And so ideally, we'd like not to have to talk to this database if we don't need to. So you might imagine, for example, a news organization's website, something like the front page of the New York Times. If you go to the home page of the New York Times website, it displays all of the day's headlines with images and with information about what each of the stories are about, for example. And you might imagine that the way they're doing something like this is that they have some kind of database that's storing all of these news articles. And when you visit the front page of the New York Times, it's going to do some kind of database query, selecting all of the recent top headlines, for example, and rendering all of that information in an HTML page that you can see. And that would certainly work. But if a lot of people are all requesting the front page at the same time, well, it probably doesn't make all that much sense if the web application every time is making a database query, getting the latest articles, and then displaying that information to all of the users, because the articles might not be changing all that frequently. If one person makes a request 1 second and another person makes the same request half a second later, it probably is not going to be useful to re-request all of the information from the database, regenerate that template yet again, because it's an expensive process of requesting data from the database, of generating that template. We'd ideally like some way of dealing with that problem. And the way we can deal with that problem is some form of caching. And caching refers to a whole bunch of different types of ideas and tools that we can use at various different places inside of our system. But in general, when we're talking about caching, we're talking about storing a saved version of some information in a way that we can access it more quickly, so that we don't need to continue making requests to a database, for example. And so there are a number of ways we can do caching. One way we can do caching is on the client side, via client-side caching, where the idea is that your browser, whether it's Safari or Chrome or something else, is able to cache data, store information, so that the browser doesn't need to re-request the same information the next time it visits the page. For example, if you request a page and it loads an image on the page, for example, and you reload the page, well, your web browser might try and make a request again for the exact same image and then display it to you. But an alternative might be that your web browser could just save a copy of the image inside of a cache to locally store a version of the image, so that the next time that the user makes a request to the website, the user doesn't need to reload that entire image. And that might be true of entire web pages and web resources, that if there's some page that doesn't change very often, then if the web browser just stores a cached, a saved version of that page, then the next time the user goes to their web browser, tries to access that page, rather than re-request to the server and make a new request that the server needs to respond to, if the browser has that page cached, the browser can just display the cached, saved version of the page, saving the need to talk to the server at all. So this can certainly help to reduce the load on any given server, that if users are caching information inside of the web browser, it makes the experience faster for the user, because they can see the information immediately rather than need to make a request and wait for a response to come back. And it's good for the server, because the server doesn't need to be dealing with as many requests if some of those requests are getting cached. And so one approach to trying to do this is by adding this inside of the headers of an HTTP response. That when your web server responds to some request, the web server can include a line like this inside of the response, something like cache control, max age 86,400, in effect specifying the number of seconds that you should cache this resource for. That if I try to access this page 10 seconds later, well, that's less than 86,400. So rather than reload and re-request the entire page, we're just going to use the version of the page that happens to be cached inside of the web browser. And so this has several advantages that we've talked about in terms of reducing the amount of time it takes to see the content of a page because it's already saved, and reducing the load on any particular server. But it also has drawbacks, that if, for example, the resource changes within this amount of time, that maybe in 60 seconds the page has changed, if I try and load the page again, well then, if it's loading the cached version of the page, I might be seeing an outdated version of a web page. I'm seeing an older version of the web page because my web browser just so happens to have that particular resource cached. And this might be true of a web page. It's especially true of other like static resources, things like CSS files or JavaScript files, that the CSS of a web page probably doesn't change all that often. And so as a result, it's pretty natural that your web browser, rather than request the exact same CSS files again and again and again, might just save a copy of those CSS files, cache them, such that it's able to just reuse the cached version. But if the website were to update their CSS, you might not see the latest changes. And you might have experienced this yourself as you're working on your own web applications. When you change your CSS and refresh the page, you might not always see those changes reflected if your web browser is caching those results. And so in most web browsers, you can do a hard refresh to say, ignore whatever is in the cache and actually go out and make a new request and get some new data. But ultimately, if you don't do that, you're subject to this cache control, where the web browser is going to say, unless this number of seconds has elapsed, we're going to reuse the existing version of the page. And so an alternative to this approach, and this approach certainly works and is quite popular, we can add to this approach by adding what's known as an E tag. And the E tag for a resource, like a CSS file or an image or a JavaScript file, is just some unique sequence of characters that identifies a particular version of a resource. It identifies a particular version of a CSS file or a JavaScript file, for example. And what this allows a program to do, like a web browser, is that when a web browser requests a resource, like makes a request for a CSS file or a JavaScript file, they get it back, and they get its associated E tag value. So I know that this is the value that is associated with this version of the CSS file. And if the web server were ever to change that CSS file, replace it with a new updated CSS file, the corresponding E tag will also change. So why is this helpful? Well, it means that if I am trying to decide, should I load a new version of the resource or not, should I try and make another request to get the latest version of the CSS, what I can do first is just ask for what is the E tag value, this short sequence that can be answered very quickly. That very quickly, we can just respond and say, you know what? If the E tag value is the same as what I remembered from last time, well, then I don't need to get a whole new version of that resource. And so this is quite common, too, that a web browser will say, hey, let me request this resource, but I already have a version of the resource with this particular E tag. So if that E tag is still the E tag for the most recent version of a particular resource, like a CSS or JavaScript file, then no need for the web server to send a new version of that file. Just go ahead and respond and say, the version you have, that one works totally fine. But if there is a new version, well, then the web server can respond with the new asset, the new CSS file, for example, but also the new E tag value. So these two approaches can work in concert with each other. That you can say, go ahead and cache this for some number of seconds, so that for some number of seconds, you're not going to ever request a new version of that resource. But even if you do ask for a new version of the resource after this number of seconds has elapsed, if the E tag value hasn't updated, then no need to re-download a whole new version of a particular file. You can just reuse the version that happens to be cached already in the browser. So caching in the browser can be an incredibly powerful tool for trying to speed up these requests, for trying to reduce the load on any particular server. But the client side is not the only place where we can begin to do this kind of caching. We also have the ability to do server-side caching. And in server-side caching, we're going to introduce to our picture the notion of a cache. That we have these multiple servers that are all communicating with the database. But these servers can also communicate with a cache, some place where we've stored information that we might want to reuse later rather than have to do all of that recalculation. And Django, it turns out, has an entire cache framework, a whole host of features that Django offers that allow us to leverage this ability to use the cache to be able to speed up requests. So there are per view caches where you can specify a cache on a particular view to say that rather than run through all this Python code every time someone makes a request to this particular view, instead, just cache the view so that for the next 30 seconds or 30 minutes, the next time someone tries to visit the same view, go ahead and just reuse the results of the last time that that view was loaded. And this can work not just for a single view. It can work for fragments inside of a template. That your template might have multiple different parts. That on your web page, you might render the navigation bar and the sidebar and the footer, maybe based on information about today that might change the next day. But if you expect that the sidebar of your page is not going to change very often within the same minute or within the same hour, well, then you might imagine caching that part of the template so that the next time that Django tries to load that entire template, it doesn't need to recalculate how to generate the sidebar for your website. It just knows that we can use the saved version of the sidebar from the last time that we loaded this website instead. And Django also gives you access to a lower level cache API, where for any information that you might want to cache and store for use later, you can save that information inside of the API. You make an expensive database query that takes a couple of milliseconds or a couple of seconds to process. You can save those results inside of a cache to make it easier to access that same data if ever you tried to get access to that again. So caching allows us to be able to deal with these issues of scale by reducing load on our servers, but also on our databases. That rather than need to talk to the database every single time we make a new request for a particular web application, we can just reuse information that happens to be in the cache to allow our web applications to become even more scalable. So that then was a look at some issues concerning scalability. And we'll next turn our attention to security, trying to make sure that as we build our web applications, as we deploy our web applications and more users start to use them, we want to make sure that they're secure. And there are a whole bunch of security considerations to take into account across all of the topics that we've looked at in the course. We've looked at a number of different topics, and with each of them, there are security vulnerabilities, there are ideas to be mindful of when it comes towards making sure that our applications are secure. And we can begin our story, in fact, by talking about Git and version control. Git is all about trying to make sure we're able to keep track of different versions of our code. And one thing that goes hand in hand with Git is this idea of open source software. That on websites like GitHub and other services that host Git repositories, increasingly a lot of software is becoming open source, where anyone can see and contribute to the source code of an application. And this is great in the sense that it allows for many people to be able to collaborate, work together in order to try to find bugs that might exist inside of a web application. But it also comes with drawbacks. Drawbacks where if there is a bug in the application, now someone who's looking through the source code of our program might be able to spot that bug. Or you might imagine that because Git keeps track of different versions of our code every time we make a commit to our repository, you have to be very careful when it comes towards credentials or things that might leak inside of the source code. You generally never want to put passwords or any secure information inside of the Git repository, because the Git repository could be shared with other people. It might be open to anyone to look at. And so those are security considerations to be mindful there as well. That if you make a commit and accidentally make a commit to your code where you expose those credentials, you might remove those credentials and commit again, so the latest version of your program doesn't have those credentials in it. But someone who has access to the Git repository has access not just to the latest version of your code, but to every version of your code. And that person could theoretically go back through the history of the repository and find the commit where the credentials were exposed and see those credentials as well. So while Git is a very powerful tool, it's also one to be mindful of, that any change you make could potentially get saved inside of a commit, could potentially, therefore, be accessed later on. And so if ever credentials are exposed inside of the repository, you want to make sure to wipe out all of those previous commits and not just make some new commit in order to try and hide the previous credentials that can be exposed, because they can still be retrieved if someone goes back through the history of any particular repository. And so that then was a look at some issues that might surround Git. We also talked at the beginning of the course about HTML and about what it is that we can use with HTML and how we can use this language in order to design the structure of a web page, in order to decide where all of the paragraphs are going to be, what tables are going to be on the page. We talked about links and how we can use anchor tags to link one page to another page. Now, one concern is this type of attack known as a phishing attack with HTML. And a phishing attack really just comes down to a little bit of HTML that looks like this. Very easy to write, where I have an anchor tag that is going to direct the user to URL 1, but it looks like it directs the user to URL 2. So what might an example of this be? All right, so we'll take a look. I'll go ahead and open up link.html. And in link.html, I have a website that I've written that appears to have a link to Google. But if I click on that link, I'm suddenly directed to this course's website, for example. So how did that happen? Why did that happen? It seems like it's linking to Google. Well, if you look at the code, if I go ahead and open up link.html, we'll see that here I have an anchor tag that actually links to the course website, but appears to be linking, the text that the user sees appears that it is linking instead to Google. And so this is a very common attack vector, especially in emails, for example. That you might see an email that tells you to click on a particular link, but that link takes you to somewhere else entirely instead. And as a result, someone might inadvertently share their bank account credentials or other sensitive information. And so here, too, something to be mindful of as you interact with the web, maybe not necessarily on your own website, but in other websites that you might interact with, just to be mindful about where links are actually taking you. And most web browsers, if you hover over a link, will show you where that link might actually be directing you to, because it might be different than what the text of that particular anchor tag might appear to link you to instead. And so HTML has all these various different vulnerabilities where, because you can just decide what you want the structure of the page to be, it leaves open the possibility that someone might try to trick you into thinking that you're going to a page that you're not actually on. And this problem is more widespread because anyone can look at the HTML for any page. HTML comes back from the server, and therefore the web browser has access to all of that HTML and can use that HTML in order to render a page, for example. And this leaves open other vulnerabilities too. So for example, let me go ahead and go to bankofamerica.com, just Bank of America's website. You can go to any other website instead. If I wanted to create a fake version of Bank of America's website, for example, to trick people into thinking they're going to Bank of America's website when really they're going to my website, well, then what I can do is just go ahead and view the source of this page. I'll go ahead and view page source. And here is all of the HTML for Bank of America's website. And nothing then stops me from copying all this content, going into an HTML file, and creating a new file that I'll just call like bank.html. And I'll go ahead and paste in the contents of that HTML file. So here then is all of Bank of America's HTML. And now if I open up bank.html, that HTML file that I have now written, but really just copied from Bank of America, I open it up. And now here on my page is a web page that appears to look like Bank of America. It's using all of Bank of America's HTML, but instead it is my HTML page and not actually Bank of America. And so you might imagine combining these to create an even more concerning attack vector, where instead of linking to google.com, let me try and link to bankofamerica.com. But where I'm actually going to link to is bank.html, my version of Bank of America's website, where now, if I open up link.html, here appears to be a link that links me to bankofamerica.com. If I click on that link, I get to a page that looks like Bank of America's website, but it's not Bank of America's website. It's my bank.html file that I have written that just so happens to look like Bank of America's website because I copied all of that underlying HTML. So HTML has the ability to describe the structure of our web page, but anytime you're writing this HTML, it's good to be mindful of this fact that anyone can copy your HTML, could theoretically pretend to be you. And these are security vulnerabilities that are worth bearing in mind as we start to develop web applications and interacting with web applications as well. So ultimately, we used HTML in the context of designing web applications using Django, a framework. And how exactly then did these web frameworks work in terms of creating these web servers that are listening for requests and that are responding to those requests? Well, ultimately, much of the internet is based around this idea of a client communicating with a server, or more generally, any one computer communicating with another computer using HTTP, and in particular, HTTPS, a more secure version of the HTTP protocol. And so you might imagine that what these protocols are really about is how information gets from one person to another and what we're storing with that information. That we have one computer trying to communicate with some other computer. And in order to do so, information is generally going to flow through these routers. That you might imagine information going back and forth between one computer and another computer, going through these intermediate routers along the way. And as a result, one thing to be cautious about is how do you know that this information that's getting passed back and forth is getting passed back and forth securely? That ideally, when I send a message to another computer, I'm sending an email to someone else, I'm sending a message, I'm making a request to a website that might contain sensitive information, like my bank account, for example. I don't want it so that any intercepting router that is taking my request and passing it along, I don't want those routers to be able to look at that request and see the contents of my email or the contents of what password I happen to be sending across the web or not. Ideally, I'd like for this information to be encrypted. And so here we'll talk a little bit about cryptography, this process of trying to make sure that I am able to communicate with some other person without some eavesdropper in the middle being able to intercept that message. Obviously, if I just take a plain text version of the message I'm trying to send, I just literally take the text of the message I'm trying to send and effectively pass it along across the internet, well, then anyone who is able to see that message is going to know what the text of that message is. And so I want to do some kind of encryption, some way of encrypting that message so that someone along the way won't be able to do that decryption if a router in the middle or someone in the middle is able to intercept that message. And so the first approach we'll look at is what's known as secret key cryptography. In secret key cryptography, I have not just the plain text, but some key, some secret piece of information that can be used in order to encrypt or decrypt information. And so I'll use both the key and the plain text to generate what's known as the ciphertext, the encrypted version of the message I'm trying to send. And then instead of sending the plain text across the internet to the other person, I might instead want to just send the ciphertext across the internet to the other person so that I'm not sending the plain version of the message across the internet. So the ciphertext goes across. And the other person will also need the key. And now if the other person has both the ciphertext and the key, well, then using that information, the other person can use the key to decrypt the ciphertext and obtain the original plain text. This key is what we might call a symmetric key encryption and decryption key. You use the key in order to encrypt messages, and you use the same key in order to do the decryption process. And as long as both I and the person I'm communicating with both have access to that key, well, then we'll be able to encrypt messages and decrypt messages. And someone who just has the ciphertext but not the key likely won't be able to figure out what that original message was. But there's a problem here, especially in the context of the internet, and that is that both I and the other person need to have access to this key. The key is what I use to do the encryption and the decryption. And I can't just send the key across the internet to the other person, because if I do that, well, then someone in the middle who's intercepting all of my requests could intercept both the ciphertext and the key, and therefore they would be able to decrypt the message because they have both the ciphertext and the key. Now, if I were able to go to another person in person and exchange this secret key in secret, well, then this scheme might work because we both have the key and I didn't share the key publicly with anyone who might intercept the message. Only I and the other person have the key. But in general, when communicating on the internet, you're not communicating with servers you've necessarily communicated with before. I might be trying to make a request to a new website, and we somehow still need to agree on a system where I can encrypt messages, but only the other person on the other side is able to decrypt those messages instead. So this kind of cryptography, probably not great for trying to initially try and create a secure connection on the internet. And for that reason, a major advancement in cryptography that allows for the internet to work is this notion of public key cryptography. In secret key cryptography, it's important that the key is secret, because if the key were known by everyone, well, then anyone would be able to decrypt messages. In public key cryptography, we're able to create a secure encryption system where the key is allowed to be public, or one of the keys, as we'll soon see. And the idea here is that we're using two keys instead of just one, that we have both a public key and what's known as a private key. The private key, your private key, is something you should not share with other people to keep the encryption scheme secure. But the public key is one that is OK to share with other people. And the distinction between the two is that the public key will be used in order to encrypt information, and the private key will be used to decrypt information that was encrypted by the public key. And the public key and the private key are mathematically related, and there are a couple of ways that we might imagine doing that. But the idea now is that if I want to communicate with another person, that person sends me their public key. And it's OK for the public key to travel across the internet. Anyone is allowed to see the public key because the public key is only used for encrypting that data. So I can then take the plain text and the public key and use that to generate the ciphertext, the encrypted version of the message that I am trying to send across the internet. And then I send the ciphertext to the other person with whom I'm trying to communicate. And the other person now, using the ciphertext, then uses the private key that they did not share, and the private key that has the ability to decrypt information that was encrypted using the public key. So using a combination of the ciphertext and the private key, the person I'm communicating with can decrypt that information and get back whatever the original plain text of that information happened to be. And so this then is how we can do a lot of this communication on the internet. By using this public-private key pair, we can say use the public key to do the encrypting, use the private key to do the decrypting. And now two computers that have never interacted with each other before without having the opportunity to meet to exchange some secret information can use a technique like this in order to securely communicate with each other, to send a message back and forth without anyone in the middle being able to intercept the message and identify what the message is about. And once you have this ability, the ability to communicate with another secretly, well, then you could imagine agreeing on some secret key and then using secret key encryption to be able to encrypt and decrypt messages as well. And so that's an approach that you can also take when trying to communicate with other people across the internet. But this idea of encryption is what allows for HTTPS, a secure version of the HTTP protocol, to actually work, to make sure that when you are communicating with your bank's website, for example, that someone along the way won't be able to intercept that information and identify what it is that you're communicating about, and instead only has the encrypted version of the information and a public key with which they can encrypt information, but not a private key that can ultimately be used in order to decrypt information as well. And so that then is how we might allow for this kind of secure communication on the internet and allow our web applications to be secure. But in addition to our web applications just listening for requests and then providing some sort of response, our web applications were also dealing with data. We introduced the idea of SQL data tables, where we had tables of data with rows and columns that are representing information. And we've also created web applications in this course where we've had applications that have users that sign in with a username and a password, for example. And so how might we represent that information about users and their passwords? Well, one way would be just to store it inside of a table like this. Here's a table of users. Every user has an ID. They have a username, and they have a password. But this turns out to be an incredibly insecure way to store passwords, to be storing passwords in what might be called plain text, just to literally store the passwords inside of a database. And we should never do this in practice because of the security vulnerabilities associated with it. If ever someone were to unauthorized get access to this database, they would be able to see all of the passwords for all of the users. So if this database ever leaked for whatever reason, suddenly all of these passwords are now known. And this kind of thing does happen, that if companies are not careful about how they represent usernames and passwords inside of their databases, and if ever there's some sort of database leak, suddenly a whole bunch of passwords could potentially be compromised. And it's for that reason that the recommended approach, rather than store an actual password, is to store a hashed version of the same password using a hash function, where a hash function in this context is some function that takes a password as input and outputs some hash, some sequence of characters and numbers in this case, that represents that particular password, a hashed version of the password. But the important thing about this hash function is that it's a one-way hash function. From the password, you can get to the sequence of letters and numbers, but it is very, very difficult to go the other way around, to use this information to figure out what the original password actually was. And so what this means is that the companies won't actually know what any particular user's password is. When a user tries to log in, what we'll do is take their password that they're trying to log in with, we'll hash it, and compare that hash against the hash that we've stored in the database. If the hashes match up, that means the user probably typed in their password correctly, and therefore we can sign the user in. And otherwise, that's a sign that the user did not type their password in correctly. So this then is the reason why companies, if they're obeying these best practices, usually can't tell you what your password actually is if you forget your password. If you forget your password, the company will let you reset your password. They can update the data inside of the table. But the company won't be able to tell you what your password actually is because the company doesn't know your password. The company only knows some hashed version of the password, some result of passing that password through a hash function. And as a result, they're able to know whether you logged in successfully or not with the correct credentials without actually knowing what your password actually is. And so this is another area where you might imagine that if you're not careful about how you're storing this data, it could be a security vulnerability inside of your program, where if ever that data is leaked, passwords suddenly become known. And there are other more subtle ways that web applications could potentially leak information that you as the web developer need to decide if you're OK with or not. Imagine a website, for example, where you do have a place where you can say if you forgot your password, you can be sent a place where you can reset your password, for example. You might imagine that if you type in your email address, click reset password, you might get a message like, all right, password reset email has been sent. But you might imagine typing in an email address and getting something like, error, there is no user with that email address. And here again is a potential security vulnerability in terms of leaked information. This page that just seems to send you an email if you forgot your password is now leaking information about which users happen to have accounts on your website and which users do not. Because all someone needs to do is type in an email address and find out whether it results in an error or not in order to know whether a user happens to have an account on the website or not. And maybe that's not a big deal if that's not something that you care about securing. But if it's a website where you do care about making sure that if someone has an account or doesn't have an account, that information is kept private and secure only to the user unless they want to share it, well, then this type of page, this type of interface with the database could potentially be leaking that kind of information. And information can be leaked in all sorts of different ways. You can even leak information just based on the time it takes for the database to be able to respond to a particular request. You might imagine if you make a request about a user and it takes longer to respond, that might tell you something about the number of database queries it needs to run or the amount of information that's stored about that user, as opposed to if a request takes less time. So even something like how many milliseconds it takes for a web server to respond to a request can reveal or leak information about the data that is stored inside of the database. And there have been examples of researchers who actually try and see what information they can get just from looking at these kinds of information that it doesn't seem like would leak information, but might actually reveal information as well. Now, another concern when dealing with SQL and databases we've talked about is the context of SQL injection, this threat where if you're not careful about how it is that you run your SQL code, you could inadvertently end up executing code that you don't mean to be executing. Situations like here, we're in a username and password field. We've seen this example before, where if a user tries to log in, you might imagine a query like this is run, selecting from the users table where username equals whatever was typed in as the username, and password equals whatever was typed in as the password. And we saw how for a normal user, someone who types in like Harry and 12345 as their username and password, that this type of query works just fine. But if a hacker tries to log into a website and maybe includes a double quotation mark and 2 hyphens, for example, where 2 hyphens mean a comment in SQL, and we were to literally substitute these values into our SQL queries, well, then you might end up substituting hacker hyphen 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 hyphen, creating a comment that ignores the rest of this query, effectively ignoring any kind of password checking that we might want our web application to be doing. So this, too, another vulnerability that comes about whenever we're dealing with executing SQL code inside of a database. And in order to deal with this, we want to make sure that we're escaping any of these potentially dangerous characters that might show up inside of our SQL queries. And Django's models do this for us. That when we do these kinds of queries using Django, saying like .objects.filter to be able to filter out for only certain versions of a particular model, it is going to take care of the process of making sure that it's not subject to these kinds of SQL injection attacks. But if ever you're writing a web application that is directly executing SQL code, which you might imagine doing, you do want to be careful about making sure that you're not exposing the application to be vulnerable to these kinds of threats as well. So that then are potential threats that come about when we're just talking about what's happening on the server. But we also can think about what might happen when we're interacting with other servers, when we're interacting with APIs, for example. And so we talked about JavaScript and using JavaScript to be able to make additional requests to APIs or to other services that are able to return back with certain types of information. And with APIs, there are a number of techniques that we can use in APIs to allow them to be more scalable, to allow them to be more secure. One is this notion of rate limiting, where we might want to make sure that no user is able to make more than a certain number of requests to an API in any particular amount of time. This is in response to a security threat that has to do with the scalability of a system, which is known as a DOS, or denial of service attack, where effectively, if you just make a whole bunch of requests to a single server over and over and over again, you could potentially shut down that system because you're making so many requests that it's not able to handle that many requests all at the same time. And for that reason, because it's so easy to make an API request. You can do so using just a single line of like Python or JavaScript, for example. APIs will often institute some kind of rate limiting to limit the number of requests you can make so that you're not going to overwhelm the server or overwhelm the database that needs to be queried in order to respond to those requests. And so this kind of limiting might work as well. APIs might also want to add some kind of route authentication. You might not want everybody to access the same data via an API. Maybe there's some sort of permission model where only certain users are able to access certain pieces of data from the API. So you might imagine that a user needs to have an API key, for example, effectively like a password that they need to pass around anytime they're making an API request to your API. And that allows you to then be able to look at that key and verify that they are who they say they are. Now, with those API keys comes other potential security vulnerabilities to be mindful of. One is that just as you should never be putting like passwords inside of your source code, inside of your Git repository, for example, you likewise generally shouldn't be putting your API keys inside of your web applications as well, inside of the source code of those web applications, because then anyone who has access to the source code for the web application can see what your API key is, could then use the API key to pretend to be you, and therefore get access to potential API routes that they should not be able to access. One common solution to this is to use what are known as environment variables, where effectively you and your program say that your API key is not going to be some predetermined string that is in the text of your program, but instead is going to be drawn from the environment in which the program is being run. And then on the server, when you're running the web application, you'll first make sure the server has all of those environment variables set correctly, so that rather than have the API key actually in the source code of the program, the API key is simply in the environment on the server where the web application is running, and the server can just draw that information from the environment so that it knows what the API key should be without the API key actually having to be inside of the web application source code itself. And so as we begin to deal with APIs, you might notice that many APIs will require you to have an API key. And often, it's for these sorts of reasons, to make sure that we're able to authenticate users effectively, and also to make sure that we're able to limit users to make sure that they're not making too many requests to the server or to the database at any particular time. But this then starts to get us into other potential vulnerabilities, in particular, vulnerabilities concerning JavaScript. JavaScript, again, is a programming language that we use in order to write code that runs inside of our web browser, a browser like Chrome or Safari or something like that. And as a result, JavaScript has a lot of power to manipulate things on the page. It can simulate the clicking of buttons. It can change the content of what happens to be on any particular page. And as a result, there are many, many vulnerabilities that come about when it comes to thinking about JavaScript. And one such vulnerability is this notion of cross-site scripting. That in general, when on your web application, you only want JavaScript to run if you yourself have written it. Cross-site scripting is a potential threat where someone else might be able to get JavaScript code to run on your website when it's JavaScript code that someone else wrote instead of you yourself. And this is a potential vulnerability because if someone else can write the JavaScript code, they can manipulate the contents of what happens to be on your website. They can potentially manipulate the user experience to get a result that is not actually desired. So let's go ahead and take a look at one example of cross-site scripting. All right, so I've prepared a web application in advance. It's called Security, inside of which is a single Django app called XSS for cross-site scripting. And inside of here, we'll first take a look at the URLs. So there's a single URL that just allows us to provide any path, and then it's going to load the index view. And on the index view, we're going to display an HTTP response that says, here was the path that just happened to be requested. So you might imagine this is a simplified version of what you might see on other websites, for example, where websites might show you on any particular page what path you're on in order to get to that page, some sort of indication of where you are inside of this web application. So I'll go ahead and cd into security and run the server, python manage.py run server. So I am now running the server, and I'll now go ahead and go into my web application /hello, for example. And so what I see here is requested path hello, which is what I would expect it to be. I can change it to something else like hi. So here's requested path hi. Here's hi/2, for example. Whatever page I visit it gives me a page that says requested path and then whatever path I happen to be visiting. But watch what happens if I try and visit this URL instead. I'm going to visit URL/script alert hi and then end script. So I run it, and suddenly an alert shows up on my page that says hi, and I press OK, and it says, all right, requested path. That alert was a JavaScript alert. It was JavaScript code running on my web application, but it was not code that was JavaScript code inside of my web application. It was someone else who wrote based on the URL to run particular JavaScript on my particular page. And so if someone linked to my web application and passed in this script tag as part of the URL, someone who clicked on that link might have been taken to my web application, but ultimately had JavaScript run that was created by someone else. And that ultimately is potentially dangerous. It leaves open the possibility that someone else could run JavaScript code on my page. And it might not just be something like a script. You might imagine someone not just displaying an alert, but modifying something inside of the DOM, changing the contents of the web page, making API requests, doing other types of tasks that you can do using JavaScript inside of a web browser that ultimately leave my page open to potential security vulnerabilities. And so these are cases where it's important to be mindful of when you're designing these pages. If ever there's a possibility that someone could inject their own JavaScript into your page somehow, you'll want to either detect that or escape it in some way, or take other precautions to make sure that this kind of cross-site scripting isn't going to be possible. You might imagine that in a messaging application, for example, if you're messaging back and forth, you don't want it to be the case that if you message someone else some JavaScript code, that when they receive it, that code actually ends up running as some JavaScript that runs on that particular page. You want to be sure to escape that information so that they just see the text of the JavaScript code, but that the code isn't actually executed. And this is a similar threat to that threat of SQL injection. It all comes back to the idea of not wanting to allow someone else to be able to inject their own code into your program. You don't want someone else to be able to inject SQL code into the queries you run on your database, and you don't want someone to be able to inject JavaScript code into your web page, because that leaves open potential security vulnerabilities as well. One type of security vulnerability that Django is quite good at defending against is one that we've seen before, but we'll explore in more detail how it might work. And it's this idea of cross-site request forgery, where you fake a request to a website when you didn't intend to actually make a request to that website. So you might imagine that if your bank, for example, had a URL that allowed you to transfer money from one person to another person. We've talked about this idea a little bit, but imagine now how you could implement this if it really was just a URL that you could go to like /transfer and say as get parameters, who am I transferring money to and what is the amount that I'm transferring. Then someone else on some other website could, in the body of their page, just have a link where that link says click here, and it links to yourbank.com or whatever your bank is, transferring money like to me in this amount. And if some user unknowingly just clicked on that link, not knowing where it would take them, this website might be able to forge a request to the bank, make it seem like the user had gone to the bank and tried to initiate some kind of transfer, and ultimately tried to transfer money. And it doesn't even necessarily need to be in a link. How else might you get some new request to happen inside of the web browser? You might imagine, though it might seem a bit strange, to put this inside of an image. Image source, the source of the image, is this particular URL, the bank's transfer page. Now, that doesn't really make any sense. The transfer page is not an image, but it doesn't matter. All an image tag is going to do is try to make a request to this source URL to get that image, and then try to display it in the user's web browser. But the first part is what's important, the fact that this source ends up being requested by the web browser. Without the user having to click on or do anything, they might try and request from yourbank.com/transfer this particular request, which might initiate some sort of bank transfer without the user even realizing it. And it's for that reason that we generally suggest that any time you're creating a website that is going to allow for the manipulation of some kind of state that allows for some change to happen, something like transferring money, you don't want that to be via a GET request, something that you could just load in an image or load by clicking on a link that takes you to another page. You don't want that to happen, because then it makes it very easy for someone else to fake a request to your page by just creating an image or linking to somehow a website like transferring funds from one user to another. So a solution to this, as we've talked about, is that generally we only want post requests to be able to manipulate something inside of the database, to be able to actually initiate a transfer from one user to another user. But even then, this is not perfectly secure, that you could still be tricked into submitting a post request. Imagine an adversarial website that had a form like this, a form whose action was yourbank.com/transfer and whose method was post. And now here are two input fields whose type is hidden, meaning you won't actually be able to see those input fields when the user is looking at the page. They'd only know about it if they inspected the source code of this particular HTML page. Here there's a hidden input whose name is to, meaning the person I'd like to transfer money to. Here's the amount, the value that I would like to transfer. And all the user is going to see is a button that says click here. They're not going to see either of the input fields because they're hidden. But if they do click the click here button, well, then suddenly they're going to be submitting a post request to the bank and initiating some transfer when they didn't intend to. Now, maybe this seems like, oh, it's not a big deal because the user still needs to click a button, and the user shouldn't be clicking on a button if they don't know what the button is going to do. Well, for one, it's probably reasonable to imagine that an adversary might embed this button inside of a page where it looks totally safe to be able to click on a button. But moreover, the user doesn't even need to click on it in order to submit the form. We can just add a little bit of JavaScript. You might imagine that an adversary could do something like this. Add an onload attribute to the body that says when the body of the page is done loading, go to document.forms, meaning all of the forms for this web page, get the first one, and submit it. Submit the form. And what that's going to do is, even without the user doing anything, even without the user clicking on the click here button, as soon as this page is loaded, this form is going to submitting a post request to the bank and attempting to transfer funds from one user to another user. And so this is what we might call a cross-site request forgery, where some adversarial website has forged a request to our website, and ideally we wouldn't like for that to be able to happen. So how did we guard against this? Well, what Django allows us to do, and a very common approach, is to add a CSRF token, a cross-site request forgery token that is going to be regenerated for every session, such that only if that token is present will the transfer be able to go through. So on our website, we can include the CSRF token inside of this HTML form, and as a result, make sure that we're able to transfer money only when the CSRF token is present. But if some other website tries to forge a request, they won't know what the CSRF token should be because it changes for every session, and therefore they won't be able to actually forge a request from one user to another. So all across the various different tools and technologies we've been using, Python, HTTP, Django, HTML, in terms of creating these web applications using JavaScript and the APIs that we might be interacting with. There are security considerations all throughout. We've only touched on a couple of them here, but just goes to show how it's important to be mindful as you think about the practice of web programming, thinking about what you're going to add to your web applications and what features your web application supports, to think about what the potential vulnerabilities there are as well, how someone might exploit your web application in order to do something with it that they probably shouldn't. And as you take your web applications from applications that are just running on your own local computer to applications that are running in some web server that many people are starting to use, these are the types of questions to start to be asking. How can you make sure that your web application is scalable? How can you make sure that your web application is secure? So now that we've explored a lot of web programming, what comes next? In this course, we've explored a number of different tools and technologies and languages, but there are many other web frameworks and ways you can build web applications as well. We spent most of our time looking at the Django web framework written in Python, but you can use other programming languages to build web applications as well. Express.js, for example, is a very popular JavaScript framework for building web applications. Ruby on Rails is a popular server-side web framework built using Ruby. And there are many others as well. And there are also client-side frameworks used primarily with JavaScript to be able to build user interfaces. We've seen a little bit of React to build dynamic and interactive user interfaces. Other popular client-side frameworks include AngularJS and Vue.js and a number of others as well. And then once you've built these web applications using any of these server-side frameworks and client-side frameworks, then you might imagine wanting to take these applications and deploy them to the web. And to do that, there are a number of ways we can do this as well. A number of different services, including Amazon Web Services, AWS, Google Cloud, and Microsoft Azure, that can be used in order to deploy these web applications. Heroku is a service that uses AWS and tries to simplify the process of making it easier to deploy your web applications. And if your web application is really just static, it's just HTML and CSS and JavaScript, well, then you can use something like GitHub Pages to be able to host a web application for free on GitHub's own servers instead. And there are many other ways you can imagine deploying web applications as well, different services that you can use in order to take the web applications that you have been building or web applications you might build in the future and make them available on the internet for others to be able to use as well. So as we look back on the various topics within web programming we've explored, we've seen a lot of tools and technologies we can use that we can leverage in order to build interesting web applications. We started by taking a closer look at HTML and CSS, diving into how we can use that to describe the structure of our page, and then taking advantage of tools like Sass that allow us to generate CSS that allows for much more complex styling for our website that would have been much more difficult to do with just CSS alone. As we started to build larger web applications, we took a look at Git, version control tools that we can use in order to make sure that we keep track of versions and changes we make to our code, allowing multiple people to collaborate on a project simultaneously. We then took a look at Python, looking at various different features that the language offered, functions and conditions and loops as we've seen in many other programming languages, but also object-oriented programming, the ability to represent objects and methods and functions that operate on those particular objects, which prove especially powerful in the context of dealing with data inside of our web applications. Django was the example of a web framework written in Python that we use to very quickly be able to start up a web application that's able to listen for requests and make responses. Django has a whole lot of features built in that really make it easy to get started with building a web application. And in particular, it makes it easy for writing web applications that deal with data. So Django allows us the ability to build models that interact with SQL without us having to actually write any SQL code. Django can generate the SQL for us just using these models. And migrations then allow us to continually apply changes that we make to our database. That as we add new tables, add and modify existing fields on those tables, Django can take care of all of that. After that, as you'll recall, we took our attention towards the second of the main programming languages in the course, JavaScript, which has a lot of uses and is very, very popular, but we primarily used on the client side to be able to build interesting user interfaces, using JavaScript to manipulate the DOM, the structure of the page, to change what it is the user sees, and also to add event handling so that when the user clicks on a button, when the user hovers over something, when the user interacts with the page in some sort of way, our code is able to respond to it. And we saw React, a web framework, a client-side framework that uses JavaScript in order to allow us to create really interesting and interactive user interfaces with not all that much code at all. And then finally, in these last couple of lectures, we've been looking at some best practices. How we can design tests that test the server, but also the client to make sure that our code is working appropriately, and also some industry practices like continuous integration and continuous delivery that just help to make sure that as we make changes to our code, we're able to deploy and deliver them rapidly and effectively, and make sure that we're able to make incremental changes to our code base rather than need to wait on longer release cycles. And then finally today, we've been talking about issues about scalability and security, especially important as we begin to take our applications and move them to the web. We want to make sure that these applications are scalable, that they're able to handle multiple different users, and also to make sure that they're secure, that we're not exposing ourselves to potential vulnerabilities like someone who might inject SQL or inject JavaScript code into our pages, or who might try to access some data that they're not supposed to access. We want to make sure that when we go about designing these web applications, we're able to do so in a scalable and ultimately in a secure way. So hopefully you enjoyed this exploration into the world of web programming with Python and JavaScript. Best of luck with the web programs that you yourself might build with the tools we've seen here today, and also other tools that are inspired by or use similar tools and techniques and ideas as the things that we've ultimately talked about here. A big thanks to the course's teaching staff and the production team for making this entire class possible. I look forward to seeing the web applications that you might go on to create. This was Web Programming with Python and JavaScript.